This comprehensive C# course will take you from the basics of C# programming to advanced concepts, all while integrating exciting mini projects to solidify your learning. This course offers a structured path through essential topics such as syntax, object-oriented programming, data structures, and more. Abba teaches this course, and he will help you understand C# both theoretically and also gain practical experience in applying your knowledge to real-world scenarios.
Hey there, freeCodeCamp, Abba here. Join me in walking you through everything you need to get set up with C#. Let's have a quick walk through the course content to let you know what's in store for you. We'll start with installing the Visual Studio program required to develop C# applications. You'll learn about data types including integers, strings, and many more, and how to manipulate them inside your code. Next, we'll dive into control flow. You'll discover how to use conditional statements and loops to control the flow of your program's execution. Strings are essential in many applications. You'll master powerful string functions in C#, allowing you to manipulate and transform text effortlessly. Data structures are crucial for organizing and managing data. From arrays to collections, you'll explore various data structures in C# and learn how to use them effectively. Functions are the backbone of any program. You'll uncover the power of functions in C#, including how to create and call them to organize your code. No program is immune to errors. You'll learn how to handle exceptions gracefully in C#, ensuring that your applications remain robust and reliable. Debugging is a crucial skill for any developer. You'll discover how to use Visual Studio's powerful debugging tools to identify and fix bugs in your C# code efficiently. Finally, we'll delve into object-oriented programming. You'll learn the principles of object-oriented programming, how to use classes, objects, inheritance, and polymorphism to create modular and maintainable code. By the end of this course, you'll have a solid understanding of C# programming and be well equipped to tackle a wide range of software development challenges. Thanks for tuning in, let's get started. So in order to start developing with C#, we need to install the latest version of Visual Studio. In this case, it's currently 2022. So let's head over to Google and type in Visual Studio 2022 download. We will be presented with two links. We have this one and this one. We want to use the second one which says download Visual Studio Tools. So if you press on that, and now we're presented with the download area. We have three editions: Community, Professional, and Enterprise. Community is free for students, open source contributors, and individuals, which is exactly what we need for the content of this course. We have the Professional Enterprise Edition, which are paid for and only used by bigger companies or smaller teams. So let's go ahead and press free download. The download will start straight away. After the download is complete, let's start the installer. So double click on the executable and press yes to allow it for admin permissions. It'll pop up like this: Visual Studio Installer. Before you get started, we need to set up a few things so you can configure your installation. You can read the privacy policy in the software terms if you'd like, or you can just press continue. So it's getting the Visual Studio installer ready. So when you get to this section, everything here is all the different packages and tools you can install within Visual Studio 2022. The main one that we're concerned with in the contents of this course is the .NET desktop environment, so you can go ahead and press this one. It will then tell you in the bottom right hand corner the total space required is 6.52 gigabytes. Please make sure you have enough storage space available for this, and then you can go ahead and press install. If you want to check out other packages, you can have a scroll through and read any other packages you may need and may want to install. Like I said, the only one required for this course is the .NET desktop environment. You can also deal with Node.js development, Python development, web development. If you need to deal with individual components like specific versions, you can access it here. If you need some more languages installed, you can access it here. This should automatically select your default language for you that's based on your system's language. And if you wanted to, you can also change the installation location in case you want to install it on a different drive or you just want it in a different folder. So now that we've selected the .NET desktop environment, we can go ahead and press the installation button. We do have two options down here. We have an install while downloading and a download all then install. If you have a reasonably fast computer, you can stick with the install while downloading and it will do the installation and the downloading at the same time. If you have a slow computer, it's preferred that you use this option to download it first and then install. It just means that it won't slow down your computer too much. So you can go for this one and press install. Now the installation will begin. So now that Visual Studio is finished installing, it will say done installing, Visual Studio has been successfully installed. We recommend rebooting soon to clean up any remaining files. So this just means restarting your computer just so it has a chance to clean up any files that were kept during the installation process. So we can just press OK. If you have any other versions of Visual Studio installed, they'll also show up down here. And now that Visual Studio Community 2022 is installed, we can just press launch. So now it will prompt you to sign into Visual Studio. We should definitely sign in, but just for now I'm going to skip, but feel free to create an account or sign in if you already have one existing. We can skip this and then we get to choose your theme. I personally prefer the dark theme, but you can go with blue, blue extra contrast, or the light mode. So let's select dark and hit start Visual Studio. It will do a first time setup, and it's already done, and we're already inside Visual Studio 2022. So that's it for the Visual Studio installation. So now that we got Visual Studio 2022 installed, let's see how to create your first project. So once you've opened Visual Studio 2022, you'll see this window popping up. You can clone a repository from things like GitHub and Azure DevOps, or open a project that you already have, or open a folder which may have projects inside, or you can create one from scratch. If you don't want to do any of these options, you can just open the Visual Studio program just on its own by clicking Continue Without Code. So let's go down the Create a Project path. So click on Create a New Project, and we'll get a list of all these different projects inside our system to be able to use. The ones we're going to be focusing on this course is going to be C# in the languages drop-down box, and the platform is going to be Windows, and the project type is going to be console. And they have one that uses .NET Core, which is for Linux, Mac and Windows, and one that uses the .NET Framework, which is Windows. So we want to go for this one. So press on this one and then press Next. Here we have our project name, our location and our console app. So we can start with the project name and say, My First Project. As you can see, it'll start copying it over to the solution name as well, and it tells you where the project will be created into. So it'll be creating a folder called My First Project, which is the solution name, plus My First Project, which is the project name inside that folder. If we change the solution name, you'll see it update. You can see here, now we have multiple T's because we appended the solution name. The solution name is almost like a folder that holds lots of projects inside. So to begin with, we'll have one solution that has one project inside, and then later on in the course, if you feel like you want to add more projects to it, you can just add more to this solution. So let's get started and press Create. So now we've created our very first project. And just to explain what's here, we have a static main void, which is the main entry point to our program. If you do a lowercase m, then the system's not going to recognize this main function because the .NET Framework requires this function to be found in order to run a C# console app. And you can see here in the errors, the program does not contain a static main function, and you can see it's capital M. And C# programming language is case sensitive, so make sure to include it. So now you understand how to use Visual Studio 2022 to create a project and also know where the main entry point is in C#, let's get started with a Hello World example to kick off this course. So as we know, our main entry point to our application is the static void main. If we go inside here and press enter, then we can actually start writing some code inside here. Just a quick note before we continue. Static void main is inside the class program, and the class program is inside the namespace hello world. And the reason why you can tell this is because of the curly braces. The curly braces of hello world begins here and ends here. And within these curly braces, we have a class program, and also within the class program, we have the static void main. So just between these curly braces, we want to type console.writeLine, open the brackets, and we can type in some speech marks, and we can simply type hello world. There you go. So as you can see now, system has actually been highlighted. So if we just delete this line, you can see now system has been grayed out. And the reason why is it says it's unnecessary because it hasn't been used. So if we undo it, then this comes up. Because I showed you before that console writeLine is actually within the system library, what happens if we delete it? If we delete it, then it doesn't know where console exists from. And because that just said system, we can actually just use system.console.writeLine and then open the brackets and type in hello world. And now this works again. And the reason why this works is because we don't have to define that we're using system, we could just use it straight in here. If you have multiple lines like this, then you don't want to be using system right at the start. Ideally, you want to have the reference to it at the top of the screen and then use it throughout. So now that we've included back in the project, you can see that now these have turned gray and it says that it can be simplified. If we press the little light bulb and we can say simplify member, and it doesn't really matter because we can just delete the rest now. So now that we've wrote hello world, let's press F5, which is a shortcut to the start button. As you can see, Well, you couldn't really see because the program closed too quickly. And the reason for that is it printed hello world to the console and then it didn't do anything else because there's nothing else for it to do, so the console simply closed. We can use another command called console readline, open the brackets and close the brackets and have a semicolon at the end. All this does is it waits here until the user inputs something, reads the next line of characters from the standard input stream. So although the program will actually be reading stuff, we just want this line to stop the application from closing. So now if we press F5 and run the program, you can see it actually says hello world and it's just waiting here flashing. And this flashing means it just started this console read line. So it doesn't matter what we type into here, it just waits for us to press enter. And as soon as we press enter, this line executes and the program finishes. Congratulations, you just wrote your first C# program. Welcome to the amazing journey of programming. So let's look at how to make variables in our C# code. Let's start every code with a console read line, and then we can hit F5 just to make sure our console doesn't close. So let's begin with an integer. So integers are whole numbers. So we can just say int age equals 23. So what we've actually done here is we've said we want an int, we want to call it age, already made it equal to 23. This is called initializing and declaring in the same line. So what you could do alternatively is you can end the semicolon here and it just says int age. And then on the next line you can write age equals 23. So this is declaring it in the first line and then give it an initial value in the second line. If they're right underneath each other like this case, then you may as well just make it together because then you have less lines of code. The reason why it says it's a green underline is because there's an unnecessary assignment because we're not actually using age. So let's just print age to the console. If we make some new lines and we can type in console.writeLine and then press tab to finish it, we can write age. And if we run our code using F5, we can see that 23 gets printed out to the screen. So now that we've worked on the age, let's explore other data types. So let's define a long variable. So let's start with the type, long, followed by a space, and then the variable name that we want. And let's add an equals and type in a very big number. So now if we hover over it, it says it's a system int32. And int32 is actually an integer, but we're telling it it's a long, which makes no sense. We have an int64 here, but when we hover over the number, it comes up as int32. And the reason for that is, when C# sees that you just have a number typed in like this, it will always assume that it is an integer. To tell the compiler that you indeed want this to be processed as a long number, then you can put a capital L right at the end. Now if we hover over it, it says int64, and this says int64. So now we've got it working, and we've got the long there. So now we can take another console write line and just print this out to the screen. And just a helpful tip, if you type in CW and press tab twice, then you get the console write line. It's very easy to write your code, and then you can type in big followed by a tab and it'll come up straight away. So as you can see, they're both being printed to the console now. So now that we've made positive numbers, we can also make these negative by simply just putting a negative sign behind them. There we go. And just to show you how big these numbers are, what we can do, we can type in int.maxValue and then make another one using Control D and type in int.minValue. So you can see integers can be positive 2.1 billion or negative 2.1 billion. And if we do the same for long, you can see that long is a very, very big number because instead of being an int32, it's an int64, which takes up a lot more memory. So now we've covered whole numbers, let's have a look at decimals. So we can have a double negative, for example, and we can say it's minus 55.2. And in this case, when you just have a number typed in like this, and it's got a decimal point in it, it will always register it as a double. But just to make sure, just as we're doing with the long, you can actually just put a capital D at the end. Now if we print this out to the screen, and also print out how big these numbers can be, max value and min value, and print this out. So we get our minus 55.2, and you can see that these numbers can be very big. E plus 308 means it's this number times by 10 to the power of 308, which is a very big number. And we also have that as a negative. So we have float, let's call this precision, and make it equal 5.00001 and then put a semicolon at the end. Now we've got a problem here. This is trying to register as a double, but we don't want to register as a double, we want to register as a float. And this is the same issue we have with long. So when you type any number that has a decimal point in it, the C# compiler will always register as a double. The same way when you type in a whole number, it will always register it as an int. So in this case, we need to put a capital F at the end, and it will process this as a float. So now we can print this out. And then let's just print out the max values and the min values just to show you what that looks like. So as you can see here, we have our number printed out. And again, we have quite a big number, 3.4 times by 10 to the power of 38. So again, it's a big number, and we have that positive and negative. So quite a big range of numbers. And the last one we're going to cover is decimal for things like money and currency, 14.99. And again, in this case, it's trying to assign a double into a decimal. So in order to denote what a decimal is, you can put a capital M right at the end. And for one last time, let's print out the money and the decimal dot max value, Control D, and then we'll do min value. And you can see here that this is a really big number as well, and it's even bigger than the long. So we have our number printed and the max and the minimum values. So now that we've understood that how to declare a variable, I have an extra little tip for you. So if we had three variables, int x, an int y, and an int z, and let's say you're always going to declare them together like this, you can actually miss out and do x, comma y, comma z, and that will do exactly the same thing. There we go. And that's really neat, and it's a lot better. But let's say, for example, you had these variables, but you actually had them set to something like equals 10, equals 20, equals 30. This is still practical, but it might look a little uglier. So you can actually type them in straight into here. And if you comment these out again, then it still works. You can even put these onto new lines like this, just so it looks a bit neater. It just prevents you from typing the additional int each time if they're all going to be the same variable type. So that's it for the numbers inside our code. So let's just have a quick recap. So in order to define a variable, you want to use the data type, in this case an integer, followed by the variable name, and then you can either add a semicolon at that point, or you can add an equals to give it a value. This is just called declaring a value, and this is called initializing a value. If you want to decide you want to change the variable further down your program, for example, age equals 50 here, then this is fine, and this is now called an assignment. It's called initialization because as soon as you make it, you give it a value, and then later on in the code, if you give it another value, this is called simply assigning a value. This is just called assigning it a value. So now that we can store numbers in C#, let's see how we can store characters and letters. So as you know from the introduction, we have a string variable. So let's call that name and make it equal to ABBA. Please note that when you're defining a string and giving it a value, that this value needs to be in speech marks. If you put it in quotation marks, it will not accept this, because that's the notation to declare a char, which we'll get onto next. So in the next line, we can do a char letter equals, and we can't have something like this, because the char will only accept one singular character. So we have to wrap it around the quotation mark. Once you've wrapped it around the quotation mark, then it will accept it. So let's print these two to the screen. So CW tab tab, and we can just print these to the screen. And if we just run the code, you can see that we've got the values entered in here. And we can start to write stuff. Your name is, and then we can output this, and we can also put it on one line. If we do a console write and a console write, then maybe we can take the colon off and just have it a space, and we can say your name is ABBA. And we've seen that additional A because that's the write line for the letter. So we can space it out with an empty console write line, and they'll add a gap between them both. There we go. So now we know how to declare a string variable and give it a value, and we can declare a char variable and also give it a value. Just a quick recap, when you're declaring and initializing string variables, you need to put the value in speech marks, but when you're declaring and initializing a char, you don't have to put it in speech marks, you put them in apostrophes. Whenever you see apostrophes, that can only ever refer to one singular character. When you see a speech mark, it could be one or more characters. Also, things can be empty. This just means the string is empty. This is also a valid character, it just means that we're storing a string but it has no value. With a char, that's not exactly the same. You can't store an empty character literal, it has to be given something. Chars get defaulted at \0, which is just the default character. But don't worry about that too much now, we'll go into escape characters, which is the / later on in the course. For now, just note that whenever you declare a string variable, we need to put it in the speech marks, and when we're declaring a char variable, we need the quotation mark. So now that we know how to define numbers in C# and to also define strings and characters, then let's look at how to convert between them both. So let's take some similar code from our first video, and we can define an age, the number, the negative, the precision, and the money, and we give it the same values from the first video. We simply just print them out to the console here, and if we just run, we can see them all. But this doesn't help us because we're just statically typing in the numbers. What if these were actually processed as string and we want to convert them into an int? So just above each of the variables, we're going to make another variable. So we can say a string text age equals -23. And then for the age, what we're going to use is this function called convert to int32, and we can put in the string inside the brackets. And what this is now saying is we're taking our string text age, which is equal to -23, and we're passing it into this function convert to int32. And the reason why it's int32 is because an int is by definition an int32, which is a 32-bit signed integer. So what we want to do here is convert for our text age into an int32 and store it back into our int, and hopefully we should see the same value when we hit run. 23. So now that's actually went from a string variable and then went into our integer, and we've printed it out as an integer and it's no longer a string variable. Now we can do the same for the other ones. So we can have a string text big number and make it equal to this value just in the quotation marks. Now we're typing this value in the quotation marks, we don't need to put the L at the end. The L is just to tell the compiler that we want to use int64. If we take the L away, then it's going to think it wants int32. This is not really applicable when it comes to text, because we're going to explicitly say on the next line, we want to convert to int64, so the compiler already knows that it's int64, and we don't need to put an L at the end. Now let's make sure this works, and there we go. So what we should end up with is the console should look exactly the same as how we had it at the start of the video, but actually what we're doing is converting it from a string into the applicable value. String text negative equals -55.2, and then in here we can do a convert to double. Add the text negative inside here, and let's just run it to check, and we still have the same value, so it's going well. We have a string text precision, make it equal to this, and then instead of this we can have a convert to, in this case it's actually going to be a single, and the reason why it's a single, when you hover over float, the definition for a float is indeed a single. So we can add that in, text precision, and we're just going to do the last one and just check it all together. Text money equals 14.99, and then instead of this we can have a convert, and let's have a look at this. A decimal is indeed a decimal, so we can say 2 decimal, and then add the text money in. Perfect. So now if we run the line of code, we can see that all of these values are exactly as we had them. Now they're being represented by their official descriptions based on a string conversion. As I mentioned before in the error video, the problem you'll have with this is if this value actually has a character inside, you will get a runtime error. This can be fixed in the future when we look at how to resolve these errors, and we can have exception handling and use functions like TryParse so we can try and avoid these exceptions occurring. Because when these exceptions occur, the rest of our code does not run and it becomes fatal at this point. But for now, don't worry about this too much, just get used to the notation and how these things work. So this video we're going to focus on the Boolean data type. So we can make a Boolean data type by saying bool value equals true. This Boolean value is literally just a true or false value. We can store anything in here, and maybe something like bool is male, and we can just say true. And later on in our code, Booleans are used to make decisions. We'll cover this in the next section of this course, but Booleans are mainly used for making decisions. If one thing is equal to another thing, then we can take another path, or if something is true or something is false, then we can do another path. Like for example, if you make an output to the user, you could check if this value is true, and if the value is true, then you can address the user as a male, and if the value is false, then you can address the user as a female. These are the kind of things that Booleans can help us with. And just like any variable, if you want to assign it later on, you can just assign it again. And if we print these out to the screen, just like that, you'll just see the values true and the values false appear on the screen. As of right now in the course, there's not a whole lot to do with Booleans, just understand that they can hold a true or false value. So now that we know how to define different variables and how to convert between them, let's see how we can perform operations on different data types. Let's say we could have an int age equals 23. And then what we can do to that age is we can say age plus plus. And what this age will do is it will actually just increment age by 1. And if we do age minus minus, it will decrement it by 1. So if we just print it out after, and after this as well, what we'll notice is there'll be no change because it'll go forward 1 and then back 1. There we go. We went from 23 plus plus to 24 and then minus minus to 23. That's one of the important operators that you'll see a lot, especially during the next section of this course. So another way to be able to add 1 to a variable or anything to a variable, we can replace this with age equals age plus 1. And what we're saying here, we want age to have the value of itself added to 1, which will give us the same result as doing age plus plus. Another way of writing this as a quick shorthand is you can say age plus equals 1. These three things are doing exactly the same thing. When you do an age plus plus, you can only increment by 1 and only 1. These two options give you the flexibility of having something like 10. These two are doing exactly the same. Age equals age plus 10, and this is going to read exactly the same thing. It's just when you use plus equals, it will take the value of the current variable and add it to 10, which is exactly what this line does. To make it a lot shorter, you can use age plus equals and then just put the value at the end, just in case you forget to mention age twice. So now if we just get rid of these two lines of code, and we can just have a look and see if this runs. So now the value should be 33. Perfect. And now, as we said, we're going to cover plus, minus, times, and divide. So just as you did with plus equals, you can actually do a minus equals as well, which will give us 13, and you can do a times equals, which should give us 230. Now, if we try to do divide equals, we're going to run into an issue. It says 2. 23 divided by 10 is 2.3. And when you take 2.3 and make it into an integer, it's just going to truncate the 0.3 and leave you with 2. With integers, if you add two integers or take away two integers or times them, you'll always end up with an integer. If you divide two integers, you don't know what you'll end with. For example, if you make this into 20, then you'll always end up with 2. But that's not always the case. As you just saw, 23 divided by 10 is 2.3. So if you're ever going to do any division, it's best to actually make this a double. Because now that we do the division, we actually get 2.3, which is technically the right value. So you can add minus, times, and divide any variables that you want. These are just demonstrated in int and double, but you can do this with the float, the decimal, etc. So let's have a look and see what the plus and the minus operators do when you've got a string variable. So we can have a string name equals Abba. And then we can say the name plus equals is programming. And then we can just print our name to the screen and see what happens. So there you go, you've actually just joined two strings together. They're completely separate from each other and we've made them string together. So if we try to do a minus equals, you can't really remove from a string because a string is just text. It'll be very difficult for the compiler and for the C# language to be able to determine what's currently in the string and whether you can remove it or not. This is not something that's built into the language. So let's remove that and we can have the same thing with a char. Now the problem with a char is if we add A to B, then let's see what happens to the output. What it will try and do is actually get the Unicode values for both of these items and try and add them together as integer variables. So when you add A and B, it will take the Unicode value and you will actually get a capital A with a squiggle at the top. And if we open character map, you can see that this squiggle at the top is right here. A, which is Unicode 61, and 61 actually means 97 because it's 6 times by 16 plus the 1. And B means it's 6 times 16, which is 96 plus the 2. So you have 97 and 98. And if you add them two values together, you'll get the hex code, which is C3, just for this character. So what you're doing is you're kind of adding them both together and you're producing weird results. So unless you really want to do this, then you should be wary about adding two characters together. One more thing to note about when you're doing plus plus, so let's bring another int variable back. And we just say int I equals 0, and then we can do I plus plus, and then if we print out I, the value should be 1, which is fine. What if we did I plus plus, but we did plus plus I? So the value is still going to be 1. But what happens if we put this I plus plus straight into these brackets? Let's try and run it, and you still get the value as 0. That's strange because we've said I plus plus. And what happens when you do plus plus at the front? It will actually execute this and return the value of I and then do the plus plus. So if you actually print the value of I after, you'll realize that now it becomes 1 after. If you ever had a situation where you need to increment first and then use the value, you can use plus plus I. And now if we run it, you should see the value is 1 twice. The difference is that as the plus plus is before the variable name, it tells the compiler, please do this action first and then return back the I. If you don't want that behavior, then use I plus plus. Finding the remainder between the division of two integer variables can be very handy when you're determining whether a number is even or odd. Let's look at an example. Let's have an int first num, assign the value of 10, and int second num and give it the value of 3. Now if we just print to the screen first num divided by second num, what do you think you'll get? So the value of this in the calculator will be 3.3 reoccurring. So we'd actually just get 3 because it's truncating it because of the integer. So now what happens if we need the remainder between both of these? You could actually work this out by seeing how many times that 3 would be divided by 10 as close as possible, and you'll see the value is 3, and then 3 times by 3 is 9, which will give you 1 left over for the 10. But that's a bit too long in our code, so we have something called a modulus operator. So we can actually change this divide for a percentage sign. And what this will output is it will only give us the remainder. So let's say 10 divided by 3 is 3.3. As we've just said, but the remainder is different. Remainder is exactly how you learnt it at school. 10 divided by 3 is actually 3 remainder 1, because 3 times 3 is 9, and then you have 1 left over to get to 10. So that'll be 3 times 3, which is equal to 9, and then 1 left over to get to 10. So now let's run our code and see if we do actually get 1. There we go. So the best way to determine if a value is actually odd or even is to divide it by 2. So we can say 10 modulus 2, and if the value is 0, then that means the value for first num is actually even. If the value is 1, then it's odd. And let's see how this works out. If we had 10 modulus 2, then the value is 0, because 10 can be divisible by 2 perfectly. But let's say we had 11 modulus 2. The closest multiple to 11 is 10, which is 5, and then we have 1 left over. So you just have the remainder is equal to 1. And if we just keep going up in the chain, we'll realize that it's the same pattern. Every single time you go up a value, the value just toggles. So when we print this out to the console, and the value is actually 0, that means the number is even. And if we make the number odd on purpose, and then rerun the code, you can see that it's a number 1 now, which means this value is now odd. So let's look at a couple of examples and see if you can figure out the answer. If we do 1000 modulus 90, what do you think the value will be? And let's write a couple more. If we do 100 modulus 90, and maybe something like 71 modulus 10. So have a think about this in your head and see if you can figure out the answers. Pause the video and see if you were correct. Let's take a look at the answers. So we can see we have 10, 10, and 1. So the closest multiple to 1000 from 90 is 990. So we have 10 left over to get to 1000. And the same goes here. The closest multiple of 100 to 90 is just indeed 90. So we only have 10 to get from 90 to 100. And in this case, the closest multiple of 71 to 10 is 70. And we have 1 to get up to 71. Therefore, these two answers are indeed correct. So now that we know how to really define a variable by specifying their type followed by their name and giving it a value, let's see how we can do a very easy way of defining a variable. So normally we would type int age, but we can use this var keyword. And what this means is the compiler will figure out what type it needs to be based on the value we initialize it with. So if we just make a variable called age, then it's not going to like it because you need to give it a value. This doesn't give the compiler enough information to figure out what this variable is going to be. Just because it says age, this is just text to the compiler. This does not mean anything. So if we make it equal to 23, then the compiler can see that this is indeed int 32 because it knows that. So now if we hover over var, it says int 32. Now let's try and do this for the big number. Var big number equals 90,000. And what will happen now is because it's defined as int 32, it's going to say this is int 32 as well. And this is the same issue we had when we were first defining the long variable in the first video. We need to explicitly give it an L just so this knows that it's int64, and now the var has updated to an int64. Instead of rewriting each one, we can just change these to var and inspect what happens. Double, double, and now we have a float, single, single, and finally the decimal. We have a decimal, and we have a decimal. And the same thing goes for a string. We can say var name equals ABBA, and we can have a var letter equals A. There we go. And they'll both register as their applicable data types as a string and as a char. And if we just print this out to the screen to make sure everything's working fine and run the code, you can see that everything is exactly how we'd expect. So just a quick recap. You don't have to do this. At the end of the day, this will be exactly the same as writing this, because when our code gets compiled down, it doesn't matter what these things are because the compiler will deal with it however way it wants to. This is just for us to read it. In some cases, if the value is very obvious, like as we know, an age cannot really be a point, 23.1 years old. No one says that in real life when you get asked your age, so we can just assume that this value is going to be an integer. And that's fine because that's an easy number. That's an easy example. But if we say we want a negative or a big number, then it doesn't really tell us what we're meant to be. Like this big number could be somewhere up to 2.1 billion, which is what an integer supports. But in this case, if it's going to be a big number and we specified a L, then we're going to need a really big number, bigger than 2.1 billion. So in my honest opinion, it'd be very beneficial to only use var if it's very obvious what the variable is going to be and what it's being assigned to. Using var too much might hurt the readability of your code in the future, because you'll have to inspect each variable individually to read what the type is going to be. If you're scrolling through your code and you can see that this is long very quickly, and you don't have to hover over it, then it can improve your read time. This is really important as readability of code will make more sense when it comes to big projects. When you have 20-30 lines just like this project, then it makes almost no difference because it only takes a couple of seconds. When you have big functions and big software, when you work at a job, then it's going to be very difficult to be able to find your way around and to understand what's going on, especially if you're new to the code. Something very simple like this, where you know you're defining a name, it's very obvious and var will be accepted. Fine, because you can tell that this is always going to be a string. There's no other data type in C# gets specified by a speech mark. Whereas when you're defining numbers, it can be very, very hard to understand what different data types that people are using throughout the code. Especially when these numbers are not statically typed in, they might be inputs from the console, from the user, from a different function, from anywhere. So having good variable names along with their explicit types will be very handy to understand code in the future. So now that you've understood how to make a variable, let's look at a concept called constants. So if we defined a variable called VAT and we set it to 20, just to represent the 20% VAT in the UK. Now later on in the program, we can actually change it to anything we want. And that's because it's a variable. Variables can change. In certain circumstances like VAT, you might not want to change it and you want to disable the ability to change it out the code if it's done accidentally. Let's say for example you're making a banking application and you wanted to fix the VAT. and you don't want anyone else to change it. You can add this keyword called const right before the declaration. And now when you go to reassign it, you'll get an error message. And it says at the left hand side of the assignment, so anything before the equal sign has to be a variable, property, or indexer. And in this case, if you hover over VAT, it states that it's a local constant. Local because there's no access modifier before it, and constant because we specified the const keyword. So now if we try and run the code, we'll actually get a compile error because the VAT cannot be changed. So if we remove that and then we just print it out to the console using CW tab, and then we can put VAT in the brackets and press F5. And now we can see our 20 being printed. So let's try and calculate some values using this code. If you have an int balance, make it equal to 1000, and let's say we wanted to calculate the VAT based off this. Then you'd have to do a little bit of a complicated calculation. You have to take the balance, and because the VAT is a percentage, we need to convert it from decimal to percentage. So if we do times and then open the parentheses, we can insert VAT divided by 100. And just to make sure that this gets processed as a double, we want to write 100D because right now it's in 32. And if we leave this as an integer division, then we'll lose any decimal places, and decimal places are very important when it comes to percentages. So we put 100D at the end. Now you can see it says double, so it'll actually calculate as if it was a decimal number. So now if we print that to the screen, so we can see here that 20% of the balance is indeed 200. Instead of having to do this calculation each time, what we can actually do is make another const, this time making it a double because we're not sure what the output of this division will be and we don't want to truncate it, so we want it as a double, and we can say %VAT. And what we can do here when we assign the value, just because it's a constant, it means that we can't change the value. But that also means we can read it as many times as we want. So we can say the percentage VAT is actually the current VAT that we've got, specified here, divided by 100D. This will give us the VAT from a number form into a decimal form. So now when we do this calculation, if we duplicate this line using Ctrl-D, we can remove these entire brackets and literally replace it with percentage VAT, and you should see we get the same values. Perfect. This can be very helpful in the future if you have things like version numbers in your code, and you can have version 1.0, and then if you ever specify this version later on in your code, you can just change it once up here and it will change the rest. This can be very helpful. You'll avoid a lot of typos and you won't have to redeclare this value several times. If you had 3 different occasions where you were displaying the version number in your code, then it's going to be problematic once you update the version number and you have to change every single occurrence and you might miss them. So inserting it once and only having to change it once is the preferred option. Just to note with constants, when you compile your code, all the constants will actually do is do a find and replace, so it will take this VAT and find all references of VAT and just drop the 20 in there. So this is more of a feature for maintaining your code from a user and programmer's perspective rather than anything to do with the compiler, because when it compiles, it just removes all the constant anyway, and then you're left over with the literal values that we've gave it. Nonetheless, this is still something very handy to learn and to use throughout your code. First, you want to define a variable to hold your name. So we can just say string name equals ABBA. Perfect, so that's the first one achieved. It says define a variable to hold your phone number. So at first, this could be quite easy. We could say int number equals, and then we can start to type our number in here. So now that's our number completed, let's move on to holding your age, and we can just have an int age equals 23. Print variables line by line to the screen, so we can use CW tab and type in name, and then we can use Ctrl-D to copy and paste the line, then we can do number, Ctrl-D again, and then we can use age. Now if we run the code, let's see what happens. Here we've actually hit a slight problem. It says 1, 2, 3, 4 for the number, but I'm pretty sure that I started it off with 0. This is a problem with storing your number as an integer. As a number, zeros at the front don't really matter. If we had 100 zeros here, then it's not going to change the actual value. The only time zeros matter is if it's throughout the number or towards the end. That actually changes the number. But if we have lots of zeros at the start, then it doesn't change anything. So what you actually want to do in order to store a number is you want to store it as a string. Therefore, when you run the code, it will actually return the 0 that we typed in. So now that we've accomplished all of these, let's see how we can define the variables using the var keyword. So if we hover over these, you can see that it's picking up that it's a string and a string here. And finally, this is an integer. So what we can do very simply is just change these to var, and then let's hover over the variables and just see if the tooltip reads the correct data type. String, string, and integer. And if you run the code, you should see no difference. So in this exercise, I want you to create and initialize two integer variables, make a variable to work out the remainder, output the remainder to the screen, and then change the first integer variable to another number, recalculate the remainder, and output the new remainder to the screen. So let's take this step by step. So first we need to create and initialize two ints. Let's say int num1 equals to 10, int num2 equals to 2. Make a variable to work out the remainder, so we can have an int remainder equals 2, and if you remember how to do the remainder, it uses the modulo symbol, which is the percentage sign. So we can say num1 percentage num2. Now it says output remainder to the screen, so we can use cw tab, add remainder in, and hit run. And just for now, we can see that the remainder is indeed 0. If the remainder is 0, then that means 10 is even, because 10 modulus 2 gives us 0, and if it's 0, then that means it's even. If the remainder was 1, then it would mean it's odd, so if we try 11 remainder 2, we get 1, so 11 is indeed an odd number. So let's change this back to 10, and then it says change the first int variable to another number. So just after here, we could say num1 equals 11, and then recalculate the remainder. So we essentially just need to do this section again. We don't need to write int before these two variables, because int is only used when you're declaring it. This is reassigning the variable. So we'll reassign variable num1 to 11, and then we reassign the remainder to the calculation again. And now we can use the exact same line of code above to print out the remainder to the screen. Now you can see that it's 0 and 1. It's 0 because 10 is even, and it's 1 because 11 is odd. So far throughout the course, we've been using console writeline to output stuff to the screen. For example, I can output hello, my name is Abba, and we can see it in the console. The issue is so far, we haven't really wrote any code to be able to read in values from the console. So let's explore that option right now. So in the console library, we have a console writeline. But what you don't realize is we can also use this console writeline to ask the user a question and to let the user type something in. So let's use cw tab and say enter your name with a colon and then end the quotation marks. And then in order to return a value from the console into your program, we need to use console.readline. And if you hover over readline, let's have a read at the description. Reads the next line of characters from the standard input stream. Perfect, this is exactly what we want to do. Right now it's used at the end of our code just to stop the console from closing so we can actually see the output. So if we just run this right now, we actually get the opportunity to type, but when we press enter, our program closes. This is because in this case, we're simply using readline just to wait until the user has pressed enter so our program doesn't close. But what you don't actually see is this is returning as a string, which means that anything that we type into here, and when we press enter, it actually gets returned back to the code, but we're not doing anything with it because we don't care at this point. So now let's actually do something that will make us care about the user's input. So we can make a new string variable and assign it to console readline, and it should give us the ability to store whatever gets entered inside the console. So we can just do string name, and we can end the semicolon here, and if you wanted to, on the next line, you could do name equals console.readline. Or if you wanted to have it all in one line, then you can get rid of the semicolon and bring it up like this. This is the preferred method, as both lines were on top of each other and it wasn't really necessary to split them. Here we're doing a declaration of string name and an initialization and giving it the value of console.readline. And this is whatever value the user is going to type in. Let's run our code and see what happens. Enter your name, Abba. Now when I press enter, it successfully stored Abba inside this string name variable, and now it's waiting at this line, the console read line, just right here, so when I press enter, the program closes. So now that we've made a variable and not done anything with it, let's print it out to the screen to make sure that something's actually worked. So if we use cw tab and we type in name in the brackets, and we can run this code again, and let's see what happens. As soon as I type in ABBA and press enter, then this second ABBA is actually the variable printing out to the screen. So here it says enter your name with a colon, and normally when you see the colon, it sometimes lets you type on the same line. So if you'd prefer the user to type on the same line, then we actually have another function for that. Instead of using writeLine, we can just use write. And the difference between writeLine and write is the writeLine will actually have a terminator at the end of the line to tell the console that it wants to push everything after it onto the next line, whereas console.write will just print it out to the screen and not worry about any new lines. Let's try run it now. And now we can type in ABBA. As you can see, it's a little close to the colon, so we can fix that in a second. So if you press enter, you can see now that ABBA comes up on the second line. So if you just put a space after the colon just to give it a bit of room. Now if we type in ABBA, you can see that there's a bit of a gap and it's quite nicer to look at. Now if we press enter, you can see that ABBA has been stored successfully. So what we can do now is maybe ask for your age. So we can have a console.write, enter your age, colon space, and then do a string age equals console.readline, and then we can have a age output as well. And let's see how that works. So we can say ABBA, then say 23 and press enter. And now we have ABBA stored within the name variable and have 23 stored within the age variable. So let's try and output a string that's a bit more meaningful to the user. Let's clean this console up and see what we can do. So we don't need to output their results back to the console because they literally just type that in. And we don't want to have this line because we just use that as an example. So if we run the code right now, it'll look better. But it does look a lot more structured. Enter your name and then enter your age. So now when we press enter, the program will just close. So let's try and output these two variables in a formatted fashion. So as you now know, we can use console.write to print a lot of stuff on one line. So we can use console.write and we can say your name is, and then add a space and finish that line there, and then duplicate it down. We can write name, duplicate that down and say space and your age is, duplicate that one down, and then we can type in age. And let's see what happens now. ABBA 23. There we go. So we actually have the name output and the age output all on one line. If we all change these to right lines, then they're going to be on separate lines and it's not going to look very nice. So I'm just going to introduce you to a notation called string concatenation. This is the notion of being able to concatenate two different strings, which just means to add one string onto another. As you can see, this is taking up 4 lines of code and it's getting a bit ugly. The better and easier way to do this is by containing it all within one line. So we can have a console write line, and we can take the first section, your name is, keep the space at the end, we can end the speech marks and put a plus, and then we can say name. So now we've just added these two together. If we just comment out the rest of them and run the code, and you can see that they should be on one line. There you go. So we can say your name is ABBA, and let's just keep chaining the plus symbol. So we can say and your age is, another space, end the speech marks, and plus the age. Now we've got all of this contained within one line, and it looks a lot better. Enter your name ABBA, enter your age 23, and now you can see exactly the same output, but reduced to one line. As you can see, these 3 lines are all stuck to each other. So if you wanted to add a blank line between these two, you can just put an empty console write line just in here. And what this will do is simply just print the write line character to the screen, which will force the console to make it on the next line. Just like so. Here's the console write line from the empty line that we just wrote, and this is the console write line to output the values. So now that you've understood how to read values in from the console, let's try and convert some values. As I showed you how to do it earlier on in the course, you can actually convert these strings into integers. Ideally, you want to store variables in their data types. As we covered before, ages should not be stored as strings, they should be stored as integers. But if you try and change this to an int, then you're going to have an issue. Console readline will return back a string, so therefore it can't implicitly convert from a string to an integer. So we need to do this in 2 steps. We can rename this to age input, and then on the line underneath it, we can say int age equals convert to int32, and then add age input in these brackets. There we go. And now when we actually print the line of code, nothing should actually change. Your name is Abba and your age is 23. But now what's actually changed is we're storing the variables in the correct format. This is the ideal method because in the next section when we cover if statements, you'll realize why this is very important. If you wanted to minimize the amount of steps you need to convert this, then you can actually move the console read line and get rid of the string input variable, and we can just paste it straight into the bracket of the convert to int32. And you can get rid of the string input variable and everything will work the same. Abba 23, and now it's working exactly the same. If this is too many steps for you or if this looks too complicated, then just please revert it back just to keep it the same way for the time being. So now we've learned how to read in values from the console and output them back to the screen. Now let's see how we can use if statements to divert our code into multiple paths. So in the previous section, I told you that it is very crucial for our code to have this int age. And the reason why is age is meant to be stored as a number and not as a string. So we read it in first as a string and then convert it to an integer using this function and store it into our age variable. This is the reason why. So our condition goes as follows. We write the word if, and between the brackets, this needs to be evaluated to either a true or false value. And then we can have the curly braces to tell us what to do if this becomes true. So in this case, you want to just check if our age input is greater than or equal to 18. Let's say this was an entrance to a place that only allowed over 18s to enter. So we can do age input, which references the age input variable, and we can use the operators equals, greater than or equal to, less than or equal to, or not equal to. So these are all the different options that we have. We can say if the age input is equal to 18. Perfect. So now that we've read in the age input, we can check if it's 18. Let's just process a message in here that says, you are 18. And let's have a look and see if this works. Abba, 18. Now I press enter, it says you are 18. But this is the problem with storing everything as a string and then trying to use it as if it was a number. If I type in 18 followed by a space, as you can see there's a blank space here now and press enter, you can see that it doesn't come up. And the reason why is it's processing it like this, with a space at the end. In order to avoid situations like this is why we would convert it to a number. And the reason why we're using equals to here is we can't use greater than or equal to because strings can't be greater than or equal to another string. They can only ever be equal to or not equal to. String is just text. So if something equals to something, then it's fine. The only way that we can use these different operators is if we actually interact with our integer variable. Now let's see how we can use this. So we can say age equals 18, and now you can see we actually reference it as a number. Now let's run the code. If I do 18 followed by a space, it still works. And the reason why is it actually dismisses that space when it's converting it to the integer. So now our age is stored as an integer and we can actually manipulate this a bit better. So instead of saying you are 18, we can say you are 18 or older. And now instead of doing equal to, we can have greater than. If we have greater than, then we're actually dismissing the number 18. Because if the age is greater than 18, so this will read like this. And 18 is not greater than 18, so this will return back false. What we actually want to use is greater than or equal to. If the age that we've inputted is greater than or equal to 18, then you are 18, hence the equal to, or greater than if you're older. So now let's try and run this. Abba 23. Perfect. You are 18 or older. Let's change some other if statements to add some additional conditions. So we can say else if, and the only reason why it would come into this bracket, if this condition returns false, it will move down the next condition in the else chain. If this was wrote as a separate if statement, then this would run completely independently from this one. If you're going to have chained if statements, you need to make sure that you chain them correctly. In this case, I want to check if it ages between 18 and 25, and then move on to a different age bracket. And these two things are grouped together, so we should have this as an else if. Because with an age bracket, you can only be part of one age bracket and not multiple. So we can say if age is greater than or equal to 25. And we can copy this and we can say you are 25 or older. Now let's see what happens. enter your name, Abba, and let's just say that I am 35. It says you are 18 or older, but I told it the program I was 35. Now the problem we're facing is any value that's over 18 will always enter inside here, and it will skip over this one completely. This is not the behavior that we want. So what we can do in our if statements is we can use the double pipe, which represents or the double ampersand, which represents and we can change some conditions in here to make sure that you implement some sort of range. So we can actually have a range between 18 and 25. So we can say if the age is greater than or equal to 18 and the age is less than or equal to 25, and we can tweak this message. You are between 18 and 25. And let's just run that for now and see what happens. Abba 25. Now it says 18 and 25. So now that we've got between 18 and 25 here, we can tweak this to be greater than or equal to 26. If you're 25, we'll enter this condition, and if you're 26 or older, enter this condition. So let's test that now. If we enter 35, now it says you're 26 or older. That's perfect because now that we've implemented range checking, it gives us the ability to differentiate between different age groups more precisely. Let's show an example of how to use the OR. So if we just have a block comment around all of this, we can write an if statement in here, and we can say if the age is smaller than 0 or the age is bigger than 150, then we can output to the screen invalid age. And what this is saying is if we're less than 0, and notice that this is less than 0, so this value will actually start at -1 and this value start at 150. Is -1 or less or over 150, then this will happen. Notice why it's an OR. One of these need to be true in order for this to be true. When you've got an AND, both sides need to be true in order for this condition to evaluate as true. So let's try our code. We can say Abba, and we put -1. And now it says invalid age, which is perfect because this is our range checking. And we can try again with 151. As it's just outside the range, it will say invalid age. And if we have an else on here, we can print valid age. Notice there is no condition in here. If you have an open else like this, it means if this were to return false, it will always do this regardless of any condition. In this case, it's perfectly reasonable to do this because we know that any values that are underneath 0 or over 150 is invalid, and anything between 0 and 150 is indeed valid. What you can do instead is actually move these if statements inside here, so instead of just printing out valid age, we can actually check the age as well. So let's run this now, and we can say Abba -1, and it will only print out invalid age and then move on, because once it reads this line of code, it will actually skip over the else and finish up down here. And now if you enter a real value, you are between 18 and 25. So let's follow the path. It got to here and realized that the range check was actually correct. So it jumped out of this curly brace and went to the else. Because this had returned false, we jump into this else and now we start checking. If age is between 18 and 25, which it was because our age variable is 23, then it outputted this to the screen. Now if we do the same thing but have 35 instead, then it follows the exact same path, except towards here, this will return back false, and then it will check the next condition. If age is over 26, then we'll return this. So now let's just make a quick multiplication program using if statements to see if you can get the answer correct. So let's just comment everything out, and we'll start the next section underneath. So let's make a console.write and ask the user to enter the first number. And then we can say int number a equals convert to int32, and the value that we want to convert is the console.readline, which is whatever the user's entered from the console. Again, if you're unfamiliar with this format, you can just type it in manually, number a input equals console readline, and then we can put the number input in here. Now if you use shift and highlight these lines and press Ctrl D, we can duplicate this entire section, and we can say enter the second number, change A to B, change A to B, and then finally change A to B. Perfect, so now we've got enter the first number and enter the second number, and we can say our answer equal to number A multiplied by number B. And then we can have a console.write value of, we can add to it number A plus an X plus number B, and then finally plus a colon for the user to type in. And then we can say string answer input equals console.readline, and then int actual answer equals convert to int32, and then we can have the input in here. So now that we've got one number from the console, the second number from the console, we're just making a variable that will multiply them together and store it inside answer. And then we're just going to ask the user what's the value of number A times by number B, and they can input that. We store it as a string and then convert it to an integer and store the answer into actual answer. So now just after this section, we can write an if statement that says if the answer equals to the actual answer, then we can say well done and else. And the reason why we don't need to condition this else, because with equals to, the only opposite thing you can have is if it's not equal to. So if you really wanted to, you could also write if answer is not equal to actual answer, then in here you can say close, but it was wrong. You don't actually need this. This is just for learning purposes, because this will return back false if they're not equal to each other. So this statement is just a given. If they're not equal to each other, then we can just assume that they're not equal to each other. So we don't need this additional statement. If this condition evaluates to being false, then that means they're not equal to each other. We don't need this additional check to check if they're not equal to each other, because that's a given if this returns back false. So we can just leave this as an else. Let's try run the code. 10, 10, value of 10 times 10, 100. Now it says well done. And let's just try that again, and we can enter a different value, 90, close, but it was wrong. So let's just have a quick recap. So in the previous section, we talked about how to input from the console, and we generated this line of code, which will output your name and your age in one line to the console. And then we looked at how we can use these different operators in our if statements, and we did some range checking to check if the age was between 18 and 25, and it would output something to the screen. And if it was over 26, you'd get a different output to the screen. And then we took that a little bit further and started using the OR operator. If the age is smaller than 0, or it's greater than 150, then it must be invalid. And if this condition returns false, it must be between 0 and 150. So we can come into this else bracket, and inside here we can do our range checking from the previous bit of code. We can check the ranges between 18 and 25 and print a value, or if it's over 26, we can print another value. And you can keep changing these if you want. You could have 26 to 40 and 40 to 60, etc, etc. That's up to you. So this is just a quick little program to simulate a multiplication program. We can enter the first number using console.write, and then we store it as a string, and we put that string into the convert to int32 function to give us back an integer variable. And we do exactly the same thing for the second number, and then we make a variable to store both numbers multiplied by each other. We ask the user what is the value of number A times by number B, and we give them an opportunity to type in a value. We read that value in, convert it to an integer, store it as into actual answer, and then in our if statement we say if the answer is equal to the actual answer, then we print well done to the screen. Double equals are used for equality and single equals are used for assignment. Don't get them mixed up. We don't need an else condition in here because if this returns true, then this will execute. If this is indeed false, that they're not equal to each other, then we always want to do this section and we don't need to put an additional if statement inside here. If you wanted to, but it's not necessary, you can have else if answer is not equal to actual answer. But this is just extra code and it hurts the readability and it should be avoided. If statements are one of the methods we can decide different paths in our code. The next method we can use is called switch statements. So let's write a little program so we can demonstrate this. So we can just have a console.write, enter date of the week. And we can have int date equals convert to int32. And we can place our console.readline inside the brackets. So we take whatever the user's typed into the console and then place it inside here. And inside here, we're going to convert whatever they've typed in to an integer 32 and store it into our day variable. So if we just print this out to the screen to make sure it's working fine, if we just type in 7, we can see that 7 is returned, so it's all working. So normally what we do is type if day equals 1, and then we can add the curly braces and use CW tab, and we can print out Monday. Now if we run the code and try use number 1, then Monday works. And that's fine. And then let's do another else if, and we can say day equals 2, and then we can print Tuesday. Perfect. So if we try that now, there we go. So now we have the ability to print out Monday and Tuesday to the console, depending on what day of the week the user enters. But since we're going to have 7 different paths because we've got 7 days of the week, then sometimes it might be better and cleaner to use a switch statement. So let's have a look at the syntax. So we can type in switch, and then inside the brackets is what variable we want to have a switch on. So in this case, we want to be using the day variable. So we can add day in the brackets. This is not a condition in the brackets. This is just telling us what variable we're going to be using for the switch statement. So let's open the curly braces after. And inside here, instead of having paths like this, we're going to use cases. So this can be translated to, in the case of number 1, we can do this. In the case of number 2, we can do this. So let's try and see how it works. We can type in case, followed by number 1, and then add a colon, and then we can type out our Monday in here. And then we need to follow each case off by finishing the section off with a break. This break's very essential, and you'll get a syntax error if you don't put it in. So now if we do case 2, and we do exactly the same thing, there we go. And if I dismiss the break, then you'll realize that it says it cannot fall out, so we have to use a break, just so the compiler knows that we want to break here. The reason why this break is placed inside here is because what we can do is we can say case 2, and then add another one in here called case 3. And what this now reads is if we enter 2, it says Tuesday, and if we enter 3, it also says Tuesday. So what you can do is you can actually chain. So this would be equivalent to writing if day equals 2 or day equals 3. Now this is exact translation. These two are exactly the same as of right now. We have day equals 1, which is our case 1, and then equals 2 or equals 3 is right here. If we go into the case 2 path, it will fall in the case 3. So we're saying for this break is we want to end this section here. So now if we just revert this back and continue the chain, I'll just skip this part just so it's a little bit quicker. There we go. So now that we've got all 7 days of the week, let's just see if it works. Let's try 6 and we have Saturday. So now we're kind of missing something from here. The only thing we're missing is having our external else, just in case the user types something invalid. So normally we would write something like this, enter a value between 1 and 7, just to make sure that the user knows what they're doing. Now we don't seem to have anything inside here that gives us the opportunity to it invalid. So we have this keyword called default, and it works exactly the same as the case, except what this will do is this is basically the word that replaces else. So we can literally take this line of code and place it again over here and add ourselves a break. This is exactly the same as doing our else statement inside here. If none of these cases match this variable, then it'll go into the default and continue as normal. So if we type in 0, we should see the message twice because it's executing for the if statement and executing down here. And let's do 8 and you see the message again. So now that the case statement is fully working, let's just comment out the if statement and make sure that it still works. 1, Monday. Let's just try another one and we can do 7 for Sunday. So just a quick recap. Case statements are used by using the keyword switch followed by the variable in question. And then if you want to check if this variable number is equal to something, you put that something straight after the word case, followed by a colon, and then you can insert multiple lines of code inside here and make sure you end that line with a break. If you want to chain multiple like day equals 2 or day equals 3, then you can add the case above right here. So the case of 0 or the case of 2, it will do this little section. So it'll print out Tuesday if the user enters 0 or the user enters 2. Of course, in this case, we don't actually want that. After you've filled out all of the code, make sure you add something called the default. The default is equivalent to an else keyword in our if statement, just to catch all the values in case the users type something incorrect and you want to let them know what they should be typing instead. So now that we've explored different paths in our code using if statements and switch statements, Let's have a look at how we can iterate through our code. An iteration in code is just the ability to be able to loop and do a certain task. So let's say we wanted to print hi to the console several times. Then we just have to copy and paste it down, and this will be 5 separate lines that do exactly the same thing. This will essentially achieve what we want. The problem is, you just have exactly the same code copy and pasted. So what we can do, if we just block comment this line for the time being, we can write something called a for loop. A for loop gives us the ability to loop a certain amount of times depending on the parameters that we give it. So this is the syntax. You can type for, open the brackets, and we have to use a variable. So we can declare a new variable straight into these brackets. We can say int I equals 0, and then have a semicolon. And there's 3 different sections to this. The first one is the variable declaration and initialization, and the second one is the condition. So in this case, we want to do this task 5 times, so you want to say I is less than 5. Then we end that semicolon there, and now for the third task. Every time this for loop goes around, we want to increase I by 1 because we want to go in steps of 1. So we can do I plus plus. Alternatively, if you don't like using plus plus, you can say I equals I plus 1. Or to make that quicker, you could say I plus equals 1. I personally just prefer using plus plus, and you'll see that everywhere else. There are certain cases where you would actually want to change this to a different value, like I plus equals 2, and we'll show you that in a second. So this for loop now says, we want to go from I equals 0, and once this condition returns back false, when I is equal to 5 or greater, then we want to stop this for loop. Every time this for loop goes around, so when it hits this curly brace and comes back around, we want to do this action, and in this case it's I plus plus. So if we just use console writeLine and print out the value I, we can see what happens when the for loop runs. You can see that the value of I is increasing 1 each time, and after the 5th time is increased, the value is actually 5, so now this statement is false because the value of I is equal to 5, so therefore this is now false and the for loop is ended. So now that we've verified that you can repeat it 5 times using this code, we no longer want to print I, we want to print our hi. So let's paste that inside the bracket and run the code. Now you can see that these 2 values will be exactly the same as printing it out to the console just like this, but now we have a lot less code. So let's have a look at another example. We can say for int I equals 0, and we can say I is less than or equal to 10, and then we can do I plus equals 2, and then if we just print I to the console. So what this is now saying is I want to go from 0 all the way till 10, and I want to go up 2 times each time. So what this will be achieving is printing out all of the even numbers between 0 and 10. Let's try and run it. Now we can see we have all the even numbers printed out between 0 and 10 because we're going up in 2s. If we start this at 1 for example, and still keep every parameter exactly the same, then we'll be getting all of the even numbers between 1 and 10. 11 is missing because our condition stops at less than or equal to 10. What you can also do with for loops is you can let the user determine what this value is going to be. Let's test that. So if we block comment this section out, what we can do is we can append this little section. So we can have a console.write, how many times do you want to say hi? We can have a colon followed by speech marks, and then we can say int loop counter equals convert to int32, and we can have console readline inside the brackets. How many times you want to say hi, the user types in the value. We take the console readline as a string, convert it to an integer, and store it inside loop counter. So now what needs to change inside here? The 5 is what determines how many times that we're going to loop. So in this case, we actually want to just loop by whatever the user types in the counter. Let's just type 5 and make sure it works. And if we just type 1, it works. If we type 0, however, it will just skip over the for loop. And the reason for that is if you're going from 0 to I is less than 0, then this is immediately going to be false. So then the for loop is just going to get skipped immediately. There is nothing to do if the user's typed in 0, which is perfectly reasonable. And you can type in a really big number like 100 and it will output them all to the screen. If the user types in 0, then nothing's going to come up. So you always want to be able to let the user know if there's something wrong. So we can say if the loop counter equals to 0, or maybe we can change this to less than or equal to, because it could type in minus numbers as well. We could just say a console writeLine using CW tab, sorry, please enter a value above 0. And then if this condition has returned back false, then inside our else statement, we don't need to give it an else if, because if it's less than or equal to 0, then we want to process the other values because it has to be greater or equal to 1. So when this is false, this section has to be greater than or equal to 1. So we can just place our for loop inside here, and that's fine. And let's try to run the code now, and if we type in 0, please enter a value above 0, and if we just try any negative values, we'll get the same message. If you want to print additional code in here, you can literally do anything you want. You can even ask the user what they want to print up here, and then you can replace this with a message. For example, we could have a string message, and we can just change this to hello world, and this could be something that you read in from the console. So we can say a message, and we can put that in here, and if we print that, there we go. So we can just say console.write, what do you want to repeat? And then we can read this in. And actually, it might be easier if we change this loop counter to second. So if you highlight the section, hold Alt and press down arrow twice, we can move it down and say, and how many times do you want to repeat it? There we go. So now what we can do is we can use this message inside here and then loop depending on how many times the user's typed in whatever. So we can type in hello world and get this exact value, and we can say 10 times. There we go. So now this entire program is fully customized by the user's input. So let's just have a quick recap. So we started off this code by printing the console write line 5 times to the screen. We wrote our simple for loop that went from int I equals 0 to I is less than 5, and we did I++ because we want to count up in ones. You can place the high inside here and it'll print it 5 times for us. So now we've made our code from 5 lines down to just 3 lines for the for loop. And then we allowed the user to type in how many times that they want to repeat it, and we changed the condition from I is less than 5 to I is less than whatever the user has typed in and stored within the loop counter. And then we hit a problem where if we entered 0 or anything less than 0, the for loop would just not run and it might look like some things went wrong. So we added a little if statement in here to make sure that the user has entered a value above 0, and if they haven't, we can let them know. We don't need another if statement in here because if this has returned back false, we can assume that the value is something that we can work with. We later tailored the program so we can change this message that was fixed to high to something that the user can type in manually. So now that we know how to use for loops, let's have a look at while loops. For loops and while loops still iterate through code, but they're used in slightly different contexts. For loops are used mainly when you know how many times you can iterate through, as in this example we're going to print to the console exactly 10 times. But in a while loop you might print until a condition is true. For example, if you're asking the user to type a number and they kept typing in something else, you don't know how many times it's going to take the user to type it in correctly. So in that case you would use a while loop. If you are executing a certain amount of code and you're only doing it a fixed amount of times, then it's always best to use a for loop. So first, let's try and convert this simple for loop that just prints I to the console 10 times. Just like so, from 0 all the way till 9. So let's comment out this for loop and have a look at this syntax for the while loop. So we can type the word while, and then in here we have our condition, and then we can open our curly braces. And while this condition returns back true, it will always go inside the curly braces, and when this condition returns back false, then we'll exit the while loop. So let's try and mimic exactly what we're doing inside here. There's 3 sections to the for loop. We define the variable that we're going to use for the for loop counter, and we give it an initial value. We give it the stopping condition, and we give it how many times the value needs to go up every time the for loop iterates. In the while loop situation, we only have the condition available. So let's take our condition and paste it straight into here. And now we need to store our variable. So just because it's a while loop and we can't store it inside here, we have to do it outside the while loop. So let's make it int I and we'll make it equal to 0. So we've got our variable, we've got our condition, and now we need to set I++. So inside the while loop, we can say I++, and then now we've achieved this entire line and successfully converted it. Let's try and put the console write line in and see what happens. And let's run the code. So it's going from 1 all the way till 10. And the reason why it's going from 1 till 10, not from 0 to 10, is because the I++ is at the start. Let's move it down one line using Alt and down arrow key to move it down, and let's run it again, and you can see it goes from 0 till 9. And if we just block comment this out and undo the for loop, you can see that they're doing exactly the same thing. So let's bring the while loop back. And as you can see, what we have is we've defined our I variable, made it equals to 0. While the I variable is less than the value of 10, we print the I to the console and increment I by 1, and we keep looping this until this statement returns back false, and then we exit the while loop and jump underneath the curly braces and hit the console read line. And this is the output that we've got. So now I've just copied the code from the if statement video, and let's make this code a little bit better. So let's comment out our while loop and our for loop that was just used for explanation purposes, and this is the code that you saw earlier on in the course. We read in the first number, store it as a string, use that string to convert to an integer, store number A, and then store number B, and these two blocks are exactly the same, except you have enter first number and enter second number, and we store number A and store number B. Then we store the value of them both multiplied inside our int answer variable. Then we ask the user what's the value of both answers times together, give them a chance to input their value, convert it to an integer, and then we check the value and print well done, I'll close but it was wrong. Now if we run this code again, and we type in 10 and 10, and we know the value is 100, but let's just type in 90. Now this is kind of a problematic user case. We've asked the user to type in a value and they've got it wrong, and then when they press enter, the program just closes. There's no opportunity to loop or try this again. So what we can do is add a while loop in here, and we can say, while the answer is incorrect, we can keep asking the user to keep on guessing. So instead of reading the input here, let's turn this little section into a question. What's the value of number A times number B? And instead of allowing an input here, let's just put a question mark. And then let's add a console write line just to give a little bit of a gap. And then in order to do our while loop, we actually want to create a Boolean variable just to track if the answer has been correct or not. This is the section that we want to loop around in the while loop. We want to read in the user's answer, check it, output a message, and then give them the opportunity to read in another value so they can guess again. While the answer is not equal to the actual answer, then we can loop around our code. So we have to modify a few things here. So we can't just take this code and place it inside. The problem with doing this is the variables that we want to check, answer is outside of this while loop, but actual answer is inside. And the reason why there's a red line here says it does not exist in the current context, because we're trying to check a variable that hasn't been defined yet. So what we can do is check the declaration for the actual answer and place it outside here and make it equal to 0. And instead of redeclaring it inside the while loop, we can take this int and get rid of it. So we set the actual answers to 0, set the answer to the multiplication. While the answer is not equal to the actual answer, then we want to loop around. So we don't actually need another check in here. This while loop will keep on repeating if the answer is incorrect, so we don't need a path for correct and incorrect. If this while loop still continues, then the answer will always be incorrect. So what we can do to double check is we can say, if the answer does not equal the actual answer, then we can place this message inside here and get rid of this branch. And then after the while loop has continued, we can say well done. So let's just read through the code. While the answer is not equal to the actual answer, and when this while loop first enters, it's going to be true, because you're going to have 10 times 10, which is 100, and the value of answer is 0, so this will return back true, because these two values are not equal to each other. Then we're going to ask the user to enter the value, then we're going to read it into the actual answer, check if they're not equal to each other, and then we output a message. Because we're asking a question here, we want to ask another one using a console write line, enter your answer, colon. There we go. So let's have a look and see how this works. 100, 100. What's the value of 100 times 100? And let's just get it wrong on purpose. 90, close but is wrong. And now we get to answer it again. And we can keep answering this as many times as we want until we reach the correct answer, which in this case is 10,000. And we've got the answer of well done. So to make the console look a little bit better, because this is all in one block, we can separate these with console write lines. Maybe after this line, we can print out a new line, and then after each guess, we can print out another new line. So after each guess will be down here, we can just print out a blank console write line. And just after you ask them to enter the second number, we can print another one here, and let's just see how that looks. 10, 10. Now it looks a lot better, because you ask the user to input the numbers, then you ask them the question, and then you get the answer, and then it keeps looping around like this. So there's a little gap between each one, so you can efficiently read it instead of it all being closed off together. And now if you answer it correctly, 100, now it says well done, and when we press enter again, the program now closes. So that was using a while loop, and now we have something else called a do while. And a do while is very close to a while, except that the while will only happen if this condition returns back true, and a do while will always happen once, and it'll check the condition at the end. So let's have a look and see how this works. So we write the word do, and then we have the curly braces, and then after it we have our while condition, and let's just copy the condition from the old while loop. And we can say answer is not equal to actual answer. So as you can see with a while loop, it will always check the condition first, and then it opens the curly braces. In the do, there is no condition, it will always do everything inside the curly braces once, and then it will check this while condition. If this condition is still true, then it will loop around and check it every time, but it will only check it at the end. While loops will check the condition as the first thing it does, and then check it every iteration. So let's move our code down into here, and let's just comment out our while loop just to see how this works. And if we run it again to make sure it's working fine, 10, 10, 90, 90, 50, and then finally 100, and it says well done. So you could be thinking, what are the differences between a while loop and a do while? In certain cases, you want the while loop to make sure that this condition is true before even continuing. In this specific case, we always want the user to answer the question. It doesn't matter if it executes once, because actually that's the behavior that we want. We've asked the user a question right here, so we want to always be looping at least one time. The while loop user case doesn't quite apply here, because we don't necessarily have to check if they've answered correctly if they haven't even inputted a value yet. We always want to be able to give them the option to do it once, and then we check their answer at the end. They could get it on the first answer, 10, 10, 100, and it'll still be fine. The same is true with a while loop, but it'll be easier and it makes more sense to read your code. When you have a while loop, you can see that this bit of code depends on a condition, whereas in a do while, the first iteration does not depend on anything, but the second and third and so forth depend on the condition. So depending on your user case and what situation you want to use it, you should either pick a while loop, which will only occur through a condition, or pick a do while that will occur once or multiple times after the first condition has passed. So when you have if statements that are pretty basic, you can actually make them quite easy to read through the conditional operator, also known as the ternary operator. So let's see how this works. Let's say we have an int age and we set it to a minus value. And we know that this value can never be someone's age because it's negative. But let's say that we have a situation where you ask the user for their age and they've accidentally typed in -10, and we know that that value is not actually true. So we could write something like this: age is greater than or equal to 0. Then we can print out valid. And then in the else, we can take this console write line and we can print out invalid. So that means if we run our code now, you can see that it says invalid. And if we change it to +10, now it says valid. So this seems a little bit long. We are just checking one condition, printing a value and printing another value if that condition returns back false. So our conditional operator works like this. We have a condition, followed by a question mark, then the value if it returns true, then the value if it returns false. Let's see how we can rewrite this if statement into one simple line. So let's take this in steps. These two values are both strings that we've typed in. So let's make a string and we can call it result. And let's make it equal to our ternary operator. So the first step is to get the condition. And the condition in this case, if the age is greater than or equal to 0. We can follow that by a question mark. And then if this returns back true, we want the string to say valid. and we can have a colon, and if it returns back false, then we want the string to say invalid, and we can add a semicolon. And then straight after it, we can just have a console write line that just says result. As you can see, now that we get it twice, we can verify one comes from the if statement and one comes from the ternary operator, and now if we make this a positive 10, then you can see it both says valid. So if we comment out the if statement and just see this running on its own just to double check, there we go. And because this is just returning back a string, we can actually just take all of this code in the conditional operator and paste it straight into the console write line. So you run the line of code now, we get exactly the same thing. If this hurts the readability of your code, then it's best to just store it and then use it after, if you can read this code and it's better for you in the long run. Later on, you might want to dismiss this variable and do it straight inside the brackets just to save a variable and then print it out onto the screen straight away. It'll be better for memory if you just print it out straight away, but if you're not familiar with this notation yet and you want to get used to it, then that's fine as well. So a quick recap, we had an if statement with a condition, and if this returned back true, we printed valid, and if it returned back false, we'd print invalid. And this was pretty simple. The only difference between these two paths is this string literal that we've typed into here. So we can pull the string values out and place them in our conditional operator. We can say string result is equal to, if the age is greater than or equal to 0, then we store valid inside result. And if it's not greater than or equal to 0, then we can store invalid straight in our string. After we've stored this value, we can print result straight to the screen, which will either give us valid or invalid. When you're dividing two numbers, you might get an ugly output just like this. The user sometimes doesn't want to see such long decimal places, and maybe you just want to prevent it to 81.03. In order to do this, we need to use a format pattern so the language understands what we're trying to achieve. So if we make another console write line, what we can do is use string.format, and inside the brackets we can give it a format and then the object that we want to format. So in this case, the object in the second parameter is our value. So let's open some speech marks, go to the next parameter using the comma, and just type in our value. And then inside the speech marks, we want to type in the pattern. If we type in curly braces 0, then 0 represents the first value in this list. We can do a space followed by curly braces 1, and then add another comma, and we can add 1000. And what this means is value will get placed where 0 is, and 1000 will get placed 1 is. So let's run this. And you see the exact same things happened, plus a space, and now we have the 1000, which follows this pattern exactly. If this is confusing, don't worry too much about it, I have the next section all about string functions. So let's get rid of the 1, followed by the 1000, and run it again, and we should see the output being exactly the same. There we go. So now let's see how we can make this better in terms of decimal places. So just after the 0, and the 0 represents the first value, we can add a colon. And this colon will tell us what format we want the value to be displayed as. We can type in 0.00, and what this means is all the numbers before the decimal place will get displayed, and only two numbers after the decimal place will get displayed. So let's try run this now, and you can see that the code output is a lot cleaner. One thing to note though, by default this will round it up. 0.37 becomes 0.4. Not to worry though, because this is what the user will see on the screen and it won't affect the actual value of the variable. If we print out value straight after, you'll see that the difference hasn't been changed. It's still 0.3 in the original variable. So that's one method of doing it. What we can do now is just use Ctrl D and copy it down, and we can use different formats to show you what it looks like. If we remove the 0.00 and then one of the zeros and leave it like this, and it gains one decimal place each time, you'll see what the output looks like. We just have the 81, which essentially makes it into an integer because it's a whole number. And then we have 81.0, and the reason why it's 0.0 is because 0.3 will round down as it's under 0.5. The 0.03 is going to round down as it's under 0.5, so it'll round down to 0. And then finally we have the 81.04, and just like before, this will round down to 0.4. And just like before, this will round down to 0.4. This will round down to 0.04. Let's say you wanted to get rid of trailing zeros because you don't want them, then you can actually change this 0 to a hashtag. Once you run the hashtag, then it will trim off any trailing zeros. So what this means is it will try and put it in this format, but if this format happens to be a 0, then it will just keep it like this. And if you just have 81 dot, then it will also get rid of the dot for you, so then you're just left with 81. It's really up to you as the programmer what you want to display depending on what context. I'm just giving you the options that you have available. So let's say we want to work with money now, and we have a 10D divided by a 3D, and what that value would be is somewhere between 3.333, and this will be reoccurring because it's exactly 1/3. The reason why I've got D's in here is because these are registering as doubles. If you type the value in normally, it'll get registered as an int32. And the problem with int32 is when you do this division, it will process the division as an integer and then store it as a double. The issue with that is, in this case and in this case, both values will get truncated. Let me demonstrate. If I remove the D from both sides, and down in here, it will see what the difference is. And let's print out money, and then see what's happened. In the first case, this isn't actually an issue because we have a decimal place here, which means this will be a double. So an integer divided by double will give us a double. But we just place the D here just so we don't forget, and it makes the compiler's job a lot easier because it doesn't have to convert it from an integer to a double. In this case, we have an int that's divided by an int. So we'll get 3.3 reoccurring, but because it's processing as an integer, then we just get 3 being displayed. And this is not the intended result. So let's just replace these back to D's and we'll see what we get now, which is the 3.3. Perfect. So let's say that we want to display this as actual currency because you never see it displayed like this. It's always to 2 decimal places, just as follows. So we can follow the same approach as above. We can do string.format, 0:0.00, end the curly brace, and then comma money because that's the variable in reference. Now if we run that, let's see what happens. 3.33. That's perfect. And now what we can do in here, because this is the pattern, we can actually type in anything before or after this and it won't affect the pattern. Just like so, we've added some extra spaces in here. So if we get rid of these spaces, we can actually just place a £sign in front of it, and then let's see what happens when we run it. Perfect, so now we actually have some money. And we can say in here, £10 divided by £3 equals this. And now our output looks a little bit better because we have some formatting. Now the issue is, when we start getting into negatives, let's see what happens. So we can say negative £10 divided by £3 equals something. And when we run, we'll see that the format is actually incorrect now. You never see the negative symbol after the pound symbol. It's always this way around. In this case, what we're doing is we're telling the compiler, hey, we only want to see 2 decimal places, but always keep it in this format. The £sign followed by the value. And the value of money is -3, so it'll place -3 inside here, and then add the £sign before it, but we don't exactly want that. So we can add something called a culture info, but we can also give it some other formatting some other way. So let's explore some other options. If we use money to string, then what we're actually doing here is using the double variable and converting it to a string, and we get passed back a string representative of this value. And that's fine, and when we run the code, you'll see no difference between these two. At this point, they're both being converted to strings, but what we can do in this case is when we open these brackets, it tells us there's 1 of 4. What does this mean exactly? So in our toString function, we have 4 ways that we can call this function. The first way, you give nothing in the brackets. And if we press the down arrow, the second way is to give it a format provider. The third way is just a string format, and the fourth way is both a format and a provider. So we'll use all of these in a second, but let's explore the easiest one. If you add a string in there, which gives us the third overload, a string format, and we can just type in a capital C, let's just see what happens. Perfect, so now we have the best format displayed to us, and the reason why this works is the C# program will recognize that the format of C is telling us that we want to display currency. So then it's going to your local machine and figuring out where you are based on your date and time, just down here. When you have a just date and time, it'll figure it out based on this. We have UTC time and we have the date and time listed up here. Based on that information, it can figure out that we are indeed in the UK and we want to display a £sign, and because the program knows that it's negative 3.33, it'll put the pound sign in the right location. So now that we've explored C, let's have a look at the other ones that are available. So if we use Ctrl D and copy this down 3 times, we can use C0, C1, and C2. And now if we run this again, you'll see what the output gets you. C will get you currency in its most native form, which is what we're used to using in the UK. C0 will only return you back with the whole number, C1 will give you 1 decimal place, and C2 mimics C on its own as they're displaying the same values. Now this is where it gets interesting. If you want to display different currencies, then you're going to have to use this thing called a culture info, which will be able to retrieve back different currency formats based on a certain country code that you give the function. So let's have a look and see how that works. If we scroll to the top, we can add a new library called system.globalization. Inside globalization, we have a culture info. So let's see how we can tailor these to make it look a lot better if you're worried about different currencies. So we use CW tab, and we do the same thing, money.ToString, we add our C, and this is where our format provider fits in. So we can start typing culture info, and it should come up like this, press enter, and inside this is a class, that's why it went green. If we press dot, then we get the current culture. The current culture will decide based on the machine that the program is running on. If this program is running on a cloud computer, and the cloud computer is stored in Europe, then it might display euros, and if it's stored in America, then it will display dollars. So you want to avoid using current culture if you're going to scale your program worldwide. In the case of this example, I'm going to leave it, because as you can see, when I run it, it will display the same thing as the other ones, because this one will also recognize that my current culture is UK, and I'm also telling it to use the current culture. So in both of these cases, it's figured out that my current culture is indeed the UK, and it started using the pound sign. But let's say we want to give it a different culture. Then what we can do, if we duplicate this line using Ctrl D, and remove this section just after the dot, we can actually say create specific culture. And inside the parentheses, we can actually add a string, and it says here, a predefined culture name or the name of an existing culture info object. The name is not case sensitive. So in the case of the UK, you have English GB. And now we need another bracket at the end. And then if we use Ctrl D to copy this down, we can change GB to US. Let's run this again and see what happens. These two don't actually output anything different because we're just doing the normal culture, and then we're telling it to find the GB culture, which is exactly the same thing for me. So we get these two values exactly the same. And apparently it's picking up that in the US you have brackets around your negative values, which I can't personally validate, but this is how it's showing up. So let's try some other cultures and see what happens. So we can try ENAU for Australian. Then you can see that they actually use a negative followed by the pound sign and then the value. So even though they're both in dollars, one's US dollars and one Australian dollars, and apparently the US uses brackets for their negative values, but Australians use the negative value like we do. So let's just have a quick recap. So we can display the value just like this, but we'll have a problem with multiple decimal places. We can use these format options to give us 0 decimal places, 1 or 2 decimal places, and then when we use this format, the problem with it was when you display negative numbers, you get a nasty format where the negative value actually comes after the pound sign, which is not correct, and you don't want to output that to your users. Instead, you should use the C format. You'll tell the compiler that you want to process this as a currency. Currency processing is better because the software will understand that the value you're trying to represent depends on a certain strict format, just as follows. You don't want the negative to be here instead of before it because that doesn't look very nice to the end user. Alternatively, you could use this culture info if you're going to scale your program. Scaling your program means that it's going to live on servers. And this culture info, especially the current culture, depends on where the program is being run on because it depends on the system time. Different servers will have different date times set because they'll be in different countries. So you want to be careful, and if you want to display in a certain currency, you can create a culture specification and pass the country code inside the brackets, and then you'll get the correct output, and it doesn't matter where your program lives. If you always want to generate in pound symbols, then you always use create specific culture and always specify ENGB. Upon doing so, you'll always get the pound sign and it doesn't matter where your program lives. So throughout this course, you've seen this notation a lot. Print out a value using console write to give the user an opportunity to write on the same line, reading their value as a string and store it in a variable, and then use that variable to convert it to an integer 32, and we're passing the string input inside here, and then we convert it to an integer. If we run the code, you can see that this actually works perfectly, assuming you actually enter a real number, like 10. We press enter and it works and it outputs back to the screen using this console write line. And then if you press this restart button, we can start the program again, and let's say we accidentally type a character like L, and we press enter and we get a format exception now. This is problematic because our program will now close. If we press continue, it doesn't even hit this line or this. As soon as it hits the exception in here, our program just closes. If we use debug, start with our debugging, and now we're actually running the program outside of Visual Studio, so we won't get that pop-up when the error happens. Let's see what happens if we type this in now. We can say 10p and press enter, and now we get that the program has stopped working. You've probably seen this pop up a lot throughout Windows and different versions of Windows, because when a program has a fatal error or an exception, you see this pop-up appear, and the only thing you can do is either debug or close it. Normally the debug option isn't available, but because this is a C# program and it's made through Visual Studio, and the Visual Studio has been installed on the system, then it gives us the option. But really, all we can do here is just terminate the program. It doesn't matter what happened because we can't recover this. If we press close, then it's literally just going to close down. It's going to tell us the exception and then press any key to continue. And as soon as you press any key, then the program just closes. So this is very fatal for our code, since if we had some precious data stored in here or anywhere else in the program, it is now lost before we can do anything. This is problematic and we want to avoid this. The best way to do this is to use something called TryParse. Right here, the program is assuming that your string input is a perfect input, and then you're immediately converting it to an integer. Now, like I said, what if this had 10h in it? The program is going to cause an exception, and then the program's going to close. So let's see what we can do with this TryParse function. So the notation is int.tryparse. The first parameter is a string s. String s is a string containing a number to convert. So what this TryParse function will do, as it says here, converts the string representation of a number to its 32-bit signed integer equivalent. A return value indicates whether the conversion succeeded. Okay, perfect. So we'll get into that in a second. So our string s is a string containing our number to convert, and in this case we want to be using the num input. So we copy and paste that down, and then we add a comma because we have more than one parameter. Now we have an out int result. When this method returns, result, which is our integer, contains a 32-bit signed integer equivalent of the number contained in s, and s in this case is our first parameter, which is num input. If the conversion succeeded, then we get the value inside our result, or 0 if the conversion failed. The conversion fails if the parameter s is null or string.empty, is not of the correct format, or it represents a number that's less or more than the maximum value that the integer can store. This parameter is passed uninitialized, any value it originally supplies in result will be overwritten. Let's dive in to see what this means. Because it's an out int result, what this means is we can actually process a variable inside here, like int num. So we can say out num. And what this will do is when this line executes, it will try and convert num input and place the value inside num. So we don't need to run this convert anymore, we can just specify that num is equal to 0. So we've read in the string that contains our 10h, and we have our num that contains 0. Let's just remove this console write line. So now we have our variable set up. Let's see what happens. If we do a console write line and just print num after this, let's see what happens to the code. So if we type in 10h and press enter, the value of num is 0, but what do you notice now? The program hasn't closed because it's tried to parse it instead of just parsing it automatically and then cause an exception. So the reason why TryParse is called TryParse is first it tries, and then if it succeeds, this will contain the value, and if it doesn't succeed, this will contain 0. To know if the number has actually been converted, we actually have to use the bool return value. So what this means is, because it returns us back a bool, we can store it inside a bool. and we can give it the name of success. Bool success equals int.tryParse. We try and parse the num input and we place the value inside num. The reason why having this bool success is very essential, let's say for example the user actually enters 0. So technically as of this point, num0 is actually correct because we've got 0 and we initialize it to 0. But of course after the TryParse runs, this is still going to be 0. Now we don't know if the value 0 is because this has succeeded or the value is 0 because we initialized it to 0. Let me demonstrate. If I type in a 0 here, is this 0 being converted because this was successful, or is it presenting me 0 because this has been initialized to 0? And the only way we can know is because our TryParse will return us back with true if S was converted successfully, otherwise false. We can actually write an if statement in here. If success. Open the curly braces and we can start to type something in here. So we can take our console write line and place it up here using Alt and up arrow key, and then in the else we can say failed to convert. So now we have a mini setup here. If it's been successful, we print out the number. If it hasn't been successful, then it'll go into this path and it'll print failed to convert. Let's have a look and see how this works now. If I press 0 and I see 0, that means it's followed down the success path, and this 0 actually means it's converted my input instead of just the value that it's been initialized by. If we run the code again and type in 10h, then we actually see it says failed to convert. And why that happened is we have 10h up here, and then this will return back false when it tries to convert num input, and then after it hits this line, since success will be false, it will dodge this path, go into this path, and output failed to convert. What you can do if you really wanted to is you could wrap this around in a while loop, so let's see what we can do. So we can specify a bool success and make that equal to true, and then we can add a while loop with success in there, and then open the curly braces and put all of this code inside here. Now we're going to have some errors because we got success twice, but what we can do, which will be a lot easier, is we can place this straight inside our bracket. And the reason why is because this returns us back a boolean, so we don't need to store it and then use it. Another thing we can do is instead of having int num and then num right here, you can actually make this a declaration as well. So if we just remove this value, we can write out int num. And this will do exactly the same thing, it just uses less variables. While our success is true, we come into here and run this code. If we fail to convert, then we still want it to be true so we can loop around. If we've converted it and the value is successful, then we can actually make our success at this point false, because that will stop the while loop from going around. Let's run the code. We can type in 10h, 10e, 10a, etc, and as soon as we type in a real number, then it will print it out and the while loop will cancel, and now right here we're sat on the console read line. Now if I press enter, the program will close. So let's have a recap. We use int.tryParse so we can try and parse a value before the program assumes that the value is in the correct format. We give it a string variable and it returns us back with a fresh new integer called num or whatever you want to call it inside here. We can place this straight inside the condition of an if statement because this function returns us back with a true or false value, otherwise known as a bool. If this has been successful, we stop the while loop and print the value out to the screen, and if it hasn't been successful, then we print failed to convert, and because our success is still true, it will loop back around to the start of the while loop and ask the user to input another value to try and convert. This while loop will only exit if it's indeed been successful, and the only way it can exit is by having the success being equal to false, and the only way that can happen is by having a successful conversion. The use of TryParse in every program is very essential, because if you have a fatal exception, then your program will close and you will lose all the data. The problem with that is you might lose anything that you haven't processed yet at that given point in your program. So you want to try and use TryParse because you'll avoid any potential exceptions, and you can let the user know if the conversion has been successful or not, and write yourself the same while loop just like this So you can tell the user, hey, you input it incorrectly, but this is how to do it right, and make sure that your program doesn't execute incorrectly. And make sure your program doesn't just close unexpectedly and then an error will be caused. In this exercise, I want you to print out some sort of times table. And what I mean by this is you want to ask the user to input a number for the table and then write a for loop to print out the x times table. X is dependent on the value that they entered. If they enter 10 in here, then this will be the 10 times table. Let's get started. So we can have our normal console.write, enter a number, and then use our int number equals to convert to int32, and we can say console.readLine because we want to read whatever the user types in. Then we can have a for int I equals 0, I is less than 10. We're only going to print up to the 10 times table, so 1 times something, 2 times something, all the way up to 10 times the value that they entered. Immediately we acknowledge an error here. When you do your 10 times table, for example, you do 1 times 10, 2 times 10, and so on and so forth. The issue here is we're going from 0 to 10, but because it's less than 10, we're actually going from 0 to 9. So let's change this to 1 and then less than or equal to 10. In both cases, we were actually looping the same amount of times. The issue is this was starting on 1 and the other one was starting on 0, and the first one was finishing on 9 and this one's finishing on 10. And we want them to go from 1 till 10 instead of from 0 till 9. Even though that's the same amount of iterations, it gives us different values. So in here, we can just have a console write line. And this is how it's going to work. We're going to have our first number times by our second number, and that's going to be equal to something. So our first number is our value of I, because that'll say 1 times something, 2 times something, and so forth. Our second number is whatever the user has typed in to the calculation, which will be number. And our third number is going to be the actual result of the calculation, which are these two times together. So we can have I star number, and that should be it. Let's run it and give it a shot. We can do our 10 times table, and if we press enter, you can see that it's fully working. This will be our I variable going down the side. The second number is what the user's typed in, and the third number is this multiplied by this gives you the output. Let's run it again with a bigger number, and it seems to handle okay. And because this is an integer, you'll expect to work okay up until around 2.1 billion, which is a big number for some times tables anyway. So just a quick recap, we looped through from 1 till 10 instead of from 0 till 9, because we made sure that when we do our multiplications, we don't want to start the value at 0 times something, we want to start the first one at 1 times something, and we don't want to end at 9, we want to end at 10. So using 1 and less than or equal to 10 will get us the values that go from 1 till 10, and that'll make our output look a lot more concise. We're using conditional formatting here, adding the 0 and curly braces, and then the 1, and then the 2. And in order to insert the values in, it's a comma delimited list after the speech marks. The first one goes in the right order, 0 is I, 1 is number, 2 is I times the number. Running that code, we'll get this output. There you go. So in this exercise, I want you to have a look and see if you can make the FizzBuzz game. FizzBuzz game is one of the most popular interview questions you'll come across. And the way to do this is to create a for loop from 1 to something. In this case, I'm just going to use 15. And inside the for loop, you want to decide if the number is divisible by 3 and 5, then you want to print FizzBuzz. If it's divisible by 3, then it's Fizz. 5, it's buzz, and if it doesn't fall into any of them categories, then you want to simply just print the number out to the screen. Let's get started. So we can have a for, and because we know how many we want to do int I less than 15, I++. And then inside here, we need to use the modulus operator, which is the percentage sign. So if you remember from the tutorial, in order to figure out if a number is odd or even, you could do the number modulus 2, and if that value is 1, then it must mean it's odd, and if that value is 0, it must mean it's even. But what we can also differentiate from here is if 10 modulus 2 equals 0, then that means that 10 is divisible by 2. But also it is even, and if it's even, that means it's divisible by 2. If it's not divisible by 2, that means it's not even, and therefore it's odd. So in this case, if we're trying to divide 3 and 5, we can have the same calculation, but we can work it out differently. So 10 modulus 3 actually gives us the value of 1, because it's 3 remainder 1. So if this value is anything other than 0, then we know that these two were not divisible by each other. 9 percentage 3 equals 0, which means it's divisible by it. So in our if statement, we can say if I, which is the number that we're currently up to, percentage 3 equals to 0, and because we want to check for 5 as well, we want to say and I percentage 5 equals to 0, and that means they're both divisible by each other. So we can do a console write line and we can say fizz buzz. And then in our else if, we're going to check if it's 3, and we can repurpose this exact condition because this just checks if it's divisible by 3, and then we can print fizz, and then if we copy this exact structure down and change this to a 5 to check if it's divisible by 5, then we can print out buzz, and in the worst case scenario where none of them get applied, then we can simply print I to the screen. And actually there's no point in starting at 0 because normally these start at 1, so we'll just do 1 and we can make it 15 by making it less than or equal to. So instead of before it was actually going from 0 to 14, now it's going from 1 to 15. And they will tell you this in the interview. They might say, counting from 1 to 100, print out all of the fizz buzzes. So let's run the code and see what's going on. 1, 2, fizz. Fizz is actually 3, so 3 is divisible by 3. Then you have 4, and then 5 is divisible by 5. You get buzz, and 6 goes into 3, so you get fizz. 9 you get fizz because it's divisible by 3. Then 10 divided by 5 gives you buzz. 11, 12 goes into 3, so you've got fizz. And finally, when you hit 15, it goes into 3 and goes into 5, so we get fizz buzz. And the way to increase this to 100 is by simply changing this to 100 if you need to. And you can scroll through the entire input and you can see all the history. If you wanted to make this slightly efficient, what you could actually do is store the Boolean values for these calculations before. You can store the values for these calculations before. So we can say bool 3div equals false and bool 5div equals false. And what we can do at the start of each of the for loop is we can say 3div equals this value and 5div also equals this value. And then every time we find a calculation for 3 or a calculation for 5, we can replace it with either 3div or 5div. So let's change this one here and this one here and our 5 here and here. And because these are values now, we want to actually store them as true or falses, so we don't need to check if they're equal to 0, so we can just remove them. So we can say if 3div and 5div are both true, and they'll only be true if these two are both 0. Now if we run the code and just make it 15 again, just so we have a shorter output, you can see that our code is exactly the same. The reason why this is more efficient is we're only doing this calculation twice, whereas before we were doing it twice for 3 and twice for 5. Now we're doing it once, storing it, and then making use of it. This is a lot more memory efficient than having to calculate it every single time. It computes a lot faster, and it's better for readability. If the rules of the game happen to change and this was divisible by 4 or 6, then you could just change it very easily, whereas in the previous example, you would have to change it in every single case. In C#, when you're constructing strings that have backslashes, you're going to need to use double backslash. And the reason for this is the first backslash is an indication that it's actually going to be an escape character. You're going to put an escape character in and then put the character that you want to display. And the reason for that is they've chose backslash as the designated character. So you can use backslash and then a backslash to show one backslash only. And what this means is it will use the first backslash as a reference so it knows that it's going to process the next character as an escape character. And what these escape characters are, you can have things like T for tab, N for new line, and you can even use speech marks. Because if you're outputting some dialogue and you wanted to say something like this, he said, and then you added your own quote in there, if you want to put something in quotes, then you can't, because the speech marks dictates that this is the end of the string literal. That's why it's cutting it off like this, and then now it's not recognizing that something is just wrote here, and what it's actually doing is you've got two strings specified. One that says he said space, and one that's just empty, and then you just have this something that's just in the middle. Of course, we actually want to insert the speech marks within another pair of speech marks. This is where the backslash comes in, so you can insert a backslash before here, and this is now acceptable. And the same thing with the normal backslash. Because the backslash character is also going to be the escape character, then you need a double backslash, so then that equals to a single backslash when you print it out. Let's show an example. So we have C:// which will return us back a single slash, but visually right now it's a double slash, but when it gets processed or outputted to the screen, you'll see that it's a single slash. So this common example is when you're constructing a path together and you want to use backslashes to denote the different directories. So let's output this to the screen and see what happens. And as you can see, we have a single backslash. Because of the escape character, we don't see both of them. And if we print the speech out to the screen just to show you that as well, then we can see that there's only the speech marks around the something and we don't have the backslash. You can tell when an escape character is being used because it goes a slight hint of yellow instead of the normal color for a string. So now that we've worked out that this is how this works, let's see a way that we can undo this to make it easier for us. So you've used the $sign for string interpolation and you've used the plus just to concatenate two variables together. And just as a quick example, it looked something like this. Your name is, and then the name variable. And using the plus, you would say your name is, followed by a space, and the quotation marks and do plus name. That's fine. And now we have another one. So similar to how we placed a $sign before the speech marks, we have a verbatim identifier. And what this means, because it says verbatim, it just means whatever you see is whatever happens. So let's try and define this path a slightly different way, but still containing the exact same information that you see when you print it out to the screen. So let's have a look. We can reassign the path value, and just before the speech marks, we can put it @ symbol. And this @ symbol means it will actually negate all of the escape characters. It will process a single backslash as a single backslash. Let's take this line of code and place it inside here. Now what you see is that tint of yellow is no longer there. So if we print this path to the screen, let's see what happens. We actually get the double backslash because it's ignoring all the escape characters, which means if we take them all out, this actually looks exactly how we want, and you don't have to worry about the escape characters. There you go. These two are identical even though one is being displayed using escape characters and one's using the verbatim identifier. Please note that if you're going to use the \n for example, and I'll just demonstrate at the end of this, new line test, and if we run that code again, you'll see that it's printed the path on one line, the \n has made it go on to the next line, and now it's printing new line test on a dedicated line. That's fine. The problem is if you use a \n or a \t or any of these escape characters during the @ symbol, then it's going to process it as literal characters, which means you can't mix a \n with an @ symbol, as this is just taking the text verbatim. So if we try and run the code now, you'll see the \n will actually appear in the code. If you wanted to do this, then maybe you could remove the \n and add a plus at the end, and then make another string that just has a \n, and then this string will not be processed as a verbatim string because we don't have the @ symbol right before it. So then we can have the exact same thing here just to show you this. So now these two are identical again, just as shown here and as shown here. The difference being that we can't specify a \n in the same string, we actually have to concatenate them together because of the verbatim identifier. So let's have a look at speech marks. So if you have a string name, and we can make this equal to hello and then someone, and we said before that we have to use the \ so we can activate the escape characters, and that will work. And if we just print that to the screen to make sure, Then we get hello someone in the speech marks. If we add the verbatim identifier at the start, then we see we've got an error. It's trying to process it differently. This is a little quirk with the verbatim identifier. If you want to insert a speech marks, you actually want a double speech mark on either side. The double speech marks will get processed as a single speech mark. Because it's within a speech mark, the verbatim identifier needs to know that you're specifying a speech mark, and this acts as the same reason why you have a backslash here. It's slightly quirky doing it this way, but it still works as per you expect. And when you're specifying something like name, and we can say hello someone, so let's print name to the screen and make sure it works. In this case, we don't actually need to specify any sort of escape character because the quotation mark is a separate character to the speech mark and it doesn't interrupt anything by placing a quotation mark inside. The string just represents that as its own character. Let's run that and make sure it works. There you go. So just as a quick recap, escape characters are very essential because we can use things like \t to give us a tab character in our console output. This can be very helpful because you can almost mimic the use of columns inside our console output. You'll notice that \n is used quite a lot in the console output, so you can separate lines without having to use multiple console write lines. If you have a single backslash, you can't have it on its own if the string is not a verbatim string. You have to pair it with another character, otherwise you will get a syntax error. If you want to use the verbatim string, then you can put an @ symbol before the string definition and then it will ignore all of the escape characters. For example, using \n within these speech marks will mean that the \n will literally be printed to the screen and you won't get the new line functionality that \n provides. When you want to print speech marks to the screen using the verbatim identifier, you have to use a double speech marks in order for it to show up. And as you can see, it slightly goes yellow, and that's the similar notation as using escape character when you don't have a verbatim string. If you're using other characters that are similar to a speech mark, like a quotation mark, because this doesn't interrupt the syntax of the language, then this is fine because a character can just be inside a string. And to the compiler, this is just a character even though they are very similar. The quotation mark doesn't affect the speech mark. The most common approach for outputting values to the console is by having this format. You type something in as a static string and then you add a variable to it. But when you're doing long sentences, this format can get messy quite quickly. So this will just output both of these on separate lines, the name followed by the name variable and the age followed by the age variable. I just have a console write line to split up these two sections just so you can see it visually in the console. So if we run this code, you can see that both the outputs are exactly the same. And the reason why is we can use this \n. What this \n is doing is inserting a new line character just where my cursor is here, which is forcing the age to jump onto the next line. The reason why this is a slightly different shade to the age text is because it's an escape character. \n means new line. We'll explain this in a further video in this section, so don't worry about that. Just know that it means that it produces a new line. So as you can see, since we're adding the name, followed by the name, and then the age, followed by the age, then it's getting a bit long and a little bit tedious. It's not too bad in this case because we're not really printing out a sentence, we're just going straight to another line. But let's see what this is going to look like if we start dealing with multiple bits of data. Your name is, followed by the name, and then we can add a comma, and your age is, and then add the age. And as you can see, while we're structuring a sentence, then it gets a little bit long. We have to remember to put in the spaces, otherwise our code is going to look funky when we print it out to the screen. And the reason for that is there's no spaces between the name and the age variables. So let's put them back in and make sure the output looks alright. Now that the output looks like this, let's explore composite formatting, and what this means is we can get rid of all of these plus symbols and replace it with curly braces. So let's actually output this string again, but just output it completely static. Your name is Abba, and your age is 23. And now if we run this, you'll see that both outputs are identical. This is because I know the values for the string variables up here, and I can input it straight into here. So now that we know what our sentence is going to be, we don't need to add any pluses. What we do need to do is remove our variables. So in the case of this sentence, our name variable is here and our age variable is here. So we can replace this with this curly brace notation. We can have curly braces and then we want to start this value at 0. Throughout the string, you want to have these values starting from 0 and going up incrementally from left to right. So our next variable would be our 23, and we can store it like this. Now that it's got your name 0 and your age 1, let's see what happens when you output it. Then we just get this, and this is very confusing. That's because we're not done yet. So now that we've got our string typed in, we can actually place a comma in here, and now it lets us put any object in. And any object could be a string, an int, a double, or any data type. So we want to insert the values inside here, going from left to right. So our name is first, and then we do a comma, and we type in age. And what this now says is the name will get replaced by the curly brace 0, and the age will get replaced by the curly brace 1. So now if we run the code, let's see what happens. And now you'll see that the output is exactly the same. And now look at the difference between these two lines. You'll see that these multiple amount of pluses are not confusing, and let's say you forget this one, then you're going to get a syntax error, and it's a bit frustrating to keep on typing when you're trying to join things together. Now we can clearly see that this flows like a sentence, and this space here looks very unnatural, but this space here looks like it's part of the sentence, which makes our code a bit more complete. And the same goes if you want to print something like this, and let's convert this one. So if we copy this line down into here, and we just remove the spaces, then it can look something like this. Name followed by the name, and we don't actually need this space here because we're going to be going into a break line. We can replace our name with curly braces 0, and our age with curly braces 1. And then straight after we can type name and age, and if we output this, we'll see it's exactly the same. There we go. So just a quick recap. Printing strings and any other variables to the screen has been normally achieved by doing a string followed by a plus and then adding another variable to it. Adding more than one can be a little bit complicated and hard to track of all the spaces that you're going to put in, and you might accidentally miss one of them. Like this one here or this one here are very crucial to the output. If you miss this one, then it's going to say is followed by the name all together with no space. We then introduce composite formatting, which lets us use this notation of curly brace 0 and curly brace 1 to give us the ability to store some variables outside of the string and then insert them in dynamically. We took both of these examples and made them down here using composite formatting. So let's explore a new method of concatenation that makes this look a lot better. The reason why this is an issue is you have spaces in here, and sometimes you might forget these spaces and it could mess up your program. This string here looks very unnatural because you're forcing the space, but when you run it you'll see that it is actually what you expect. The spaces are complete and it makes perfect sense, but when you're writing it, it kind of looks a little bit stupid because you're forcing the space and then adding a plus and then the name and then another plus and then another static string, and these just get a little bit long to type. It's fine when you have a smaller sentence like this, but when the program starts to grow, then it could be a little bit problematic and you'll have a lot of syntax errors when you forget to type in all the pluses. Luckily, this can be fixed. Let's duplicate this line down and let's see what we can do. So we have this thing called string interpolation, and it uses a $sign as a reference. We can place the $sign before the quotation marks, and then what you can do is you can actually keep this as one big sentence. So let's remove all of the values and have it like this. So now of course this actually doesn't print our variables because we've just replaced it with text. So if we just run this, then it's completely messed up because now we're not using our variables. And this can be easily fixed. Because we've used our $sign now, we can actually wrap our variables in this curly brace, and now you can see it went white. If I double click on it, you can see that it's referencing the variable. Wrapping the variables in the curly brace means that they can actually be processed as variables even though they are still within the speech marks. Please do not remove the $sign because now this will be interpreted as string text, as you can see here. Putting a $sign at the start will make it into string interpolation, and then we get the ability to have our brackets. This can make string concatenation very easy to do because you don't have to worry about all the pluses and adding them together, and don't have to worry about the spaces as well. This looks more like a natural sentence, and what you can do for practice is you can actually just type out the sentence. Your name is Abba, your age is 23, and then from there you can actually just break down the variables and know that you'll need one here, so you can replace that with name, and then you'll know you'll need one here, so you can replace that one with age, and then you can place the $sign right at the end, and then there you go, you have your solution. This method means that it's a lot cleaner to read, easy to maintain and make changes in the future, and that's the whole point of programming. If your code base is very difficult to go around and understand what's going on and potentially make changes in the future, then you've already made a bad step and you don't want to get into these nasty habits. It's fine if you're just going to have something like this, where it's not really complicated at all. A string plus another string, that's quite simple and that's fine. You don't have to go the extra effort to put in the $sign and wrap it around in the curly braces, even though I personally still would, because in my personal opinion, this looks a lot better than having it like that. You can see that it's a lot neater, it takes up less code, and you can see visually that you're using a specific variable, and you don't have to worry too much about the spaces because this looks like a real sentence. Explore another method of string concatenation, which is the idea of taking strings or objects and adding them together to form a sentence of sorts. We can say your name is, followed by a space, and then add the name, followed by a space, add your age is, and then add the actual age variable. And we can also write the exact same line using string interpolation or composite formatting, just like this and like this. We can specify the $symbol and put our variable in the brackets, which is shown here and here. And for the composite formatting, we can take the contents where our variable would go and replace it with incremental numbers 0 and 1 wrapped around in a curly brace, and then specify in the correct order. 0 takes the value of name and 1 takes the value of age. If we run this code, you'll see that the outputs are identical. So let's explore this other method. We have a string, test for example, and then inside the string library we have this function called concat, and it can take in any amount of parameters that we want to give it. So we could say your name is, space, and the quotation marks, and then we can add a comma, and then we can say we want to add the name, and then another comma, and we want to add and your age is, and the speech marks, add a comma, add the age variable, and that's it. And we could just use CW tab and type in test, and let's run it and see what happens. And now as you can see, we get the exact same output. And because this just returns us back with a string, we can also just take this entire line and paste it straight into the console write line. You don't necessarily have to store it, but you can if you want to. And there you go, all methods produce the same output. Another way you can use this concat function is by giving it an array. We haven't covered arrays so far, so I'm just going to show you this for demonstration purposes. Don't worry about understanding it. So just a quick explanation, arrays are just ways of storing multiple of the same data type. So if we have these three names inside our names, we can actually use the console to print them all out. So we can say string.concat, and then we can concat the names together, which will just add all of these three together. Now the problem is when you run it, you'll see they're stuck together. So what you could do is just add a space between them. And as you can see, this is getting a little bit tedious now. There's other methods that we can use to concat some arrays together, and I'll show you that in the next section, but for now, don't worry about it. This is concentrating on the string concat function, and we'll just demonstrate that again. So if we run the line of code, we can see that they're all the same. So now that you have 4 different methods of printing out exactly the same information, you might be asking yourself, what's the best method? I personally prefer to use the string interpolation because with this one you can easily miss the spaces and you could produce a bad output and it might be stuck together. It's fine when you can see the lines right in front of you and you can easily identify the spaces, but when you're adding about 10 variables together, then it could be a problem. The reason why I like string interpolation using the $signs and the variables in the curly braces is that you don't have to rely on missing out spaces because it actually forms a sentence and you just replace the values with your variable. Composite formatting, which is this one, is very efficient and very nice to look at, because it allows you to specify the sentence and then plug in the variables after. The only problem with this is if you were to change this value in the future or to change a sentence, you have to make sure that the numbers add up. Just like in the first example, if you only have a short sentence, then this isn't really an issue since you can see it all visually. And you also got to realize that these need to be in the right order, because if you put age first, then it's going to put age in this one and name in the second one, and that's going to be problematic because it now messes up the sentence. Using string interpolation, you don't actually have to worry about anything, because if you wanted to change this to say your age is, then you simply just do this. And that's very easy to do, because in this case you'd say your age is, and then you'd have to change the string, and then now that this is 0, we need to change this from being age and this one to be name. Whereas in the first example, you could just easily change the value in the curly braces instead of changing this reference and the end reference. Concat is not widely used just because you have all of these methods available where you can easily add stuff together, but there could be user cases later on down the line where users, just so it's a bit more obvious and it helps the readability of your code and maintain within a big project or just on your personal projects when you're looking back at your previous code. When you create and initialize a string variable, you might want to give it the value of an empty quotes, and this will just default the value to essentially nothing. You're giving it a value, but at the same time the value doesn't actually contain any sort of characters. If we print this out to the screen, then you won't really see anything. This video is going to focus on string.empty, and string.empty will actually just represent these quotation marks. String.empty will represent these speech marks. So what we can do is we can type in string using a dot, and then we can type in empty. Just like that, we've initialized our string name to a value of empty. Now, this isn't necessarily used when you're declaring and initializing it, because this is almost identical to just defining a string on its own. Main reason why this is used, let's say we actually ask the user to input their name. So we can say a console.write, enter your name, and then we can take this string variable, move it down, using Alt and then the arrow keys, and remove this, and let's initialize it to a console.readline to read in the value from the console. And now what we can do is, using our string interpolation method that we just learned, we can print to the user your name is, and then the name in the curly braces. Now let's just see what happens. So let's actually type our name in, Abba, and it says your name is Abba. But what if the user just types in nothing and just presses enter? Then it still says your name is blank. Now let's see what we can do here. We don't necessarily want to say your name is blank, we want to check what this value is. So we can say if the name is not equal to empty quotation marks, then we can output your name is. And then else we can say name is empty. And then if we run it now and press enter, it says name is empty. So we can use string.empty instead of these quotation marks. This looks a lot better when you're trying to compare it. Abba, your name is Abba, and then when we press enter, it says name is empty. This just helps to keep your code a lot tidier, just so you don't have to write the two quotes. If you accidentally put a space in there, now your if statement is incorrect. If you always use string.empty, then it just helps you to make sure that your code is going to be maintainable and readable in the future. Reading string.empty gives you a better representation of what's going on instead of two open quotes. If there is a situation where you want to check if one string equals another string, then you can do the following. If message equals compare, then we can print out same, and then else we can print out different. And as we can see here, they both have a capital H and they both say hello, so they should be identical. Let's run the code and find out. So they say same, which is exactly what we'd expect. So we have another method of being able to do this. So even though we can apply equals to two strings, it's normally better practice to use dot equals and then place the other string inside the brackets. So you're saying if message equals compare. Now if you run the code, you'll see that it's the same output. In certain circumstances where you want to ask what the user has entered, enter your name, and then we can use a string name equals console.readline. We can say if the name does not equal to empty strings, then from there what we can do is type in your name is plus name, and then we get some output. Abba, your name is Abba. But since we're checking if it's not equal to that, that means they've entered something in. Let's see if there's another way that we can actually write this. So if we just duplicate it and comment it out so we've got it for reference, So what we want to do is we're checking if name is not equal to empty quotes. So we can say name.equals empty quotes. But what this is telling us, if the name equals empty quotes, then we should do this. So then what we can do when we learn about the if statements is we can use the not operator, and we can say if the name not equals to empty quotes, then we proceed with this line. Else we can just say invalid name input. And let's run that and see what happens. If we type in ABBA, then it passes fine. And if we type in nothing, then we get an invalid name input. The reason why equals equals and the dot equals function are different is because lower level using equals equals will actually compare the reference in the memory. And the reference in the memory is what's used up when you actually create these variables. So what this is doing is it's comparing the value that's actually stored in memory to the other one that's stored in memory. Now the problem is when it comes to something like arrays, where you actually have the same value, but they're slightly different. Let me demonstrate. So I'm just going to use this code because we haven't covered arrays yet, so I'm just showing you an example. If we have a chart array that literally says hello, and then we can use this line of code to join them together, but this is actually an object instead of a string. But if you see what we can do in the if statement, we can say if the message, which is equal to hello, we can use message.equals and we got the new compare. And this is actually an object. So now we're comparing a string with an object. And generically speaking, an object can hold any sort of value because all of these variables that are strings, ints, double, etc., they're all derived from something called an object, which is just a very generic way of storing information. So since these two data types are a little bit different, they still evaluate to the same thing. What the equals function is doing is actually checking the literal values of the variables instead of checking the values that are held inside the memory address location. And the difference here is, even though we have a character array that is giving us the values hello, and our string is also giving us the value of hello, if we run this line of code that uses .equals, then you'll actually see that the second same actually represents the bottom if statement. So what that's doing is it's actually giving us back the comparison saying that it's true. And it is indeed true because hello is literally equal to hello. But if you were to use the double equals, then what you'll realize when you run the code is now it will say it's different. Because what it's doing now is it's taking a string object and comparing it to an object. And they are not different because of their memory. And that's what the equals equals is comparing. It's not only comparing the value, it's comparing the memory address location. And that's going to be vastly confusing because you don't want to hit these situations. So it's always best to use the .equals function because the equals function is concerned about the values rather than where they are in your memory. I hope that made sense and it wasn't just confusing. But basically when you use equals equals, it checks the values that are actually wrote in your computer's memory instead of the value itself. It will do both. It will check the memory and check the value. Whereas when you use .equals, it is only concerned about the values. And that's all that matters when we're doing an if statement like this. We're checking if they're both the same. So it shouldn't really matter how and where they are stored. The only thing that matters is the values contained within the variable. We're only caring about the values and not where they're stored. So when we have a string variable defined in C#, we have it like this. And when we print it out to the console, we get the entire string being displayed. But what if you want to return the first element back and not the rest? Then what are your options? So in the later video in the course, we covered the substring function. And technically you could go from the first character till the second character and you will just get C back. So that's index 0 till index 1 and you'll get the C back. Now the problem with that is that's an extra function call for something that should be quite simple. And it is. A message is a string, and strings tend to be an array of characters, which is similar to this. We haven't learned about arrays so far and we'll cover that in the next section, but what an array essentially is it lets you store multiple of that data type. So we could have a chart array that holds exactly the same value, and each position will hold each one of these characters. And the reason why I mention this is because with strings, you can use the square bracket notation. So if you add some square brackets at the end, it says here it returns back a char, and it takes in an index. Gets the char object at the specified position in the current string object. So if we use message 0, you can see that returns us back with a char. Char right here gets the char object. So we can call this on a string and it can return us back with a character. Because like I said with the array of characters, that's essentially what a string is. Each one of these is just its own independent character, and a string lets you pair them all together. So if we print this out, then we should get C, because it's 0 based. So if we copy this down and use 1, 2, and 3, then what should we get? We get C#, then we get actually nothing technically because it's a space character, and then the third character, which is the fourth in the list because it's 0 based, is going to be our I. So let's just print this out to the screen and see what happens. There we go. So even though we don't see it visually, there's actually a space character right there. And that's the third character in the list, which is right here. So of course we don't tend to know how long the string is unless we can see it visually. And if you were to reference one of these values and the string is not actually that long, then you have a problem. Let's demonstrate. If we have the string just called C# and let's comment out the rest, then that's only 2 characters, so only 0 and 1 will be applicable. These two will return back something. Let's have a look and see what happens. So the first character and the second character will run fine, and let's put a console read line in there just to break it up so the other code doesn't run yet. If we run the code, we get our C#, and that's the max length of our string so far. It's 0 and 1. Now if we press enter, let's see what happens. We get an index out of range exception. Index was outside the bounds of the array. And the reason for that is we only have 2 characters inside our message and we're trying to display the third and the fourth. This is problematic because we literally don't have any of them characters to display. So what we can do instead is actually write ourselves a little loop to go through the entire string and return us back all of these character positions instead of us just guessing how long the string is. So if we return this string back to normal, and then just after this little section, we can write a for loop. Int I equals 0, and I is less than message, and then we have access to .length. This gets the number of characters in the current string, so we don't have to worry about the maximum length in the square brackets. We can always rely on .length because we don't have to keep track of it, and the language can know that for us and give us the value. In this case, we're going from 0 to whatever the length of these characters are. And then in here, we can actually just console write line, and we can do the same notation we did here. We're saying we want to print the message, but not only the message, we want to print the index. And the index is going to be I in this case, because we start at 0 since it's 0 based, and then we're going to the last character. So let's print this and see what happens. So now we get C# is awesome from here down to the bottom. C# is awesome, print on every single line, and that's a little bit annoying to read. So what we could do is just change this to a console write, and maybe we can just comment this section out just so we can see this properly. There we go, so we get C# is awesome, and because it's a console write, it's writing them all next to each other, and they're being printed out one by one. Let's add a cool little effect that can demonstrate you for now. So inside the system.threading library, we have this sleep function. So what we can do is we can add another using command, system.threading. We already have threading.tasks in there, but the function that we need is inside the threading library. So there's 2 ways we can write this. We can actually write everything by hand like this, .sleep, or you could just remove the system.threading because we've added it at the top. If you don't want to add it at the top, that's not really a problem. You can just include it straight into here. Adding it at the top will include it within the entire project, but if you're only going to use it once or twice, then sometimes it's better to just include it straight into here, because it'll make your overall program size a lot smaller. So let's just keep it in so we can make our code a bit more readable. So we have thread.sleep, and what this will do is it will suspend the current thread for a specified number of milliseconds. There's 1000 milliseconds in 1 second, so what we can do in here, and we're trying to mimic a typewriter effect, so we can say something like 200, which will be roughly a quarter of a second. So if we run the code now, let's see what happens. So we get this cool effect where after it prints out each of the characters, it will print out the next character only after it's been asleep for a quarter of a second. And that looks kind of cool. If you wanted to speed it up, you could just decrease this number. There you go. Of course, if you make it too low, then it might be too fast for you to actually acknowledge what's happening. And if you also make it too slow, then it's just going to take too long to turn off, and at that point you can use Ctrl+C on your keyboard or use the stop button at the top to terminate the program. Okay, so let's have a look at another thing that we can do with this. So maybe we can make this 100 for now. In the previous videos, we've used a function called contains. And let's say we're just checking if it contains C, and we know it does because we can see it visually. Let's run the code, and we see we have true being printed. And the reason why true is actually on the same line as C# is awesome is because we're using console.write here, so it's actually not made a new line character just after the E, so when it's printing true, it prints it straight after that. So what we can do to fix that is just place a new line character in here using console.readline, and we can just drop this a little bit lower to 50. There we go. So we have true. And what we can do with this is we can actually make our own little version of the contains function. Let's demonstrate. So if we make this exact for loop again, int I equals 0, I is less than the message.length, and I++. So first let's kind of understand what's going on with this function. Returns a value indicating whether a specified substring occurs within this string. And what that means is it will return a Boolean for us. If C is inside our message, then this will return back true. And we know this is true because we just outputted it to the screen and we can see this visually. So what we need to do is we need to loop through our message and try and figure out if we can find C inside our message, and then we can give back a value of true. So maybe we can do a bool contains equal false, and the reason why we initialize it to false is because we want to set it up telling it that we haven't found it, and then inside the for loop, if we find it, then we can set it to true. Let's have a look. So after the for loop, we can print contains to the screen, and then inside the for loop, what we can do, as we've seen here, it returns back every single character. So you'll get back C, sharp, then the space, then I, then S, and so on and so forth. And what we want to do is we want to go through each of the characters and then just ask if the variable is equal to C. If C is equal to C, then we can assign this to true, and then go through if hashtag is equal to C, if space is equal to C, and so on and so forth. So we can write an if statement here that says message, square bracket I, is equals to, apostrophe C. And the reason why it's an apostrophe is because this is a character, and this also returns us back with a character, so we need to compare them both like that. If we use a string in here, then it might complain that we're trying to convert between a char and a string, and it won't let you do the equals equals operator between two different variables. Maybe what we can do instead is to follow the approach that we used before and use the equals function and place our C inside here. So if the character that we're currently up to inside the for loop is equal to our C, which is what we want to search for, then we can set our contains variable equal to true. We don't need to write an else statement in here to set our contains to false because we've already gave it a value at the start. If we didn't have this value, then it would be beneficial to do this. But since we have it, then we can remove this other path and we don't exactly need it. So let's have a look and see if this works. Perfect, it says true. Maybe we can change this character to something like A and make sure this works, which it does as well. So perfect, so now we've made our own mini little contains function inside here, and we can also use the C# library one. But the purpose of this exercise was just to show you how we can iterate through a string variable and then decide what each of the characters can be equal to, and then we can decide if they're equal to another one, and then let the user know that we found a match for their search term. So far in the course, we've covered the equals function and the contains function when you're searching through strings or trying to find values. Let's have a look at a method that makes sure a string is valid before we can process information on it. So in this quick example, we have a name output, we read in the value into a string name, and then we simply output it to the screen. If we run the code and just press enter, then it says your name is blank. And we don't really want that because we want to check if your name is equal to something before we continue. So let's look at some methods. So we have if the name is not equal to nothing, and then let's just print 0 to the screen. And that's one of the methods. And we can say if name is not equals to quotation marks, then let's print out number 1. So what this is doing is checking if the name is not equal to empty quotes, and then this is doing exactly the same thing, except we're using the equals method. And let's just run the code and press enter, and you can see the 0 or the 1 doesn't appear because it's detecting that it contains nothing. So if we type in a real value, we can see 0 and 1 coming up. So these are both valid ways of checking if the string is not empty. So let's look at a third one. And this one is actually very important for reasons I'll explain in a second. So inside our string library, we have IsNullOrEmpty. So we place our name inside here. And let's see what this says now. Indicates whether the specified string is null or it's an empty string. So this can be very effective. So what this reads now is, if the string is null or empty, then we print a value. But we want it to be not null or empty because it wants to have some contents. So if we type a value in again, you'll see now we get all three numbers. And what them three numbers mean is that it's passed all of these checks, and each of these checks just ensures that the value has got something inside. And that's fine. But it can be slightly problematic for this reason. Using this method and this method are fine in some cases, except as it says here, it checks if the string is null. And null means it doesn't have a value, but it just has nothing instead of something. Let me demonstrate. If we assign the value of empty quotation marks, this actually has a value, but the contents is empty, but it's still a string as it comes up in here. If we assign this the value of null, then it's just a keyword that we can use to denote that this literally has no contents. It's not that it has an empty string, because an empty string is still actually a string, whereas a null, it just means the variable is blank. Now this is where the issue arises. If we try and call a method on something that's null, watch what happens. We actually get an exception and our program just crashes. You can't run any code on something if that variable is actually defined as null. It doesn't mind if you check the value of it, but if you try and run a function, then you've got a problem. So if we comment this line out, this ensures everything. It ensures it's null or it's empty. And this is the belt and braces option, because if it's null, we don't actually get an exception when we try and run this code. As follows. We get the 0 showing up because our variable has something that's not speech marks, and it's actually null. So we want to avoid this option as well, and also avoid this option in case our string is actually genuinely null. Using IsNullOrEmpty will check both for the value of null, which it is right now, and if it's got empty quotes, e.g. the value is empty. So if we just run this again and have these two paths commented out, we can see that 2 is not appearing. If we change this back to our console read line and we try and do it, then we get our number 2 because it's validated that this string variable is got something inside it and the variable is not actually null. This is a very good way of being able to make sure that your program doesn't get exceptions, as we'll call in these equals. If you want to call equals, then call it inside here. You can check if that variable equals something by simply placing that if statement inside here after you've validated if the name variable actually has some contents. If it's null or it's empty, running equals on it will just break the code further. And you don't need to check if it's equal to something in here. Maybe you were checking if the value is equal to ABBA or something along them lines. And now if we run it again, we actually get the output correct. It's best to nest them like this because if you run this function on something that's null, it's actually really safe. But as you saw previously, if you run a function on something that's null, then you're going to get a null reference exception and your program will close down and break. You want to avoid exceptions at all costs, so nesting it inside a IsNullOrEmpty check will be perfect for your code. It improves the stability of your program to ensure that exceptions don't happen. So in this exercise, I want you to ask the user to input any message, and then I want you to print the message in order, character by character, and then also print it in reverse, character by character. Let's get started. So we could just have a console write line, but let's change it to a write and just say enter your message, colon, and then speech marks, and then just have a string message equals console.readline. Perfect. So in order to be able to loop through the string message, we need to have a for loop. If you remember from our previous videos, we can have this string variable followed by a square bracket, and then we can have an index inside, and that will print us back any sort of index based on that position. So if we just have this is a test, then it's going to print as the t because that's the first index, and so on and so forth. So what we can do with this information is take what we can do with this string index and then also use the property which is .length and then use these two values to be able to process. This is a test. So we have the first character, square bracket 0, and the last character is at length 14. So our message variable now contains 14 characters. Obviously when I close the program, then that value is lost and I have to re-enter it. But because of that exact reason, we would always use .length, because we never know how long the user's input is going to be. So we can have a for loop, so we can say for int I equals 0, I is less than, and we can use the message.length here, and then we can say I++. So we want to start at 0 because our first index position is indeed 0, and we want to go from the index 0 all the way till the length. Now in that example, I just printed out 14 for the length. But what you got to realize is there might be 14 positions, but there's only 13 indexes. So it's not actually 13 index, it's just up to 13. When you start at 0, going from 0 to 13 gives you 14 positions. So when we're saying 0 is less than the message length, then that'll actually take us from 0 to 13 instead of 0 to 14. If we made this greater than or equal to and change this to a 1, for example, then that's going to go from 1 to 14, and first we're going to miss out the first character, and we're actually going to go 1 over the message length. So you always want to start from 0 if we're going through the entire string. So this will go from 0 to 13. And then here we can just have a console write line and just print message square bracket I, and then just for the time being we can comment out these lines just so it doesn't saturate the output. So let's run this code and see what happens. This is a test, and then we get them all on separate lines. Maybe we can just use a console.write instead, so we get each character on the same line instead of a new line character being outputted at the end of each of the lines. So we can say this is a test again, and there we go, we get this as a test outputted as well. So now that we've printed that in order, let's see how we can print it in reverse. So just a quick little tip, throughout this course I've been quite hard on you. I've made you write the for loop out exactly the way it should be, but all done manually. This is so you can get used to the syntax, and after a while, once you understand exactly what to do, then what you can do is when you type in the for, you can see that it says there's a for snippet. Tab twice to insert the for snippet, and we can do that now. And then it actually gives you a little bit of an output. You can see these sections that have been highlighted. The reason they're highlighted is once you're done with one section, you can actually press tab and it'll jump to the next one. So now my cursor has jumped on the length, and we can type in message.length. If I press tab again, then it'll just keep cycling through them until we're done and we can press escape. Upon pressing escape, then it gets out of the little message, and there we go. We've now just defined a really quick for loop. Please only use this once you're comfortable with writing for loops, and don't use them immediately because you might get stuck on what to do and how to do it, so it's best to always write the for loop syntax out from scratch so you can get used to the 3 different sections. So this is actually a for loop that goes forwards. It's going from 0 to 13, but what we actually want to do now is go from 13 to 0. So let's actually change this for loop completely, and we can do our little shortcut again. So if we do for, and then we don't actually want to start on the value of 0. We want to start on message.length, and then you want a -1. And just as we said here, we never actually want to get to the length because we want to go from 0 to 13. So if we want to go backwards, we want to go from 13 to 0. And the only way that we can get this 13 is by getting the 14 value, which is message.length, and simply minusing 1. So now that we've got our first variable, which is int I equals message length -1, which will give us the 13, we want to go from I, and instead of less than, it's going to be greater than or equal to, and then we actually want to change this to a 0, because we actually want to stop at 0 in this case. And then we don't want to use I++, because if we start at 13, we want to go down in 1 instead of up in 1, so we can simply just do -. We can take this exact line and print it out to the screen. And if we just print something small in between, like a hyphen, just to separate the 2 outputs, and let's see what happens. Test. There we go. So we have test, and then T, S, E, and T is now in reverse. But now you might be wondering, if we had a shortcut for the for, what's this for with an additional R? Code snippet for a reverse for loop. So if we tab twice, you can see that we have exactly the same format. Int I equals something -1, which we have right here, and then with I is greater than or equal to 0, as is we have here, and then we have I minus, just like here. So we can literally just change this into message.length, and then these two now are exactly the same. So just copying this down will get us exactly what we need. But obviously we just wrote this, I just wanted to show you the shortcut. So let's try it with a longer string. This is a test. There you go. And if you wanted to, you could just print these on separate lines. So you can just change this into a right line, for example, and have it like that. It doesn't really matter. The rest is up to you, but the task is just so you can print it one way and then print it the other way. I realized that what you can also do is just simply print a console write line and have message in there and just get rid of this completely. And the output will still look exactly the same. There you go. And the reason why I told you to write the for loop is not because it'll be easier if you do this, it's more for your educational learning purposes. Having more practice to how to iterate a string variable is very helpful for the future and you can understand it fully. If you just print it out to the screen, then you're not learning anything extra, you're just applying what you already know. So let's just have a quick recap. We asked the user to enter the message, we store it into a string variable, and then I demonstrated that you could use the square brackets to output the first index. Then you can output the length of the entire variable. Using a for loop, you can go from 0 to message length, which will give us from indexes 0 up until 13 in this case, and then we can go through I++, incremented in 1, and then we can have a console write, which will just print out message index I for the index that we're currently up to, and then we break it off with a console write line just in the middle, because these are printing on the same line, so we need to insert a new line character at the end. After we've done that, what we can do now is print it in reverse. And now we can do exactly the same thing, except from 0 to 13, we go from 13 to 0. So we start at the message length -1, because the length was 14, and now we -1 to get to 13. And we're going from I is greater than or equal to 0, because that's the value that we want to stop at. And then we can do I minus minus. If we were to take out this equals operator, let's see what happens. Test. And now we're actually missing the last character, because what we've done is we've actually went from 13 to 1 instead of 13 to 0. So let's put that back in and make sure it works. And then we have t set for test. And then we're outputting the exact same thing in both for loops, because we're simply just printing the character that we're currently up to. And because this for loop starts at 0 and this for loop starts at the length -1, then they output in the same values, or what it appears to be the same values, it's just starting at different indexes. In this exercise, we're going to be building some sort of a password validator. These can be present in something like a register form, where you ask the user to enter their password, and then enter it again to make sure that they've entered it correctly. If you want to ask the user to enter their password in twice and store them both, check if they both contain something. If they do, we can print out password match. If they don't, passwords do not match. And if they both contain nothing, then you want to output please enter a password. So let's get started. First, we can have a console write. We can have enter password, string password equals console.readline. And then we can just copy these two lines down using Control D. And then we can have a password C for password confirmation. And we can say enter password again. And let's just print these out to the screen just to make sure we know what's going on. Just like so. So we can have ABBA and then ABBA again. So now we have both ABBAs stored and that's fine. So let's see what we can do now. We need to check if they both contain something. So what are the different ways that we can do this? So we can have if password dot equals, and then we can make it equals to string.empty. And because we want to check if it's not empty, then we can simply place the not operator right at the start. And then we can join them with another one, not password dot equals, and then exactly the same thing, string.empty. But in this case, we don't want to use password, we want to use password C. There we go. So if we've came into here, then that means they must have entered something. So let's just quickly do our exit path, which is if they're empty, please enter a password. So we can say else, and we don't need a condition here because if this were to fail, then it has to mean that their password's empty. So we can have a console.writeLine, and we can just do please enter a password. And let's just test if this path works first, and we just press enter twice, and we get please enter a password. And maybe if we type something in for both, and then we get nothing, because it's actually came into here now. Perfect. So if we come through and we can say password equals password C, or we could use the equals function and we can say password.equals and then password C. And if they both equal to each other, then we can print out passwords match. There we go. And if that were to fail, then we can print out passwords do not match. Here we go. Let's run that and find out. ABBA and ABBA, and we get passwords match. And if we try ABBA and ABBA with 2 A's, and then we get passwords do not match. So what are some other ways that we can do this? You can structure this completely differently. Right now we're doing both checks in one single if statement, and we can actually split this up into 2 and then provide a different error message. So right now this says please enter a password. You might have entered the second one but not have entered the first one, or vice versa. But it doesn't matter because you have to enter both of them in order to pass this validation check. So what you could do instead is actually put another if statement inside and paste this one inside here, and then just keep these as 2 separate if statements, and then you can actually provide different error messages. So let's nest this in one deeper. So we can say if the password is not equal to empty, and if this returns back true, then this variable has something inside it. And then once we go inside these curly braces, we get another check, and if the password C is not equal to nothing, then that means if we came in here, then we pass both of these validation checks and both of them contain something. And then we can proceed to check the variables. So what you can do in the first else statement is you can say please enter a password. But on the second one, so just after this curly brace, we can have another else statement, and we can say please enter a password confirmation. So I know that was a bit quick, so let's just have a quick recap. So we can have one if statement that processes the first password that you type in. And if this is empty, then it says please enter a password. And if it's not empty, then it'll go inside this curly brace, hit the first line, and check if the password confirmation is not empty. If it is empty, then it'll say please enter a password confirmation. If both of these return back true, then it'll go inside the success path, in which it will actually check if password is equal to the password confirmation, and we can say the passwords match, or if they don't equal to each other, we can say the passwords do not match. Let's run that and see what we get. So if we type something in for the second one but not the first one, so for the first one we just press enter, and then let's type something in for the second one, and it says please enter a password, and then if we run that and do the complete opposite, type in P, and then press enter for the second one, then it says please enter a password confirmation. So you can see immediately what we can do is provide a different error message for different situations. If you include these both in one line, then you can only give out more of a generic error message. This is similar for when you go to log in, and when you get your password or email wrong, it doesn't say which one you've got wrong, it just says them generically which one you've got wrong. It says invalid credentials or invalid username or email. It'll say them generically like invalid username or password, but it won't tell you which one it is because hackers can exploit this and you don't want to be doing this. But in the case of a password confirmation, and this is just for a register form, then it's not exactly the worst thing to do this, because sometimes what you'll see is the text boxes might go red to indicate that they're both not equal to each other, and this is fine on registration, but it's not fine on the login. What we can also do in here, once we've checked if they're both not equal to something, we can actually just validate how long the string needs to be. We can have if password.length, and let's say you had a restriction on it can only be over 6 characters, and we can say 6, and password c.length is greater than or equal to 6. And once it passes all 3 of these checks, then we can check if they're equal to each other. If they've got something inside, and if they've got something inside, and if they've got both the length is greater than or equal to 6, then we can check it. So we can have something like password, and then this returns back with password matched. If we have something like ABBA, then it's actually returns back nothing because we don't have an else for this specific bracket. So we can say else, console write line, please enter 6 or more characters. So if we type in ABBA twice, then you can see we get this message now. Please enter 6 or more characters. So right now we have a validation for the first password and the second password and for the length, and if all these checks go by, then you can process the actual passwords that they've entered and check if they're equal to each other. You can technically do all of these checks in one line, it'll just be a pretty long line, but what that means is you can't have 3 separate error messages like this. If you have it processed in one line, the only error message that you can give is very generic. There's no one generic message that can fit for password empty and the confirmation password empty and for the length. So maybe what you could do is chain both of them to be check if they're not empty, so then you can process a message with something like please enter a password, and then you can have another check for the password length just to let them know that they need to enter 6 or more characters. Splitting these off into 2 separate checks is going to be very helpful because it'll let the user know something a bit better than a generic error message. So in the previous examples throughout the course, we've actually talked about using the toLower function. And I said in majority of cases where you want to actually compare 2 different things, you want to actually use the toLower function or the toUpper function. And you can achieve this by having toLower just here, and then also toLower just here. Now the problem with comparing if they're both equal to each other but checking the lowercase values is this is indeed a password. If you're checking if the user has inputted any capitals, lowercase, symbols, etc., then there's no point in applying a toLower function because that will just ruin their actual password and reduce the security. So in certain cases you don't always want to use toLower and toUpper for comparison, you want to just check the values straight up. And the same thing is when you're doing a login, you don't want to be checking their values lowercase because that's their login. These are some of the specific situations where you don't want to be using the toLower function if the data that you're processing is pretty sensitive and will be messed up if you use the toLower function. That you should always avoid it. Passwords fit this perfectly, and usernames as well. If someone's added some capitals inside a username, then you don't want to ruin that by doing lowercase or uppercase. If your username is spelt like this, and you try and log on like this, then they're not equal to each other, because this will probably be 2 different accounts. You can have an account with a capital B, and have an account with a lowercase b. So you don't want to be lowercase in their input and then doing a comparison, because what you might actually retrieve is a different account than you're looking for. So now that we've talked about stuff theoretically, let's see how we can do things practically. So as you heard in the last video, arrays are a way that we can store multiple variables of the same data type in one little group. So if you had something like num1 equals 5, int num2 equals 10, int num3 equals 15, and we had a similar case in one of the exercises like this, where we had to work out if a triangle was actually a triangle. So we asked the user to input 3 different angles, and then we stored them all, and then we added them up after, and it looked something like this. In total equals num1 plus num2, and then finally plus num3, and then we had some sort of if statement after to check if the total was equal to 180. And then we did something in the curly braces, just output that it's valid, and then else output if it's invalid. You can see how this gets a little tedious. We have to create a new variable every single time we want some more data to be stored. And in this case, we just simply want another number that we can store, but we have to just keep appending 1 to it. In that case, we could have angle 1, angle 2, and angle 3. But how about if we had something that just called angles? For now, let's just talk about how arrays work and how we can use them, and then after I've went through this example about arrays and taught you what to do with it, then I'll go get the code from the exercise from the triangle video and actually transform it into using an array so you can see what the difference is and how the new code will look like. So let's get rid of this little section. So now that we've got 3 integer variables, let's see how we can do this another way. So the syntax for arrays, you first type in the data type that you want, just like before, and then you add on a square bracket and a closed square bracket. There's nothing that needs to be inside as of right now. Then you press space and type in the variable name as per always. And then we can make that equal to new int 3. So what this side of the equal sign means is we want a new instance of an integer array and we want to have 3 positions. Since we have 3 variables here that we want to store, we need to have 3 positions to store them. So this line in total says that we want an integer array, we want to call it numbers, and we want to instantiate our new integer array with 3 positions. Instantiate is just the term that we use when you turn something into a new class. At this point, if we don't use new, then we're going to get a compiler error because it's unsure what this is trying to tell you. It's trying to store an integer inside an integer array, and that makes no sense. So it won't recognize the square brackets in this case because it has no idea what it's trying to do, and this syntax is completely incorrect, so the compiler doesn't know what error message to give you. So we can have a new int, and what we can do now is by using the square bracket reference, we can actually specify these 3 variables inside our numbers array. So now we have access to numbers 0 equals 5, and then if you use Ctrl D to copy this down twice, we can change this to 1 and 2, and then print 10 here and 15 here. So now this is exactly the same as this. We have 3 integer variables defined separately as 5, 10, 15, and now that we've created an array of numbers, we can specify all 3 of these values inside our numbers array. So instead of having 3 individual variables now, we just have one that holds everything like a group. And just to show you how this works, if we have a console write line, we can say num1 space num2 space num3. And if we use Ctrl D to duplicate that down, then what we can have instead of these num1s is simply just place these values inside. Changes to 1 and changes to 2. And what you should notice is these 2 lines are going to print the exact same values. There we go. So in this example, we've took our sloppy code that revolves around appending 1 to this number, creating a new array and then printing it out. So let's say we want to actually use these to read in values from the console. What can we do? And you'd use these exactly the same as how you'd use variables up here. This is just an integer variable at a specific position held inside a group. So we could simply have a console write line, delete the write and just say enter a number. And then instead of starring 5, we can say convert to int32, and then we can have a console.readline. And that will read in from the console, convert it to an integer 32, and then store it into the first position of our numbers array. And now if we just copy this down twice, and we can get rid of these 2 lines because this is just storing it statically, and add 1 and 2 to here. So now what we're saying is enter a number, store it into 0, 1 and 2, and let's see what happens now. So now we get asked the numbers 10, 20 and 30, and you can see that they've been stored here. Of course these haven't changed because this is still referencing our static variables up here. So what you can see in this example is now that we've made an array, we can specify each of the values very easily inside here. And if we wanted to have a number 4, instead of having to duplicate it and rename it and change the value, for example, we can just simply turn this into 4, duplicate this little section, and then just change it to a 3. One thing to note, in C# and many other languages, almost every single index will start at 0. In the last section, we covered the string functions, and they also started at 0 when you're dealing with strings and their positions. When you have a for loop with a string, then you always want to use index 0 as the first position. The same is true here. We have 4 positions, which means it goes from 0 all the way till 3. It never goes from 1 to 4 or from 0 to 4. These are bad values, it always goes from 0 to 3. You might be thinking, this looks really good, but when we go to print it, we're going to have to copy and paste this little section, add another one and rename this to 3. This gets a little bit tedious if we're just trying to print them all to the screen. So let's see how we can fix that. We can use a for loop for this. So we can have for int I equals 0, I is less than, and then we can have numbers dot length. And if you notice from iterating through a string variable, the syntax is exactly the same. We have a dot length property on the arrays as well, as we do with a string variable. So in order to print out this line, what we can do is print one of them every time we go around the for loop. Instead of using a console write line, we can just use a console write. So we can have console.write. And then what we can simply do in here is we can say numbers, square bracket, I, and then we can have a space right after it. Just to mimic what happens here, we have the number printed out, and then a space after it, number printed out, a space after it, and so on and so forth. So let's see what happens now if we run the code. 10, 20, 30, 40. There you go. So you can see that these 2 lines are exactly the same. And now what happens is, let's just comment these 2 lines out. And if we were to change this to 5, and we can duplicate this section, change this to a 4, and then now we have 5 variables stored, and we don't need to touch this for loop because the numbers.length will get updated anyway. So we can have 1, 2, 3, 4, 5, and you can see all 5 variables have been printed automatically. What also is quite tedious here is we're having to add another one to this, just so we can ask the user how many times that they want to enter a number. Again, this is quite tedious, but we also have a fix for that. Because we know how many times we want to ask the user to enter a number, then we can use a for loop to iterate through and ask the user. As you can see, every single line here is exactly the same except for the index position that we're dealing with. And the same is true for this for loop. This line will always be the same as we're printing out here, And the only thing that changes between this section and this section is the fact that this says 1 and this says 0. So we can translate this into a for loop to make it dynamic. And we can do exactly the same thing above here. So let's actually copy and paste this for loop because we want to do exactly the same approach. We want to go through all the positions inside our numbers array, and then we can actually ask the user to enter a number in. So let's block comment out this massive section, and then we can take one of them and place it inside the for loop. So now we're asking the user enter a number, and then we're storing it inside index 0. And of course, if we keep using index 0, then it's just going to override the first one and we're not going to store any data. So we can change that to an I. And let's see what happens when we run it now. 1, 2, 3, 4, 5, and then we get the 5 numbers being printed. This is awesome because what we've got now is 5 output commands coming straight to the console just from a for loop. The for loop is responsible for printing them all out to the screen, reading in the value, convert it to an integer, and then storing it inside our array. And then we have a separate for loop to print it out to the screen. What's really powerful about these two for loops that we've built is if we want to have 10 numbers now, we simply just change this to 10 and then just rerun the code. As you can see, we now have 10 numbers. There you go. So what we've just done, if we move this code down a lot now, just so we can have it close by, we've made our entire program that was actually pretty lengthy into just a couple of lines and 2 for loops. One for loop is responsible for looping X amount of times, X depends on whatever that number is, and then we go through and ask the user to enter a number, read it in from the console, convert it to an integer 32, and store it within the array. After this for loop has finished running, then we have all the numbers stored inside our array, and then we can go through and print them all out to the console. Another way we can print this out to the screen is by actually using a for each. So we can say int num, and then we want to be a number inside our numbers. So for each of the integers inside the number, we want to create a new local variable called num, and then we can use it in here. And if we take this line and copy it down, everything's exactly the same, except we don't need to specify the main array numbers now, and we don't need to specify the square brackets. We can just change this completely and replace it with num. And if we just make this number smaller so we don't have to output a lot of values, 1, 2, and 3, and you can see that they're exactly the same. There's no line between them because I don't have a console write line, so let's quickly add that in. And there we go, 1, 2, 3, and you can see they're outputting the exact same values. The reason why I needed a console write line is because these for loops are using console.write. The problem with console.write is, even after finishing writing all of the lines, it doesn't continue to the next line, it stays there. So if I don't break up the 2 outputs with the console write line, then all 6 outputs from the console write and the other console write will all go in one line. This is just for demonstration purpose anyway. Either one of these solutions are fine, more people tend to use this one. The problem with these 2 options is you can't always use them interchangeably. This one will always go through every single position. It will always go from 0 and it will always go to the length. The problem with this for loop is you can't choose how many times you want to iterate through before you stop. There might be a very specific case where you have a big array of data, but you only want to select a specific range. If you had an example where you had 1,000 array positions, so from 0 to 999, and let's say you wanted to request and run a for loop from 500 to 600. So you would literally type in 500 in here, and then 600 inside here. And this would be fine as long as your array has that many positions. But with the for each loop, if you run a for each loop on a 1,000 length array, then it's going to go through every single position. In some cases you might not want that, and you only want to go through specific cases. So if you know you're going to go through every single case, then you can use the for each. But if you know you're going to go through a certain amount of cases, then it's always best to use the for loop. Okay, so we covered quite a lot in this video, so let's just have a recap. So initially we started off saying we have our num1, num2, and num3, that we had our static variables stored inside there. And then we created our integer array, which is now down here. And just to make it a little bit easier to store multiple variables, because if you wanted 5 variables, you'd now have to duplicate that and change that to number 5, and this will get very tedious if we had something like 10, like before. This is very long, and you don't need to be specifying number 10 in your code, because this also hurts the readability of it. Using arrays can solve this problem quite a lot. You can easily specify an array using this notation, int square brackets followed by the name, and you make that equal to a new int 3. The 3 can be any number that you want as long as it's a whole number, because this tells us how many positions that we've got. We then outputted lots of values to the console and read them into our array, but we had the same problem as we did above, where we just had to keep duplicating the sections. So what we did to prevent that is by writing a little for loop that went through every single position in numbers array, outputted something to the screen, read in the value, converted it and stored it into the array, and then after all that was done, we can use a for loop or a for each loop and print that back to the screen. Now that we finished the base content of this video, and because I said at the start that I was going to take the triangle exercise and convert that into an array, so let's do that now. So now I've copy and pasted the solution from the triangle exercise straight into this project. I've just block commented everything above just so it doesn't interfere with our code. So let's just run this code to familiarize us with what's going on. So if we enter 60, 60 and 60, then it says valid. And if we run it again and enter something else that doesn't equal to 180, then we get invalid. So let's see how we can make this code a lot better by the use of arrays. So as we said before, we don't want to be using this angle 1, angle 2 and angle 3. Let's make an int square bracket angles equal new int, and then in this case we have 3 angles. And what you could do as well is you could say const int angle count equals 3, and then you can simply use that inside here. So later on in the code, if we wanted to specify this to a different value, we can just change that later on. So now that we've got the 3 angles, we can get rid of these 3 lines and write ourselves a little for loop. So I goes from 0 all the way to the angles.length, and then every single time we go around in the for loop, we want to say console.write, enter angle 1, and then we can say angles square bracket and not 0 in this case because we don't want to be specifying an index, as it will go from 0 to 1 to 2, we want to be using I because we're inside a for loop that's already going through all the indexes for us, and make that equal to convert to int32 and then a console.readline. Now we've got all the values stored inside here, let's deal with this problem. So if we just comment out the total for the time being, let's run the code. Oh, we have one more error down here, sorry. Let's run the code again. And we can say enter angle 1 and we can type the values in. But as you can see, we've got angle 1 for each of the times. What we can do in here is use our I index to print out the value. So we can turn this into interpolation and then wrap the 1 inside curly braces. And we can simply change this 1 to an I. And let's see what happens now. So we have enter angle 0 and then 1 and then 2. And this is fine, but humans don't like reading 0, they like reading 1, 2 and 3. So what we can simply do is say I plus 1. And because we're using I and then adding 1 to it, it's not going to affect the variable inside the for loop, so there's no problems by doing this. This is simply just for the output purposes. So now we can have 1, 2 and 3 just showing up like that. Perfect. So what we can do, now that we have all the angles stored, now we need to replace this line by writing a for loop that can add up all the values for us. So we can have for each int angle inside our angles, and we can just say int angle sum plus equals angle. The problem with this is we can't specify a new variable inside here and then use it outside an if statement. So what do we do? In this case, you want to take angle sum and initialize it outside the for loop and then give it a value of 0. And then inside the for loop, we can remove the int and we can say angle sum plus equals the whatever angle that we're currently up to. So if we had 3 values, that's going to say 0 plus 60, and then take that value and add another 60, and then take that value and add another 60. So it'll keep a running total for us. And if we just print out angle sum to the screen, let's see what happens. 10, 20, 30, and now we have 60, and that's the correct calculation if you add them 3 together. So now that we have a running total for angle sum, then we're pretty much done. If we get rid of this line of code, which is our previous total, and we actually bring back our if statement, there you go, there's no error now. And all this is doing is checking if the angle sum is equal to 180 and then print valid and invalid. So we can have 60, 60, 60, and it prints out valid, and let's just comment out our output. And then we can have 60, 60, 59, and then it prints out invalid, which is the exact same behavior that we saw at the start. So let's remove the extra code in here and keep it like this. There you go. So now we've got our solution just like this, and it's a lot better because if triangles were to transform in the future and we wanted more than 3 sides, then we can easily update this value. Because now that we're using arrays or we're using a for loop to enter out the values, what we can do, we don't actually need to store it. What I mean by that is we can actually just get rid of this array completely. Let me demonstrate. We can take this angle sum and place it underneath here. We can keep the count so we can use that in the for loop. So we're going from 0 to 3 because that's our angle count. And then we can get rid of all of this. And let's see what we can do now. So we have an angle count equals 3. So we go from 0 to 3, which will just do, as we said before, from 0 to 2, because it's less than the angle count. And let's just print this to the screen and see what happens. So the output's still exactly the same, but what's happening is these values are not being stored. They're just being shown to the screen and then not done anything. There is no equal sign here to assign it into anything. So what we can do is we can say angle sum plus equals the value straight away. And now if we try it, 60, 60, 60, then we get valid. The main differences between these two situations is, in the first one we used an array to store all the different values and then we added the total. But if we're not going to use these values after, then what's the point in storing them? We can just use a for loop to ask the user how many times they want to input the values and then just add them every single time that they add the calculation in. And at the end, we could just simply use a conditional operator to be able to print to the screen whether it's valid or not. But let me just undo that solution so I can show you the array solution and we can have a quick recap. That was just an extra little tip, just in case you wanted to know what different ways you could use to make this work. There we go. So let's just have a quick recap here. So we have a const int, which all we'll do is let us specify 3 inside here, and then we can use it here. This isn't entirely necessary, but it does clean up your code a little bit because it gives this number 3 a bit of a meaning. It says the amount of angles is our angle count. Having a 3 left over like this is what we call a magic number. They're quite bad because it hurts the readability of your code. People want to know what the 3 actually means. So if you bring in an angle count, then you can actually read, we want a set of angles and this is the amount that we need, and that's denoted by angle count. It adds text to a variable. It gives you a way of making sure that the text equivalent of a variable is present so someone can just read it. After we've created our integer, we can actually make a for loop that goes from 0 to the length, and then we ask the user to enter the angle. And in the previous example, we had enter angle 1, 2, and 3, so now we can mimic that by using I, but because I starts at 0, we want to use +1. Every time we loop around the for loop, we ask the user to enter the number, read it in through console readline, convert it using convert to in32, and then store it into the array. After this for loop is finished, we have all 3 values stored in the angles array, and then we have an int sum to count up all the values that we need. And then we use the for loop to go through every single integer value inside and make a running total and store it inside angle sum. Once angle sum has the total count, then what we can do is use console writeline along with a conditional operator to print whether it's valid or invalid to the screen. In this video, we're going to look at how we can use the built-in array functions to be able to sort an array. So if you have an int array called numbers, and then using the previous notation that we looked at, we can actually specify any numbers that we want using a comment delimited list. So if we just have 9 numbers inside here, then we've actually defined an integer array, and then the compiler can count the amount of items that are inside here and give it the length, but we don't have to worry about that ourselves. So if we use a for each, and we can just print int num inside numbers, we can do a console writeline on the new local variable called num. If we print it out, we can see all of the values, and maybe we can actually just use a console write followed by a space just to give them all on the same line. There we go. So as you saw before, if you had a string called test and we wanted to do something to it, for example, if we wanted to use the replace function, if we wanted to remove all spaces with an empty string, Then if we check the replace tooltip, we can see that it returns a new string. Most of the string functions will return you back the new string after doing something with it. But in this case, if we type in array followed by .sort and we can place our array straight in the brackets, what you'll realize is if you hover over sort, it will sort the elements in the entire array, but it will indeed return back a void. And void just means it returns back nothing. So in this case, what it's doing is you're actually affecting the numbers array straight away, and you don't have to do numbers equals array.sort numbers. For example, if we were doing the test replace, we would have to do this, otherwise this would just be returning back a string, but we wouldn't be using it. The same is not true for the arrays. When you run the array functions, they tend to return back void, and you don't have to do anything other than give it the array that you want it to sort. So now if we run this code, you should just see the same output since they're already sorted anyway. So let's change some of these numbers up and just see what happens now. There we go. 0, 2, 5, 5, 6, 7, 8, 9, 9. And that's it sorted, just like that. There isn't a whole lot to this sorting function, but what you should note is you can use this new array syntax to define how many items that you want in there, instead of having to change the amount of positions that you have using the square brackets. You can just denote any number of items that you want inside, the compiler will count them for you and place the length straight into the brackets for you so you don't have to worry about it. Using the array.sort function, all you have to do is give it the parameter of the array that you want to sort, and it will affect the array straight away and you don't have to restore it. And then we're just using a simple for each loop to print them out to the screen. In this video, I want to discuss the array reverse function. So if you had an int, numbers equal new int, and if you just had lots of numbers in here defined just up till 5, then we can add a semicolon. And again, using this array function, we can say array.reverse and pass our array inside. And then we can just use a for each var item inside our numbers and simply just print them out using a console.write. And we can use string interpolation and just put a space at the end. There we go. And if you run the code, then you can see our numbers have just been reversed. There isn't a lot to this video, I just wanted to show you about the different functions that you have available for arrays. These can come in handy when you have something like a list returned from a database, for example, and it's ordered in a certain way. And let's say you're returning back a list of lots of people who are ordered back alphabetically, and it's going from A to Z. And let's say you have some sort of user interface that allows you to flip the order. Instead of having to request the database to get the data back in the opposite order, you can use this array function to just reverse the list. The same thing goes if you're trying to order by lowest price or highest price, you can use this to show the different values in different orders. That's where this array function comes in handy when you have different situations like the names or the price by ascending or descending, where you can just flip the data instead of having to request it back from the database again. Flipping it locally is a lot easier than going back to the database, as that uses more data and more computational power on the back end and then return it to the front end. It's always best to be able to use these functions instead of having to use external things to be able to return back the same data. Using it locally like this will give us a performance advantage because it's done directly on the data instead of having to request everything again. If you wanted to do this manually, let's have a look and see what your options are. You can have your integer array just defined like this with a dynamic list, and then we can have a sorted array using the same length as the current array. And what you can do instead of using reverse, we can actually just comment these lines out. You can bring back a normal for loop, but if we use 2 r's, it gives us a reverse for loop. So the length is going to be our numbers.length, and the rest of the parameter is exactly the same. We want to go from the last -1 all the way till 0, and we want to decrement in 1. And we can say our sorted number I is equal to numbers I. But all this will do right now is just give us back the same value stored. So what we need to do in a case like this is make another variable, something like x, and we can store that into 0. And what we can say is x is assigned the value of whatever this numbers array is, because this is going backwards, but we want this one to go forwards, because we want it to be reversed, and we can say x++ and see what happens when we run it now. So nothing's going to come up because we don't have any output. So let's use a for each. We can have var number inside our sorted numbers. And we can just take this and place it in here and just print out the item. And we can use num. And there you go, it's been flipped. the exact same values, just the other way. So this is obviously a little bit more complicated because you have to use an additional variable, use a backwards for loop, and then increment your own separate variable, and as well as completely make a whole new array. Of course, you should only do this if you need it as two separate arrays. If not, you can always just affect the one that you're up to right now. Because I said before that arrays are actually static data and they're going to be fixed size, then there's no way to remove or add an item, but you can clear what you have already. So let's have a look. Array.clear sets a range of elements in an array to the default value of each element type. So the first parameter takes our array, so let's use numbers, and we want to start off at the index that we want to clear from, and let's just say 0. And because we want to clear the entire array, let's go all the way to numbers.length. And now let's just produce a for each var item inside numbers, and then just have a console write string interpolation, which just prints out the item followed by a space. And now let's run the code and see what happens. So we have lots of zeros in the console, and this is to be expected because, as we've talked about before, the default value for an integer is indeed 0. So all this is doing when it says it's clearing, it's just actually assigning all of the positions the value of 0. And we can mimic this quite easily through a for loop. So if we comment this out and write ourselves a for loop, int I equals 0, and we want to go to numbers.length. And then simply inside, we just want to say numbers square bracket I equals to 0. What you can also write is the word default. This will pick up the default value for the data type that you specified. You can type in 0 or you can type in default, it's up to you, but I think in this case, if you're trying to reset it back to default, then you don't have to worry about remembering it or any typos, you can just use the keyword default. So if we run this code now, let's see what happens. So effectively, we've mimicked what this function is doing. But let's have a look and see what other parameters we have access to. So if we comment this out and drop the value, then you can still see we only have one constructor. Normally you'd see the up and down arrows on the left hand side to say one of two. In this case, we only have access to one constructor. It will only give us a range of elements we want to remove, but really we just want to clear. It does say here in the tooltip, the array whose elements need to be cleared. And because it is a clear and not a remove, you've got to remember when using this function, it doesn't actually remove any of the positions, it just resets the values inside the array. So what we can do in this case is we can say numbers, 5, 5. And what that will do is, the first parameter is where you want to start. So if you want to start at the 5th position, and then we want to count 5 forward. And because we have 10 numbers, then this should return back okay. Let's comment out this for loop so it doesn't take an effect, and let's run the code and see what happens now. So now we took the position 5, which is actually the 6th number because it's 0 base, and said we want to remove 5 forward, so itself and then 4 more forward. And there we go, we have 5 numbers being removed. So instead of removing all of the different values, we can actually clear a certain amount that we want, and to mimic this in a for loop, we can do the following. We can start it at 5, and we want to go to 10. And let's run the code, and you can see the output is exactly the same. When doing it in a for loop, you need to actually calculate what this is going to be. So we need to take both the numbers, the 5th index and the 5 length, which is 5 plus 5, and then we get 10. And we don't make this less than or equal to 10 because we have 10 numbers. So you actually want to go from position 5 to position 9, which will equate to less than 10. We actually want to go from position 5 all the way to position 9, which actually covers 5 numbers. 5, 6, 7, 8, 9. Even though it feels like the difference between the two numbers is only 4 because 9 minus 5 is 4, but we actually have 5 numbers between that. 1, 2, 3, 4, 5. There we go. So when we print the values from 5 till less than 10, we're going from 5 to 9, which is exactly what this is doing. This is the index that you start at, and this is how many numbers you want to count forward. So let's just have a quick recap of this function. We defined our numbers array. Using array.clear, it doesn't actually clear the values, it just gives us access to removing them back to their default values. It doesn't actually clear the array, it just resets the values back to their default type. We can have numbers parameter, which will equal to our array, and we want to say we want to go from index 0 all the way to numbers.length, which will be every single value inside the array. And all that will do is go through the array and set them all to their default value. which is similar to what this for loop is doing, and before we had int I equals 0, and I is less than numbers.length, and that will go through every single position. You can technically use 0 instead of default, but that would mean you have to remember the default value for every single data type. It's easier to just write the default keyword, and it doesn't promote any typos. Using the default keyword is by far the easiest and the most safest option if you're going to have this situation. So making every numbers index equal to default, in this case because we're using integers, it's going to assign the value of 0, and then after this for loop's run, with I is 0 and I is less than numbers.length, it's going to make all of these positions equal to 0, which is in essence what this function is here for. Because arrays can't be added or changed in terms of the values that they have after they've been created, you can only really modify what's already there, or you can reset them all back to 0. Using this notation from 0 to numbers length, you can get rid of all the values and make them all 0. Using 5 to 5 means it'll start at index 5, which is the 6th position, and then go 5 numbers forward, so it will delete these and reset them back to 0. You can mimic this in a for loop just like this. Start int I at 5, and then go to less than 10. And the reason why it's less than 10 is 5 plus 5 gives you the 10th index, but because its I is less than 10, you actually want to go to the 9th index, because from 5 to 9, that's actually covering 5 different numbers. And then we can go through and assign the default value, and then when we print it out, you'll see that all of these numbers have turned into zeros, just like so. Searching through arrays are very helpful when you try to find some data inside your array and you want to return back the position to maybe do something else with it. So let's have a look at this example. So we have a numbers array, and let's say we want to search number 199 and find the index of it. So first let's ask the user what the number they want to search. Enter number to search, then we can have int search is equal to convert to int32, and we're converting the console.readline. And then let's have a look at the function. So inside the array library we have an IndexOf. Searches for the specified object and returns the index of the first occurrence in a one-dimensional array. This is very important as it says the first occurrence, which means if there was another 199 at the end, it's only going to return you back this one and then stop immediately and not give you the value of this one. So let's have a look in the parameters and see what it takes. It takes our array and then a value. So our array is called numbers, and the value we want to search by is our variable called search. If you hover over the index function again, it says that it returns back an integer, 0-based index of the first occurrence of the value in the entire array, if it was found. Otherwise, the value is going to be -1. So we can say int position is equal to this. And because it says if it's going to be found, then it's going to have the value of a 0 index, and if it's not going to be found, it's going to have the value of -1. So we can say if the position is greater than -1, because if it's greater than -1, that means the value is 0 onwards. We can also write this by saying if the position is greater than or equal to 0, it's just up to you, they both mean the same thing. And then we can say in here, number search has been found at position. There we go. So let's run the code and let's do a perfect situation. So we can say 50, and you can see it says number 50 has been found at position 3, and that's the 4th index since it's 0-based. And what you could do if you wanted to is actually add 1 to this, just so it looks like a bit more of a readable number, because 4 is going to be the 4th number. 1, 2, 3, 4. And let's try find a number that hasn't came up, like 60, and it's going to return us back with nothing. This is really bad because it looks like the search has failed, which it has, but you need to output a message to let the user know. So have console write line and say number search has not been found. Let's type that again, 60, number 60 has not been found. So let's see what we can do to be able to write this function ourselves. If we just block comment this for the time being, we can actually use int position equals to -1. And the reason why I make it equal to -1, because when we read the tooltip with this index function, it said if it's not going to be found, it's set to -1. So why don't we set it to -1 first, and then we can try and find it. So int I equals 0, and we want to go to numbers.length. And inside here, we want to scan each of the positions. So we can say numbers square bracket I, and if that is equal to our search, then we can set the position equal to I. If the number we're up to is equal to what the user has typed in, then we want to set our position to the index we're currently up to. And we don't need to have an else because we've already set it to -1. And after the for loop, we can actually take this if statement and put it back down here because the code's going to be the same. If the position is greater than -1, which in this case is our default value, so in essence, if this value has changed, then this should always pass, e.g. we've found the number. So let's run the code, and let's type a number in, 30, and now it's found at position 5. Now if we try 60 again, number 60 has not been found. There we go. So this function is exactly doing something similar to this. It's going through every single position, finding the variable, and if they match, assigning the index, and then after just returning back to position, back to the console. So let's comment our example, and let's see what other variants of the function we can use. And let's comment back the first one. So using this line, we can duplicate it and just comment it. So we have some other parameters inside here. If we add a comma, we can actually give it a start index. This is the starting index of the search. And let's say you only want to search from the second number onwards, then you can just type in the number 2. So now if we run the code and type in 90, it's going to say 90 is not found because 90 is the first one. And let's try a value like 50. And now it says the number 50 is being found at position 4. Because now it's included in the range from 2 onwards. Because this is 2 onwards, it'll be position 2 until the end of the array. If you wanted a very specific range, then you can actually give it another value. So we can say we want to go from 0, and then we only want to go 2 forward. So if you run that now, and type in 22, it says it's not being found, because we've started here and we said 1, 2. So now it's only searching between 90 and 199. And if you wanted to include the middle ones, you could say you want to start at position 1 and go 2 forward, so now you get these 2 numbers and so on and so forth. So now if we try number 90, you'll see it's not being found because 90 is not one of these 2. The reason why you'd use different ones like this, if I revert back to the first one, this will go from 2 till the end, this will go a specific range, and this will go through everything. The reason why these exist is if you have a very, very big array, let's say it's 1,000 indexes, then you don't want to search everything unless you really need to. Let's say for example you had a names array and it was sorted alphabetically, and the person's name that you wanted to search began with an A. There is no point in running the search all the way from A to Z if you know it begins with A. And let's say for example you found the first index of the user that has a name B. So you have now the indexes from the start of the array up until the last array position that has the value of someone's name beginning with A. So now you have the 2 indexes of every single A name inside this array. If this was A, this was B, and this was C, and this was D, and you had these 2 positions, then you should only be searching all of the A names instead of searching the entire array. And the reason for that is you'll be searching lots more data for no apparent reason, and it's going to take an extra long time for searching something that you're never going to find. If you're searching for a name that begins with A, there is no point in searching for anything A, B, C, D, and so on and so forth. That's where you'd use the very specific range. You can say you want to go from 0 all the way up to the first B name, so then you're only searching the A names. This is just one example, and there is a lot more. Every situation is very unique, so use the parameters that you want, and always use the ones that can get you the best performance. The least amount of things that you can search is the best way forward. If you don't know what you're going to be searching, then you should always use the top one, which will just search everything. If you know where the value is going to be, or roughly going to be, then you can use this one or this one to give you a better range, and it's a bit more focused instead of searching for everything. So a quick recap of this index function, what it will do is it will return you back to position if it's found it. The position will be 0 based just as arrays are. If it hasn't found the position, then it's going to return this variable back with -1. So therefore, after you've run the code, you can check if the value is greater than -1, which will be from 0 onwards. If the value position is 0 onwards, then you know that that number has been found, and you can use the position variable to output that to the screen. If the value position is -1, it means the array index function has returned back negative, and the value position is now -1, so you can output to the user that it has not been found. Just in my little explanation down below, you can see that we can mimic this function by setting the value of position to -1, using a for loop that goes from 0 to number's length, and if you wanted to as well, you could use these inside here. If you wanted to mimic this goes from 2 till the end, so you can say I equals 2 and you still want to go to the length. This one goes from 1 and then 2 ahead, so you can actually put I equals 1, and then because it's 2 ahead from 1, instead of numbers.length, it'll just be I is less than 3, because 1 plus 2 gives you the 3. So in order to do this manually, you can loop through the elements that you want, check if the number you're up to based off the index position of I is equal to the search variable that the user typed in up here, and if you find a match, then you can assign the position to the value of I. After the for loop is run, you can check the same if statement as we discussed above. These are copy and pasted down below just to give you an example in this little section. All these arrays have static data, which means that when you initialize them with a certain length, you can't increase that length or decrease the length, you can only modify the data inside it and you can't delete any rows. If you create an array of size 5 and you only store 3 people in, then now you have 2 positions that are being unused. And that's unnecessary amount of data stored in your memory if you're not going to be using it up. In certain situations, like when you're making a game, for example tic-tac-toe, then you know you're always going to need a 3x3 grid. So a 2D array will be perfect in this situation because you know the exact width and height of your array, so you can do this perfectly. Whereas lists are quite dynamic. If you don't know how many people are going to be within a system, for example, if you're signing up some sort of register for a class or for a school or something of the sort, and you don't know how many people are going to be in that class, then you can use something called a list. And lists are dynamic because what you do when you initialize it, you just say that you simply want a list. And you can add items and you can remove items and you can also modify them. If you wanted to expand the size of an array, it's slightly complicated, but it's not impossible. So if you add an int, numbers equals new int, and let's make that length 4. And let's say we had a numbers array that we wanted to increase the length 5. We could have a new numbers, change that position 5, and then what we're going to have to do is from position 0 all the way to 3, which is our 4th length, from the numbers array, we're going to have to copy that into 0 to 3 of the new numbers array, so now they have the extra data, plus the last one, which will give us our 4. So that'll be 5 length, 0 to 3 gives us our 4 numbers, and then we have one empty one. So we've just made a new array and then copied all the data from numbers into new numbers. Now of course this is not really practical, that if you want to reduce the size or increase the size, you're going to have to do this each time. Of course you don't want to do this, you just want to use something called a list. So let's stick with an example and see what we can do. So you make this length 3, and let's just put 3 numbers inside here. If you remember from the array video, we can also declare it like this. We can say numbers 0 equals 1, and then 1, and then 2, and change these values. These two are doing exactly the same thing. I'm initializing it with 1, 2, and 3, and also just saying that all the positions in here are equal to 1, 2, and 3. So we don't need these twice, but I was just showing you as a quick recap. So we're declaring an array, we're calling it numbers, and we're giving it a length of 3, and initializing it to 1, 2, and 3. Now let's see the syntax to define a list. You start off with the word list, and then you have a left and a right arrow which makes a little section. Inside the section you actually want to state the data type that you want. So if we're copying the numbers array, we can have an int inside here. And that's it for the declaration of the data type. And then we can say new numbers or list numbers equals to new, and then there you go, it gets auto-filled for you. But let's just type it in. We have list, open the arrow, int in the middle, and then close it. So now it's the same on both sides. But because this is a new, we need to add a constructor so we can open the curly braces. And the first constructor says, initialize a new instance of the list class that is empty and has the default initial capacity. Press the down arrow, we can give it a capacity of the number of elements that the new list can initially store, so we can start it off with 5 length or 3 length or whatever. It doesn't actually matter, it just means that we actually have 3 positions available immediately if we place 3 in the brackets. And the last one, we can actually give it an entire collection. So let's say if we loaded a list of numbers from a database or a list of something from a database, and we can actually insert it straight into this list by putting a list inside these brackets. Of course, right now we don't have a list that we're going to assign it with, so let's just leave this empty and close the brackets and add a semicolon. So we could say list numbers.add, and then we can add 1 and then duplicate this down and add 2 and add 3. So now these two have exactly the same contents. Instead of doing this, you can have the same notation like this. So you can have the curly braces in here, and we can put in 1, 2, and 3. Now that's doing exactly the same thing. And you see, I can just keep adding more numbers in here and the list simply doesn't care. But as soon as I add one more into here, then I'm going to get a syntax error because it complains that the length is not equal to the numbers that we have. Because the lists are really dynamic, it doesn't matter how many you put in here because it can just go on forever, of course until you run out of memory. So let's have a little working example just to see how this works. So we can have a for loop and we can go from 0 to 10 or maybe 0 to 3 just so we don't have to enter as many values. We can have a console write that kind of just says enter a number. And then let's read that in and we can say int num equals convert to int32 and we can place a console.readline inside here. And then after we've got the console read line, we've got an int num that's been converted from the console input inside our integer num. And from there we can take our list numbers.add and we can add the num inside there, or if you want to reduce a variable you could just take this line and place it straight into here. Now if we get rid of that, when this for loop runs we'll have 3 iterations. Let's run the code and find out. 1, 2, 3. So now we've entered 3 numbers and now they've been stored in the list. So let's create a for loop after and we can go from 0 all the way to list numbers.length. But of course when we're using lists, we don't have a length anymore. When we're using arrays, we have length, because arrays have a fixed length, whereas lists have a count of the items inside it. So instead of .length, we simply use .count. And then inside here, we could just do what we normally do and say list numbers square bracket I. And let's run that, and we should see the numbers printed back out in the exact same order, 1, 2, and 3. And the same principle goes if you use a for each loop. We can say var item inside list numbers, and that's all you need to do, and you can just print item to the screen. Now we should see the same output twice. Let's have a look at other values that we have inside here. So we type in list numbers, dot, and let's have a look at the functions inside. So we can add, which we just used above, we can convert it to an array, we can remove a specific position, and we can clear it completely. They have other ones in here like binary searches. We can check if it contains a certain element. This is going to be very handy when we do our remove. We can convert them all to a different type. We have a copy to. We check if a value exists inside. We have a find, finding all of them. The difference between these two is the find will return back the first one, whereas find all will retrieve all the elements that match it. Finding the index of a specific match, finding the last index, iterating through them all. You can insert at a specific position, whereas the add will just insert at the end of the list. Adds an object to the end of the list. Inserts an element to the list at a specified index. And then you have remove, which gives you the first occurrence, so you could type the number straight into there. So you could ask the user, what number do you want to delete? And if they type 0, it will delete the first 0 in the list. And you can remove all, so if you want to remove every single 0 inside the list, you can do that as well. Or you can remove at a specific position. This is the most used function because what you can do is use the find index, search for an element that matches a condition, and then returns 0 based index of the first occurrence. So if you want to delete the number 0 from the list, you could use find index and that returns you back with an int, and then you can use the remove at and then pass that index straight into there. You can also sort it so it goes up in number order. We did this with the array.sort function as well. And if you wanted to, you can also reverse the entire list. This can be very helpful as we did with the array functions if you just wanted to reverse them all in case someone had something like a filter. When you're doing from price high to low and low to high, the difference between them two lists is simply the list flipped. So let's run a remove just inside here and let's see what happens. So we can say remove at and let's say position 0. So we type in 1, 2, and 3. You'll see that 1, 2, 3 gets printed out, and then I'll hit this remove at, and it will delete the first index. And in this case, the first index is going to be our number 1. So now this has become our first index, and this is our second index, and it's got rid of the number 1. So let's move on to a different data structure called dictionaries. Dictionaries are generic collections that store key value pairs in no particular order. They take in a T key and a T value, and these just mean the key and the value can be any data type that you want. Dictionaries come under the system.collections.generic namespace, and if you don't include this line at the top, then you'll have to type in system.collections.generic space dictionary every single time you want to specify a dictionary. Putting the namespace at the top will include it within the project, and you can use dictionaries freely. So one thing to note is the keys must be unique and they cannot either be null. Values can be null or duplicate because they're the values depending on the key. As long as the keys aren't the same, then the values can be similar. So let's have a look and see what we can do. We can type in dictionary, and you can see it has the arrows either side, and you can see here it says T key and T value. And what T key and T value is it gives us the flexibility to add any data types that we want. We can add in 2 strings in here, for example, or we can do anything that we please. So in this example, I just want to store a list of names, and I want to give them a unique identifier. And this unique identifier will just give them a number that their profile is up against. It's the same way whenever you make an account with any sort of website, when your data gets stored in the database, you have a unique ID for your account. And this is the same thing that I'm trying to replicate here. We have a unique ID, and with that unique ID comes a name. So we can say equals new dictionary, just like we do with the list. We can end the brackets and end the semicolon there, and now we've created our dictionary. And the exact same principle we can use with the list. We can simply type in the name of the variable of the dictionary and type in .add, and then we have access to int key and string value. And this parameter is going to change if this now becomes a string, as I'll show you now. And if we reopen the bracket, you'll see this is turned into a string key. So that will change depending on the data types that you specified. So let's say we want to add 1 and we want to add ourselves. Then we can duplicate this down and add in 2 and 3. And we can say test and test. And now if we run the code, you'll see that we have no errors and nothing's going to show up. I'm just demonstrating that it compiles okay. And the same thing with the list, we can also simplify the initialization process, and it looks something like this. So because this is a key value pair, we can no longer just type it in one line, they need to be in a little block. So when we wrap these around a curly brace, we can have the key on the left and the value on the right. And one of these is called a key value pair. Key value pair. And we will use these in the for each loop in a second when we print out all the values to the console. So let me just demonstrate something about what I said at the start. I said that all keys must be unique. And there's a reason why I said that. If we duplicate the first entry, therefore giving us the same key as 1, and we try run it, and let's see what happens, we get something called a runtime error. This runtime error happens when we run the program, and it's got nothing to do with compile time or our logic. An item with the same key has already been added. So we need to watch out if we do this because our program is going to compile, but it's not going to work at runtime. And let me demonstrate another fact. If we make this number 4 and our values are exactly the same, once we run this, it will still work fine. Values can be the same, but the keys cannot be the same. The keys have to be unique. So just like with our lists and our arrays, we can use a for each or a for loop to access this directly. So we can say for int I equals 0, and we want to go names.count. And the same reason it's a .count for a dictionary as it is for a list, but it's not for an array. Dictionaries don't have fixed lengths, and neither do lists. They are very dynamic and basically are a list. Lists can only store one different data type, whereas dictionaries give you a key and a value. So as we said above, we have a key value pair. So let's try and print this and see what happens. We can have a console write line and we can say names, square bracket I, and that'll give us back the position. The issue with this is it'll just give us back the string, and let's just see what happens if we print this. Then we get an exception because no key was given. And the problem with this situation is we can't use this like a list. Gets or sets the value associated with a specified key. What this means is when we give our square bracket I inside here, this is actually not talking about the index. This is actually trying to do a search on these keys. So if you actually change this to 1, then we should get ABBA return back. This is not actually doing an index lookup, it's doing a key lookup. And the reason for that is what we're going to have to do instead is say names.elementAt And then what we can do inside there is place our index. So this element at will return us back with a key value pair, as I said above here. So how this variable works is we can do key value pair, and then we need to specify this variable the same way we've got it up here. So we have an int, and inside a string, and then we can say pair, and make that equal to the function call element at, as that returns us back with a key value pair int string. And of course, if you wanted to make this a lot smaller, you could just simply use var, but let's keep it as key value pair just so you can understand what's going on. And the reason why we need to get the key value pair is if we want to retrieve the integer and we want to retrieve the string. And now we can use pair.key and pair.value. And because these are both integer and this one is a string, it matches our pair exactly. So we can take these values and go to our console write line, and we can say something like this. Use string interpolation and say pair.key, and then maybe add a hyphen, and then say pair.value, and then just remove these two lines. And let's try and run it now. There we go. So we get all the values, and it doesn't matter what this key is. It can be something random. It doesn't really make a difference. Like I said, this doesn't have to be in a specific order. So let's keep it as 1, 2, 3. There we go. So you can see using a for each loop to print this is a little bit more complicated. Let's have a look and see what it takes when you use a for each loop. For each var item inside our names. And as you can see here, our item is automatically a key value pair of int and string. And again, what you can do is type this straight into here, just so you can get used to the notation. And there you go, it's still a key value pair. And then now what we can do is we can take this exact line and paste into here, and instead of pair, we have item. And this should return us back the exact same values. And if we just separate with the console write line, there we go. Okay, so now that we've understood this, let's take a look at an example. Let's comment this out, and let's create another dictionary. So we can say dictionary, and then we can have a string of string. And we can call this teachers equals new dictionary string of string again. And we can add our curly brace just so we can add our values straight into here. So as you said before, we need an open curly brace and a close curly brace. And then we can say the math teacher is called Abba. And then we can add another one. And we can say the science teacher is called test. There we go. So we've initialized our teachers. And we said that the value that we want to give it is a unique identifier, which is going to be our string assigned to the subject. And this is going to be the teacher that is assigned to the subject. So what we can do inside here is we can have a console write line, and we can do something like this. So remember when I was saying in the for loop, we can't actually use the square bracket notation like this, because this is inferring to a key rather than position. So we had to use element at just to find out the key value pair and then to print it out to the console. So because the square brackets is an actual search, let's try and make use of that now. So we know that there's a math class available, so we can type math in here, and what that should return us back is Abba. There we go. So what that's doing is it's searching through our dictionary, finding this element inside here, and then returning us back with the value for that key. Gets or sets the value associated with the specified key. The problem with using this approach is it says here, if the specified key is not found, an operation throws a key not found exception. Let's just say, for instance, I mistyped the math, and now we're just going to get a runtime error, and it's going to be a horrible exception, and our code is obviously going to break. This is similar to what we do when we have int.tryParse. We don't just tryparse it immediately and convert it without actually checking if it's a valid value. So instead of doing this line, what we can do is we can check if that key exists first before we then use it. So we can say if teachers.try and get the value, which is similar to what we have with tryparse, and then the first parameter is the key that we want, which is going to be our math. And then out here is going to be the variable that we want to output out. So we can say out teacher, and then open the curly braces, and then inside here, we can print out the teacher. So we try to get the value for math, and if we found that key inside these, then we return back the value inside our teacher, the same way it works for our tryparse. You take in a string in here, and the output is going to be an integer if it's successfully parsed it. And if it hasn't, we can say console output, math teacher, not found. So let's try and run that. Now you see we get returned back Abba, and if we actually drop the lowercase, then it says the math teacher is not found. Alternatively, what we can do inside here, let's assume that this is correct, we can take this value and place it straight inside the square brackets, and do this again. This is kind of redundant because we've told it to get the value for key, place it inside teacher, and then we're just going back to the dictionary to get the value twice. So make sure if you have an output variable that you actually use it inside here. You can see that you're not using it when it goes a slightly dark color like this. So just like in the last examples when we were replacing values inside our list, we can also do that in dictionaries. We can say teachers, square bracket math, and then we can make that equal to something. So if the math teacher were to change, and now the teacher is called Joe, then we can run this line and print out to the screen. Let's just take that for each loop and tailor it to the new dictionary and see what happens when we run it. So let's just change this into a var to make it simple, and then we can have teachers inside here. There we go. So now let's just run this. And you can see that now it says ABBA as the first value. That ABBA is coming from the console right line here that says teacher. This is one line before we change it, and we change the value of the math teacher to Joe on the next line, and there we go. It's committed the change. And just like in the last video as well, when we try to delete something from the list, let's see what we can do to delete it from here. So we can have teachers.remove, and you can see that it says key in there. And again, if we add the key in like this, then it's going to work just fine. There you go, we just have science, we don't have math anymore. But if I drop the lowercase, then it's going to cause us back with an error. But in this case, instead of it throwing an exception, like it did when we were trying to do it up here, and up here as well, the problem with using the remove is it just simply won't remove it. But what it will do is it'll give you back a Boolean. And if you remember from the last video, we actually had a look at a section where in the list, it gave you back a Boolean whether the remove function worked or not. Alternatively, what you could do instead of using the remove function is to check if the item exists in the first place. We can say contains key, and we can place math inside here, and if it does contain it, then we can run the same line of code, and we can say remove, and then use math, just to make sure that this has been actually removed, and then in the else, we can say math not found. Retrieving values back should be retrieved using try_get, just so you don't cause an exception if this is not found. We can simply do an update by placing the value of the key inside the square brackets and then simply just assigning it to something else. This assignment will change the value of the key which is inside the teacher's dictionary. And if you wanted to remove something, it's best to use the contains key just to check if it contains it first, and then you can do the remove, and then if it doesn't contain it, you can tell the user that math has not been found, and then finally we can just print it out like this. So in this exercise, I want you to create two lists with the integer data type, one for even and one for odd. And then we're going to loop through from 0 all the way till 20, and if the number is even, add it to the even, and if the number is odd, add it to the odd list. And at the end, print out all the values for even and for odd. I know you can just print these out inside the for loop, we don't have to have dedicated lists, but this is just for list practice, and I want to talk about different ways that we can do the solution. So let's start. We can have a list of int, and we can say odd, new list, int, and we don't know the size, so we're just going to leave the gaps empty. And if we duplicate this down, we can simply just change this to even. Now the reason why we're doing lists, we're going from 0 to 20. Of course, this 20 value could be anything, it could be 1,000,000, it could be 100, but we don't know. And the point is, lists have counts, whereas arrays have lengths. If we set the array length to something like 1,000, we know we'll probably be able to contain all the numbers inside there, but that's going to be a lot of positions that we don't exactly need. Because arrays are not really dynamic, because they're static, then it's best to use lists in this case, because we don't know how many numbers are going to be odd or are going to be even between this range. If we knew the exact number of positions that we needed in a given solution, then an array would be better since you don't want it to be dynamic if it doesn't need to be. So let's start. We can have a for loop that goes from 0 to 20. And if we want to include the 20 as well, we can just place an equals. The best way to determine if a number is odd or even is to use the modulus operator. So we can say I %2 = 0. And what this will do is it'll tell us if I is divisible by 2 if the value is equal to 0. If you have 2 modulus 2, then the remainder is going to be 0. If you have 3 modulus 2, it's going to be 1 times by 2, which gets you to 2, and then to go from 2 to 3, you actually have 1. So if you insert an odd number and do a modulus 2, you're going to get a 1 returned. If you do an odd number and you do modulus 2, then you're going to get 1 returned. If you do an even number modulus 2, then you're going to get 0 returned. So what we can do in here is we can say even.add, and then we can simply add I. And then in the else, we can also simply just do odd.add, and then have I. Because the values of the remainder can only be 0 or 1, we don't need to have an else if in here. Doing this is a little bit redundant. Although it's still technically correct, the values can only ever be 0 or 1. So if we run this calculation and the value is 0, the only other value can possibly be is 1, so therefore we don't need this additional condition. And we can simply get rid of it. If I modulus 2 is equal to 0, then we add the number to even, and else we add it to odd. Normally when you have situations like this, we can use the conditional operator where we have the question mark followed by the colon. But in this case, we're actually doing two different assignments. We're either assigning into the even or assigning into the odd, so there's no room for the conditional operator. So at this point, we should have all the even and odd values from 0 all the way to 20 inside our two lists. So then we can now just print both the lists out. So we can say printing even numbers, and then we can have a for each loop that goes var item inside our even, and then we can do a console write, add some in-string interpolation, and then we can say item followed by a space. Then we can print environment.newline just to give it some space, and we can say printing odd numbers. Here we go, and then we can just take this exact for loop and copy it down, and instead of saying in even, we want to do in odd, and this is exactly the same since the variable name is exactly the same. Let's try run the code. There we go, it's got 0 all the way till 20, and you can see it goes up in 2s, hence our even numbers, and we also get these going up in 2s except it starts from 1, and this covers all of the odd numbers. And if we change this number up to something like 50, then the list will just grow and our code should still work okay. You can see that all of these numbers are still consistently even. So now that our task is actually complete, let's just have a little recap. So the reason why we're using lists and we're not using arrays is for this exact nature. If we have 0 to 10, then we can almost work out how many even numbers and how many odd numbers we can have. We can manually count, we have 0, and then 2, 4, 6, 8, and 10. And then for odd, we have 1, 3, 5, 7, and 9. So we know how many numbers exist within here. But what if we just change that number to 50? Then now we have a lot more odd and a lot more even. It's impractical to type these numbers in and then to simply count them in your head and then make an array length based on that position. That's a bad solution because not all cases you're going to have the flexibility of simply typing in the numbers like this and counting them yourself. These numbers could be something that are typed in by a user or something loaded for something external like a text file. You need to understand that these values can be generated from anywhere, and if you just type them in, then it provides an unrealistic expectation of how to write some programs. So what you have to bear in mind in situations like this is you simply don't know how many even and how many odd numbers will be appearing during this range. So you want to use a list so it's as dynamic as possible. We have two lists in this case, one to store all the odd numbers and one to store all the even numbers. We don't initialize them with any sort of capacity, we just keep it empty for the exact reason we don't use an array. We loop through from 0 to anything. We don't even have to loop from 0, we can also just start this at 100 and go all the way till 1000. It really doesn't matter what our number range is, the only thing that matters is that we have in a list that is going to be dynamic, and then we can calculate whether that number is odd or even and add it to the right list. How this works is we use I, which is the number we're currently up to, and we calculate the modulus of it to check the remainder. If the remainder is 0, then it must be even, as it's divisible by 2, and if it's anything else than 0, which it can only ever be 1 in this case when using modulus 2, then we add it to the odd list. After this for loop is run, now our odd and even lists have all the values that they should have, and we simply just write these two blocks are exactly the same, just print the even numbers and print them out, print the odd numbers and simply print them out to the screen, and that's it. And if you run the code, it might get a little bit crazy in here, but as you can see, these will actually work. If you pick any random numbers, you can see that they're all divisible by 2. And the same thing goes for odd, you can see that they're not divisible by 2 because they're all odd. So in this exercise, we're going to cover a little task. I like to call this task an array of multiples. So we want to define and initialize two integers, a num and a length. So in the case of this example, we have a number 7 and a length of 5. So what this will do is it will essentially give you the 7 times table, but only the first 5 numbers, 7, 14, 21, 28, and 35. We take the first number, which is num, which will give us the multiples, and we take the second number, which is the length, and that gives us the size of the array. So we create the integer array with the size of length, we loop through the array and insert the loop counter times by num because this is 1 times 7, 2 times 7, and so on and so forth, until we reach the length and we place it into the array. And then finally we print the array just to give us these values out to the console. Alright, so let's get started. We can have it int num and make it equal to 7. We have it int length and make that one equal to 5. Now that we defined initializer to integers, let's create the int array with the size length. Int array result equals new int, and we want size length. After that, we want to create our for loop. Now this is the tricky part. If we try go from 0 all the way to result.length, then let's see what happens. So we want to start result I. We want to make that equal to number, which is our array of multiples, times by the value that we're currently up to. Now let's print our array using for each loop to see the value. So we can say var item inside our result, and then we can have a console write that just prints one of them at a time. So we can say item followed by a space. Now let's see what happens when we run it. So we get 0, 14, 21, and 28. And as you can see, these are the first 4 numbers. So we're close, but we're nearly there. Because our array starts at 0 and it goes to the length, which in this case is going to be 0 to less than 5, which will cover the positions of 0 to 4. With these positions, it's going to do 0 times 7, 1 times 7, and then get to 4 times 7, and not actually get to the 5th because we're starting from 0. So alternatively, what we can do, or what you think you can do, is change this to a 1 and change this to equal to. So now what it's doing is it's going from 1 all the way to 5, which is still covering the same amount of positions. It's just one index forward. So now if we try to run the code, then we're going to get a runtime exception. And the reason for that is it's trying to access position number 5. If we hover over I, we have 5. And if we hover over the result, we actually have some of the right values. Except it's trying to get to the 5th position and it's not working. The reason why the 0th index is actually 0 is simply because that's the same value as the default value. Because our for loop started at int I, it's actually only starting from here and going down. So this calculation is actually correct, but it needs to be back 1. We need to start the multiplication on I equals 0, but our for loop needs to start on I equals 1 so we can get all the way through. So we have 2 ways of doing this. We could say I minus 1, so even though it goes from 1 to 5, it's still assigning it into the array using 0 to 4. So if we run that, we can see that that'll give us the desired result. Alternatively, what we can actually do, instead of doing I minus 1 inside here, we can define a variable called counter and make it equal to 0. We can change this to counter, and we don't need to change multiplication because that's already going from 1 to the length, which is 1 to 5 in this case. After the for loop is run, we need to remember to increment counter. So there we go, we have the desired effect. Another hack if you're interested, if you have 2 variables that you want to increment inside the for loop, you can see that we already have I++ in here, which will increment it by 1. And we want to increment counter by 1 as well every single time it loops around. What you can actually do is remove this, and you know how these are broken up by semicolons, that indicates that the section has ended. The first section is for declaration, the second is for the range, and the third is so you can increment the variable or decrement it. When you're trying to increment 2 variables inside a for loop, instead of placing a semicolon here and type in the next one, you can actually place a comma and do counter ++. What that will tell the for loop is every single time you go through, you want to do a series of these actions. And because we have I++ and counter ++, then that's going to work exactly the same way. It just prevents us having counter ++ down here, and we can move it inside the for loop just so it does it for us, and it looks a lot cleaner because you can clearly see that every single time we loop around this for loop, we're going to increment these 2 variables. There we go. So let's try put some different values in here, maybe make this 10, and we can have 10 on both, so it should give us the first 10 numbers. There we go, from 10 all the way till 100. Let's have a little recap. So we're essentially just making an array that will give us back all the multiples, so it's like a mini times table. But the fact that we're doing it dynamically using our array is quite important. What you can do if you wanted to is to extend this program. You can ask the user to type these into the console and then convert them and use them. Right now we're just statically typing them in, and that's not really an issue since the main focus was doing this for loop. If you wanted to, you could ask the user and you can type these values in so you don't have to change them every single time you compile. So now we've got the number and the length, let's make our int array called result and initialize it to the length. We set up this counter so we simply didn't have to do I minus 1 here, so it looks a little bit more intuitive. We start the for loop from 1 and go to the length, so we can access 1 to 5. And the reason why we want to do 1 to 5, so when we do our multiplication, it doesn't start at 0. These two are going through the exact same amount of indexes. 1 to 5 is 5 numbers, and 0 to 4 is also 5 numbers. So when we do our multiplication, we want to start from 1, since the timetable normally starts at 1 and we go to the length. The reason why we're using the counter is so we don't have to do I minus 1 in here, and it breaks up the logic a little bit and it looks nicer without counter. We start our counter at 0, and instead of incrementing it down here, we use this fancy comma and we can say we want to increment I and counter every time the for loop goes around. So we don't need to include the counter increment inside the for loop. And this one line is pretty simple. We say result, the index of counter, which will start at 0, which is the start of the array since it's 0 base, and we say that's equal to the number, and the number is going to be a fixed number since this is the multiple. And we say number times by I, and in this case it goes from 1 all the way till the length, so we get essentially the times table. And at the end we just use a simple for each loop that will go through all the items inside the result array and just print them out to the screen with a comma after each other using console.write just so they're all on one line. This is the start of the function section. Functions can also be called method, they are used interchangeably. In the introduction we discussed dry, which means don't repeat yourself, and the whole point of dry is so you don't have multiple sections of code that do basically the same thing, you want to wrap it around in a function. Functions are used to improve the readability of your code and the reusability of the code as well. Having multiple section code that are basically exactly the same can be more prone to errors. If you wrap them around and place it in one singular function, you can make sure that they're error prone, and then wherever you use it, it will be error prone as well. If you have to copy and paste and tweak some code, then you're actually exaggerating the amount of errors that could occur. And plus it makes your code look a lot cleaner and the structure is a lot better since you can name the functions. So let's take a little example. We have a static void main straight into here. This is a function or a method, and these are the parameters for the function. The .NET framework expects every C# program to have a main function with a capital M, and it needs to be a static and a void. The parameters don't exactly matter, we can also remove them and it won't be a problem. The only thing that matters is this needs to be called main. If we drop the lowercase on it and try and run the code, then we're going to get a build error. Program does not contain a static main method suitable for an entry point. So if we change this back to M and run it again, and then it works fine. So that's one thing to note about the .NET framework, is you need to include the main function, otherwise the program won't run and it won't even compile. So let's take a look at how we can use this. We can have something like a console write line and we can say welcome to my program. This is a line that we're probably only going to use once, but let's say this was welcome in someone's name. Welcome Abba. Let's say you had this in your software in many different places. You don't want to be recalling this or retyping out this message in case you type it wrong the 5th time and you get an error. Of course, this won't be a syntax or a runtime error, it'll just simply be a logic error because it's a typo. So in order to make sure this typo never occurs, we can actually make another function. So outside of these curly braces and just still within the class, we want to create a new function. So we want to follow this exact same approach. We can say static, then void, and we can call it welcome message. And we don't need to give it any parameters because we're not really going to give it any values just for now. Now that we've made that, we have no syntax errors and we can run it like this. Except of course there's no body, so let's place our console write line within here. Now if you run the code, nothing is going to happen. And the reason for that is, the code will still execute in the main. We haven't called this function inside the main. We've defined it and called it welcome message, and we've gave it the contents, but we haven't actually made use of it. And you can see that when it's highlighted in a darker color. That means it's not being used. As it says here, private member welcome message is unused. So now we can simply type in here, welcome message, followed by an open bracket and then a close bracket to denote the parameters that we're going to give it. And of course, in this case, there is no parameters. And then we close the bracket and add a semicolon. Now, if you run the code, you can see it says welcome Abba. So just to go over some of these words that we're using. Static means that we can access it anywhere and everywhere. What I mean by that is, we don't have the keyword new just before this. We don't need to make a new instance of the program class in order to access this. So what that means is, when we make future programs, we're going to have some functions inside our class. Inside the class, you can actually denote if a function is going to be static or it's not going to be static. You don't have to specify is it static, but this won't let you call it from here because it's unaware where this function is coming from. An object reference is required for the non-static field, method, or property. Because this is static, you need to reference something else from a static nature. All static means is you don't have to create a new instance of this thing in order to use it. We'll see different examples in the future where you have to create an instance in order to use something. So let me just show you quickly. If we have a test and I say static void something, and we can just print out nothing to the screen, and let's try and use this. So because this class is outside of the program, we have to use the notation test dot, and then it should be available within here. And the reason why it's not is because we need to insert this public word just before it. And public means everything has access to it, and static means you don't need to create an instance. Now if I type in the dot again, you can see we can now see something. And the reason why we can see something is because this is a static. Now if I remove the static word, then you see that we'll get a compiler error because it doesn't know where this is. Now if you don't use static, you need to do this. You need to say test equals new test, so we make an instance of the class, and then inside test, then we get the something. So that's the difference between static and not static. Essentially, it's accessible from everywhere, but if you don't want to be accessible from everywhere, then you can just simply remove the static word, and the user will have to create a new instance before they can use it. So this is what it's like without static, and this is what it's like with static. Don't worry if you don't understand this too much, this was just a quick overview, but I have a dedicated video later on in the course, so don't worry too much about it. So now that we've made a function and we've called it successfully in the main, and it's printed out to the console. So when we're declaring functions, we want to specify what return type we're going to have. We have a static void main in here. If you hover over main, it says void, which means at the end of this function, it doesn't return anything, hence it's void. If you have a look at something like an int.TryParse, and we open the brackets, you can see that it takes in a string and it takes in an integer out parameter. It also returns us back with the Boolean. So we can have something like 123 out int result, and then it doesn't actually complain about anything. But what we can do is also just store this in to a bool success and then print it out to the screen. There we go. So it says it was successfully true. If we remove this, or whether we keep it in or not, the TryParse function doesn't actually complain, but the main point here is it defines back a bool. That means at the end of this function, it will always return you back with a bool, and it's up to you if you want to make use of it. And you can alternatively, you can place this straight inside the console write line and get the value printed straight to the screen, or you could wrap this around inside an if statement like we've done in the past, etc., and make use of it that way, and have the result being printed out inside here. The point is, you have functions that return something and functions that don't. If you remember that we had the array.copy, for example, you'll see that they have void here, because they just apply a function to something, but they don't actually give you something back. This is the difference of having something like this. A string test that says hello, and then you can do test.replace, and then you can return you back with a string, and it says here it returns a new string. Whereas when we had a string builder, for example, and we did string builder.replace, you can see that although it does say it replaces a new string builder, you can type anything inside here and it will still affect the current string builder. It won't have to do sb equals sb replace as you would need to do here, because this returns you back with a new string, and if you wanted to replace test, you would literally have to say test equals test.replace. With something like a string builder or the array functions, you don't actually have to do any of that. So you can say array.empty and it will just return the empty array. And the ones that we used before are things like equals, and that will give you back a bool because that's determinate whether it's equal or not. But if you're doing functions like sort, for example, and doing things like reverse, it just simply applies the data, but it doesn't return you back with anything. So you can literally just call it inside here, put your array in the brackets, and it'll use it happily. Now, depending on your user case, you need to define whether or not you need to use a return type or not. For now, let's just cover void, which means it won't do anything. So let's just define a function. Static void, create and print an array. Open the brackets, close the brackets, and we can have it int numbers, make it equal to a new int with a length 3, and then just have 0, 1, and 2 inside here as the initializer. Let's just do a for each var item inside numbers. and then just do a console write string interpolation and just have item followed by a space. And now that it's dark grey because we haven't called the function, so let's make use of it at the top of our code and let's run it. Now you can see we get 0, 1, 2 printed to the screen, and if we make this into a 5 and simply just add more values in here, and then we run the code, you'll see that now it will update. But because this doesn't return us back with anything, and we don't actually use the integer array outside of these curly braces, it's not actually available up here. Numbers won't be accessible inside here because it's simply not within the scope. Numbers is only available within this curly brace and this curly brace, which means when this function finishes, numbers has now been deleted from memory, so you can't access it after this line. Void doesn't do anything. It simply just does the contents of the function, and as soon as it reaches the bottom, that's all that happens. You can have another function defined that can return a value, like I said with int.TryParse for example. At the end of the function, you'll see a word that says something like this. It will have return and then return back something, followed by a semicolon, and that will dictate that as soon as that function is done, it's going to give you something back. Now we're going to cover that in the next video, but for now we're only going to cover void functions. So we can have something more obvious like a static void, welcome message, and simply just do a console write line, welcome to my program. And we don't need to return anything here because all this function will do is simply print out a welcome to the screen, and we can use that just before the print array. So we can say welcome message, open bracket, close bracket, and then a semicolon, and hit F5 to run, and there we go. As you can see, our main is really tidy now. It gives us function names that tells us exactly what's going on. We're creating and printing an array, and then welcoming the user to the console, and then having a console read line at the end. There isn't an awful lot to void functions. All you need to know is that when you create a function, you need to give it a return type. It returns back a certain data type, or it simply just doesn't. And depending on what you want to do and what you want to achieve with that function, really depends on if you want to return a data type or not. In the case of these, since they're just doing something and then moving on, you don't actually need to return anything by it. With int.TryParse, you want to make the function is executed successfully, so when you use int.TryParse, you can see that it returns back a bool, and the bool determines whether the conversion has been successful, and based on that return value you can determine the next steps of your program. If all your function needs to do is provide some sort of functionality and then quit, then that's fine and a void is fine. But if you need to provide some functionality and then also return a value, then you'll need to specify the data type in here, which we'll cover in the next video. So far we've covered void functions, but we haven't covered return types. Void functions are where the function just does something but doesn't actually return anything, hence the name void. Let's start with an example. If you have a static void, print introduction, you might want to just return back your name. After you've printed this line, it's going to print it to the console, and that's all it's going to do. There we go. Let's say there's a situation where you actually want to use this inside your code. You can actually set the console's title by typing in console.title and type in your name inside the quotation marks, or you can type in anything inside here. If you run that, you'll see ABBA is in the title of the console right now, and that looks pretty cool. But you got to realize is now we have two references to the same value. Now at this point we can actually do something better. We can type in static string name equals ABBA, and then instead of using ABBA in here, we can say name, and instead of using ABBA in here, we can also say name. And they're both using this variable, and if you run the code now, you see that the same output will happen. You have ABBA twice, both in the title and both in the console output. Now the problem with this approach is you're actually making use of a global variable, which we do not like in code. In situations like this, you shouldn't need to make a global variable because there are ways around it. So instead of having this, which has a print introduction, and we've got the name used in there, but the name is coming from here, maybe we can use this somewhere else. So let's say we make another function called static, and instead of void, we want to actually return back a string. So we can say string, and then we can say my name, or something like return name, or anything you want. Just make sure you give it a meaningful name so it dictates what the function is trying to do. So if this is to return the name, and the reason why there's a red underline is it says that not all called paths return a value, since we need to use our keyword return. Now that we add some empty quotes in the return, it's going to execute fine and the compiler error is gone. So obviously we don't want to just return nothing, we actually want to take this ABBA and return it in here. So let's get rid of our global variable and let's see what we're going to break. So we're going to break these two references to the name variable. And simply inside here, we can actually just call return name. And then here as well, we can call return name. And what this will do is inside here, it will execute this function and then return the value in here. If this is too many steps for you, you can have a string name equals return name, and then simply use the name inside the brackets. These two lines are doing exactly the same thing, except this is using a variable because we're storing it first and then we're using it, whereas if you place it straight inside the brackets, that's just going to store it and use it immediately, and there's no additional variable. But don't worry too much if you're going to do this notation, because an extra variable in this case doesn't really matter, because as soon as this function is executed, the variable used to run this function gets deleted since it's inside the scope of these two curly braces. So now if you run the code, you'll see that again we have Abba and Abba, but now what we've done is actually control everything throughout here. So if your name were to change, or maybe this changes in a different circumstance based on the user that's logged in, then you can simply have the same thing now printed in two different locations, in the title and in the console output, and it's actually coming from one function. So we can have a return name, and we can make a static int now, and we can say return age. And then we can have simply return 23, and that's our name and our age being returned. That changes back to Abba, and then instead of the print introduction, maybe we actually want to print a little bit more than the name. And maybe in the title, what we can do is have string interpolation, wrap the return name, and maybe put a hyphen in there, and then we can say return age. So if we run the code now, you can see we have Abba-23. So maybe that's the title of our console, but then in the introduction, we can use a bit more than that. So we can have int age equals return age, and then in the console output, we can have something like this. Hello, my name is name, and my age is age. And then after we've compiled that together, we can place the output inside here. There we go. So we're using the name and the age inside the console title, and then we have this function that runs to get us back the name and the age, and then we're using it using string interpolation. Of course, these 4 lines can be all squished into one. You can simply take this $sign. Let me duplicate this line. You can take this and paste it straight into here, and where you have name, we can have our return name, and where you have age, you can have return age. And that will actually rule out all of these lines, and you can wrap it all into one. There you go. And if age were to change, like I said before, you can simply type this number in, change it, and you can see in both cases in the title and in the console output it has officially changed. Functions can be very helpful to reduce repetition in code. Let's show you an example. If you had 3 sections where you said enter a number, and you had int num1 equals convert to int32, and then we had a console.readline, and then you had this section and you wanted to do num2, and you had this section again and you actually wanted to do num3. Now at this point, even though these 3 are actually identical, you want to be using an array in this case. So you could have int numbers equals new int square bracket 3, and then in here we could say numbers 0, numbers 1, numbers 2, and then we don't need the ints because it's already been defined, and then we have them like this. But because again all of these 3 sections are exactly identical, we can actually run a for loop that goes from numbers.length, and then we can place one of these straight inside here and then change this to I. And now we've achieved exactly the same thing, but we're not actually done yet. So if you run the code and we do 1, 2, 3, now we've stored all 3 numbers. So we have enter a number, and then we have the console read line. And maybe we can actually make these 2 lines a little bit shorter. So let's make a function, static, and because we essentially want to return an integer, we can say static int read number from console. And then if we take these 2 lines, place them inside here, and because we need to return back an integer, this is the value that we're going to be returning. So instead of assigning this position to something, we'll actually just immediately return at this point. So instead of doing this line now, and instead of doing all of this, we can simply make this into one line of code. Read number from console. So every time this will execute, it will jump into here, print out the value, enter a number, the user will type it in, it will read it in, convert it to an integer 32, and this will return back the integer that the user's typed in, and then that will return it back to the console and essentially replace this. So if the user's typed in 5, then it essentially replaces this with 5, store it, loop around, and if they placed in 10 the next time, and then you replace this with 10 essentially, and then that gets stored inside, and so on and so forth, until all the positions have been complete. Let's test that. 1, 2, 3, and it still works okay. Of course, I'm not actually printing the values out to the screen, so if you wanted to see that quickly, for each. We can have var item inside our numbers, and then do a console write with some string interpolation, item followed by a space. And let's run that 1, 2, and 3. And there we go, we get 1, 2, and 3. Of course, you can make these functions and they can return any bits of data that you want. You can even have something like an int array, and we can say create random array. And then we can create an array called numbers, make that equal to new int square bracket 3, and we can actually give it the values of 0, 1, and 2. And then just at the end here, we can actually just return numbers. And then just in here, we can have an int array, and we can call that new numbers since we have numbers above, just above here. And then we can make that equal to create random array. And because this returns us back with an integer array, then there's no compiler errors inside here, and we can have a for each, follows the exact same approach as the one above, new numbers, console write line, into a console write, and then have item followed by a space. Now if we print these both out, you can see that the 0, 1, and 2 actually comes from the new one. It's just we have two console writes right next to each other, so there's no new line separating them. So if we just add a console write line here, 1, 2, and 3, and there you go. 1, 2, and 3 comes from the 3 inputs we just typed in, and 0, 1, and 2 actually come from the function that we've just created. Of course, if you don't like this notation, then what you can do is you make it a lot easier. You don't even need to make a new variable, you can actually just return the integer just like this. So if we place this straight inside here, actually just make it on one line just so it looks a bit neater, then there you go. We have our entire function reduced to one line. The goal of functions is to make them do as little as possible. If your function has two different things it's doing, or more, then you should break that out into another function. For example, if you had a function that did two distinct operations, one was a conversion and one was a calculation, then you want to split that out into two. The first function should be the conversion, and the second function should be the calculation. And the reason why they're separate is because if you want to reuse them as a pair, then you won't be able to reuse each of the pairs. If you wanted to have a calculation on its own, then you can't do that if both functions do the same thing. For example, you could have a static, and it just could be something, let's just call it void, and it could just be test, for example. And if you had the conversion here, and then if you had the calculation in here, then you need to split this up into two different functions. You want to have static void conversion, and static void calculation. If you wanted to use conversion or calculation separately, you can't because now it's in this pair together. So if you wanted to use them separately, you simply can't. It's best to keep functions on their own anyway, just so they have a single purpose so you can give them a name. Because as you can see here, we can't give this an appropriate name because it's doing more than one task. This is doing the conversion, this is doing the calculation, and this is doing multiple things. This could be doing something. If you have to think too hard about the function title, then you might be doing too much within each of the functions. These are very easy to be able to decide what they do, because this one converts and this one's going to calculate. Reading number from console. If this was reading the number from the console and doing something else, then it's going to be a bit of a problem because now you've got a bigger name. You don't want to be doing reading number from console and something else, because then your function name gets also too big and you've got multiple dependencies. So the best thing to do is to call them accordingly and keep them as short as possible. So let's say we wanted to make a function that added two values up. We can have a static int, call it add, and then we can return 5 plus 5. Now this function is a little bit redundant, although it will actually work. So if we go back to our main and we do a console write line and actually print the value of add, and we go through our function, then we see we get the value of 10, which is indeed 5 plus 5. But since this 5 plus 5 won't change, it's always going to be 5 plus 5, this is where parameters will come in, which we'll cover in the next videos. Parameters are a way of being able to give the function value, so these two can be actually changed. There's no point in having an add function if the only ability you can do is add 5 plus 5, because you may as well just return 10 at this point. So I covered a lot in this video, and there's lots of different functions that do different things. Of course, there is quite a lot of lines, we're up to 87. This is probably the biggest project that we've wrote so far, and even though this is not really a project, it's just a bunch of functions that do little things that are made for demonstrations. So let's have a recap. So first here, we're setting the title as a result of return name and return age. We can actually take this and develop this further if you want to. We could actually say return name age pair. And if you wanted to collapse that inside one function, then that could be really easy. You could say static string return name age pair. And then you can have return, and literally the exact same line above, you can have return name, followed by a hyphen, and then you can have a return age, and then end the line like that. So that just concatenates the two values that are returned from these two functions, but the point is you keep them all separate. If you were to type in very statically inside here, ABBA25, then obviously like I've talked about above, then you're going to have duplication of data, and of course we're going to use this name inside something like here. And as you can see, this name age pair is actually not applicable when it comes back to this format, so it's always best to keep these two separately. So if you bring it back and we can actually keep it like this, now instead of having this code, we can actually say return name age pair. That will give us the same value at the top of the code. It will have ABBA-25. So that's that bit. In our print introduction, if we hold Control and we actually press on this function, it will actually jump us right down. And then if we press the back arrow top left, we can go back to it. There we go. And then click forward. So in this function, we can break down all of the return values into string variables. We have a string name equals return name, and int age equals return age. And then we have a string input that concatenates them both together. Hello, my name is name, and my age is age. And then we print out to the screen. Or if you wanted to, we could wrap all four of these lines straight up into one. We don't need to assign these into variables, although it does help the readability if you keep them separate, but I prefer to keep it like this since I'm used to this notation. We can place return name straight into there, which will get rid of our name variable, and the same thing with age, which will get rid of these two variables, and of course we're actually storing the string value before we're printing it, so we could just take all of this and place it straight instead of here. Scrolling back to the top, this little section was demonstrating how we can use integer arrays to read in all the values from the console, but wrap it around in a function. So before in here, you would have something like a console write line, you'd print out the value to the screen that would say something like 8 to a number, and then you have on the next line a convert to int32, and then after you converted it into 32, you'll actually store it straight into numbers. But because this is going to be the same thing for inserting all the numbers, you can actually wrap this around in a function. So if we hold Control again and go to this, you'll see that them two lines are very simply placed in here. Console write line, enter a new number, and then a convert in 32 based on the console read line, and then we're simply just returning that back, ready to be stored in the index of the numbers array, and then straight after that we're just printing out all the values to make sure it's worked, and that all succeeded fine. Here I was just demonstrating that you can have different return values and it can literally be anything. So as you can see here, if you hover over create random array, it's inside the program class, it's called create random array, and it returns back an integer array, so that's what we're signed it into. And if we hold Control and click on this again, you can see that all this simply does is returns us back a 3-length array with 0, 1, and 2 as the array positions. And then if we scroll back up, when we execute this for each loop, then we're simply going to get 0, 1, and 2, just like that, since it's a console write and it'll be on the same line with a space after each other. This demonstration was slightly theoretical. I was saying in one given situation, a function should only do one task. If your function converts and does a calculation at the same time, then these are actually two different things. You should split them, so you use the conversion in this step and you use the calculation in this step. If you wanted to convert something or calculate something in the future, then you can only do it now because we've separated them. Whereas before, if you have them both inside here, then you simply can't do one operation because you've wrapped it around in one section. The same is true when I was discussing this earlier on. If we kept this name pair as the only way to access the age in the name, then it's going to mess up when we use it in here, and then we're going to have a duplication of data. But because we separated the name and we separated the age, we can use it in this function and we can use it in this function, and it doesn't interrupt anything. This simply returns the name, this simply returns the age, and these two functions make use of them. If we had something else underneath, there was another function that depended on the name and the age, then again we can simply use them. If it was restricted to this function, then it's going to be a problem using it in this function or any future ones. And finally, just to finish off, add function, and all it simply does is return 5 plus 5. And I was saying as of right now, even though it returns back a value, it's kind of pointless, because you may as well just return back 10 since it's doing the same thing. The reason why I included this function is that we can set it up and start planting the seeds to understand why functions exist and how to make use of parameters. What a parameter is it lets you put things within these brackets so you can give this function some data. So if you have an int.TryParse, for example, these things that we place inside the brackets are actually the parameters. So we have a string s and an out int something. And that's how the parameters work on our TryParse function. And just to show you, this is how it's actually wrote. It's a bool, and then it's called TryParse, and it takes in a string s and an out int result. Then we can make this static. And I know it's because it gives us an error because we don't have the control path. If we just use result and assign it to 0 and then return back true, you can see that the compiler error is now gone. And as you can see here, it says bool, TryParse, string s, out in result. And if we actually try and use the TryParse in here and press the brackets, you can see that these parameters are exactly identical to parameters that were inside of the TryParse coming from the integer library. So in the future, we're going to study how we can use parameters to pass data inside our function. But just for now, know that this function is essentially pointless because it's only going to return back 10. And this function will gain the functionality it needs when we start adding parameters. This should essentially be add 5 plus 5, except this is kind of a pointless function because we already know the value is going to be 10. But again, this is just helping you understand why parameters are very essential to functions. We've covered how to create a void function and a function that returns a data type, but now we want to create a function that gives it some sort of data. You may not realize it, but all these functions that you normally use, like console writeLine, you're actually inserting data consistently into all of these functions. If you hover over console writeLine, you see it says void console writeLine, and right now there's an open bracket and there's a close bracket. If we delete this bracket and reopen it, you see there's 19 different ways that you can call this function. And as soon as you start to type a string, you can see we have a string format and an object if you need to. And if you type in another string, you can see it says string value. This string value is actually a parameter. If we hold Control and press on writeLine, you can see all of the different functions right here. This is the most basic version that just inserts a writeLine character to the console, and then these are all the different parameters that you can give the value. Of course, you can't double click and view the source code because this is hidden inside Microsoft's libraries. The values that are placed inside these parentheses are actually called the parameters. This is known as functional overloading, which we'll cover later on in the course. Basically, that means you can have the same name function but give it different parameters, and you'll see why this is helpful later on down the line. So let's close this tab in the top right hand corner and let's bring back our code. So now that we've passed hello into this function, that's us actually giving this a string value parameter, and that hello is going to get passed straight into the console writeLine, so then when we run the code, it's going to print it to the console. So let's create our own function with our own parameters. So if you take the function I had last time, it was static int add open bracket close bracket, and it simply returned 5 plus 5, which we all know is going to be 10. So if we place add inside these brackets and we run the code, we should get 10 returned back. There we go. So of course this is a little bit pointless since it's always going to be adding 5 plus 5. There is no way we can change this without the use of parameters. So in here we can actually just do what we do when we normally declare a variable. We say the data type int and then the variable name, and then if you want to add multiple parameters you can simply add a comma. So now we can say int a and int b, and you can see now we've got a syntax error because it expects us to have both of these values inside. If you hover over it, there is no argument given that corresponds to the required formal parameter a, and then if we insert a by having 5 for example, and if you hover over it, it complains about not having b, so we can do comma and then do 5 again. So just this on its own is not actually going to do anything. We're actually giving the add function the values of 5 and 5 and placing them inside a and inside b variables. These are now known as local variables, and they only exist in memory between these two curly braces. As soon as this function is done, these are deleted from memory and you can no longer access int a and int b. You can't just do something like a inside here and think that this can be used up here. These are in two completely different scopes. This is one function and this is another function, and they're completely separate from each other. When you type in 5 and 5, it goes in order. So int a is the first one, so 5 gets placed into here, and this 5 gets placed into b. So now that we need to make use of them, we can simply change this to a, and change this one to b. Now if we run the code, we should still get 10, but now our function works a bit better, we can give it a set of data. So if we actually just put zeros instead of here, then we should get 100 returned. Perfect. So now that we've figured out how to do this, let's have a look at different ways that we can make use of this function. So let's say we had a situation where we did console write, enter a number, and we had int num equals convert to int32, and then you're converting the console.readline. And let's wrap this inside a function. So before, what I was doing is simply just returning back an int. It was static int read int, and then we took these two lines and placed it straight inside here and remove the fact that we have an integer and simply just change this to a return. And what this now will say is, let's output enter a number to the console, let the user type it in inside the console read line and then read it in, convert it to an integer and then give it back to whatever calls it. So now we can get rid of this and get rid of this convert and simply just type in read int inside here. And after that line, let's just print it out to make sure it's worked okay. Enter a number, 10. Press enter and we have 10 again. And that's fine, except if we want to use this in another case, for example, if we have num1, maybe we don't actually want to enter a number. Maybe this time it's going to be enter an angle, or something of this sort. So what we can do, if we undo that, we can actually introduce a string message. And what this will do now is actually specify the message that we put in here. Maybe there's a situation where we always want to enter something. So maybe we can just replace this and put a string interpolation and wrap this number around in the curly brace and replace it to message. So then in here, we can say enter a, and then we can pass the string variable, which will get placed in here. So if this is a number, then we can type a number, and maybe this is something like an angle. And then here we can type an angle. So we have 10, enter a number, and then there you go, it says enter an angle. And then we can have 100, and that's working as well. Alternatively, if you want to specify the entire message, then you can remove these and keep it like this. And then in both of these situations, we can say enter a number and copy that down like this and make sure you put the colon at the end followed by the space. There we go. Enter a number, 10, enter an angle, 20. Maybe there's a situation where this text actually changed and you just want it to be angle, and if you run that again, then you'll see that these are completely different now. One says enter a number and one says angle. But this gives us a lot of flexibility in what we pass in. If we keep it as enter a and then let the user decide on what this section is, then you rule out any opportunity to be able to do that option. If you wanted to prevent the colon and the space always being at the end, you can actually just add that in manually. If we bring back the string interpolation, we can say colon followed by a space, so you don't have to remember to always put that in. There we go, so that's doing the exact same thing, and we're actually just reducing the amount of repetition. Because we have to remember to put a colon followed by a space inside here, we might just forget it, and then when you leave it like this, then the code's going to look ugly because it looks like this, and it's all stuck together. So let's make use of these two functions, and let's see if we can write a really basic calculator. We can say int first num equals read int, and then we can say enter first number, and then duplicate that down, change first to second, and then change this also to second. And then inside a console write line, we can actually have the add function, and we can type in first number, and then we can type in second number. And if you don't want to call a function inside here, you could actually just make another int, and we can say int result equals add, and just bring this line over to here, and then in the console write line, you can just print the result. There we go. So we read in both the values, execute the add function, and then return it back to the user using a console write line. So these are the other ones, and then here they are. So if we do 50, and we do 50 again, and you see that I've messed up because we have double colons now. So although our calculator did indeed work, let's just go and correct that so we can take these off now because we added it inside here. 50 and 25, we should get 75. Perfect, so now we've made a little basic calculator by simply making use of these functions. And if we just expand this just to show you what it would have looked like. So we go in from this and we place our message inside to here. And then we have our convert line, just like this. And then if we duplicate that down, we can change this to second num, and that to second number. And then as for the result, we can say first num plus second num. There we go. You can see the code is drastically longer, and it's a bit meaningless to have duplicate code. This is literally the exact same line in both of these sections, except for the fact that this says first, and this says second, and we're storing in first, and we're storing in second. So let's undo that and get back to our more efficient code. There we go. You can see that these three lines are considerably shorter and easier to read. This is telling us we want to read an integer, here is the value, and we want to return it inside our first num, and so on and so forth. Let's have a look at another example where we can make use of this. So we can have a string called name, and we can read this in from the console, console.readline. But we need to output a message, so we can have another console write, and we can say enter your name. And then we can have this twice, and we can do enter your age, and then have an int age. But of course, we don't want to be using this approach and putting a console write line inside here with a convert to int32, because although this is actually technically correct, Now we're undoing the point of our function. So let's change this into our readInt. And then as for our message, well, we have the message right here. And again, we don't need the space colon, so let's remove that. And then as for the name, we can actually do this differently. So this is actually going to do a string variable. So what we want to do, instead of having readInt, we can have another function called readString, another string message parameter, and then do exactly the same thing. Have a console write, and we can place string interpolation, and place a message inside here, followed by colon space, and then we can just simply return the console.readLine. There we go. And instead of doing all of this, we can actually just put our read string inside here, and then place our enter your name inside here, just without the colon space because we don't need that. So now we've reduced this section to 2 lines as well. So now what we can do is have a string details and make that equal to a function that we're going to use now. We can say user details if we want to give it the name and give it the age. And that'll give us back a string that we can print to the console, so we can say details. So let's go ahead and make use of this function. So we can have a static, and it's going to return us back a string because we're placing it inside the string. And then it's going to be user details, and then our name is a string, our age is an int, and then inside here we just want to concatenate them 2 values together. So we can say hello, my name is name, and my age is age. And because that's returning us back with a string, we can make use of it inside string details, or we can place this straight inside the console write line. Let's leave it as a function call, assign it into string details, and then print out to the screen. Let's just skip over these sections, enter your name, Abba, enter your age 23, and then there you go. Hello, my name is Abba, and my age is 23. So this is how we can make use of parameters inside our functions, so we can actually give it some sort of data that's meaningful. If you didn't use parameters, then what you're going to have to face is, for example, what we showed you with this integer. If you don't use parameters, then you're going to have situations like I showed you before with this integer function. It returns back an integer, but it only gave us the value of 5 plus 5. I mean, technically you don't need to return anything, you can actually just keep this a void and just wrap this around in console write line. The only issue with this approach is you don't have any option other than to print it out to the screen. What if you didn't want to print it out to the screen and you simply just wanted to return the calculation and then store it inside another variable? This doesn't give you the flexibility of that. So we change this into an int, and instead of return it back to the console, we just return back the pure value, and then if the user decides that they want to print this out to the screen, that's fine. Like here, we've made a decision that we want to print it out. But let's just say we had a variable that said int calculation, and then we placed that inside, but we actually never wanted to print it. Maybe we kept it like this, and then used calc for something else down below, or maybe that was something like storing inside a database. Not everything will be printed out to the screen for the user to see. The best thing to do is return the values in their purest form, because you never know what the developer or the user is going to make use of that data later on down the line. Keeping it in its purest form is the best way possible. For example, in this case, we're actually reading back the integer and then print it out to the screen. But in this exact case, which is the best case scenario that I just showed you, we're actually making use of first num and second num, but first num and second num are never actually put it to the screen, it's always just used for the calculation. If we use console write line to print out first num and second num, then we're not going to be able to use it inside our calculation, and therefore our very basic calculator is now being rendered pointless. So read int and add all return back values that we can use in their purest form, and that is the whole goal of parameters. So now that we've covered parameters that are always going to be required, let's have a look at another concept called optional parameters. So we had a static int add, and we had int a and int b for example, and then we simply just returned a plus b like we used in the previous examples. If we have an int result and we want to call that function and we give it the value 5 and 5 and then print out to the screen, everything runs okay because we've added in exactly what we expect. But let's say we don't actually have this additional 5. Of course this doesn't make any sense because we're meant to be adding 2 numbers, but just humor me for a minute. Then what this will do is says there's no argument given that corresponds to the parameter b. Now of course this is a problem because it's a red underline, which means if we try and run the code we're going to get an issue. Let's say you were creating some sort of system that if you entered both values, it uses both values, but if you only entered one, it automatically sets the second value to something else. And we can achieve this behavior using optional parameters. So an optional parameter doesn't exactly mean quite optional, it kind of just means that it's going to be optional, but you can also give it a default value. This will always add 2 numbers, a and b. Even if we make a or b optional, it's going to still need 2 numbers to add in order for the function to run. So in order to make a parameter optional, let's just say we want to make b optional. We can type in an equals straight after it and actually give it a value. So as you can see, our syntax error is now gone, and if we run the code, we should get 55. And the reason why this works is a is now 5. If we hover over here, we can see a is 5, and then the square brackets around the int b actually denotes that it's optional, and it says int b equals 50 because we have that here. So it's actually using this as 50, and if we don't specify the second parameter, then it's practically just doing this, which is completely fine. So the reason why I said it's not quite optional is because you still need to give it a value. Of course, in here you can use the default keyword. In the case of an integer, the default value is actually 0. So if we just run that code now, it's going to say 5 plus 0, which is just 5. So it can be optional, but you still need to give it some sort of value. Of course, if you're doing a calculator and you're adding two values, if you only specify the first one, then adding 0 to it is simply not going to change it. So 0 or default is going to be the best user case when you're dealing with default values with integers. So another way you can actually specify this is by inserting this thing called an attribute. If we remove this equals 0, and just before the int, we can type in open bracket, close bracket, and type in optional with a capital O, and then you're going to get a red underline. If you hover over it, it says we need to include this extra library, which will import it at the top of our code, as you can see here. Now that this is available, it says indicates that a parameter is optional, and what this will do by default is it'll give you the basic value for this number. So what I mean by that is we can type in here, just to show you this, b equals and then b, and this will just give you the default value based on the data type, and as we just said a minute ago, that value is actually going to be 0. There you go, b is 0, so all it's doing is saying 5 plus 0 equals 5. So that's another way of doing it, or you could just leave it as I said before. You can say int b equals default, or int b equals 0, it's completely up to you. I prefer using the default keyword, so you don't have to keep remembering which different data types have the default values. In the integers case it's 0, but I just like leaving the default, and we can get rid of this line now. Let's have a look at different situations where this will be helpful. If you had a function called printName, and we had a string name in here, and then we can simply just say console writeline, my name is, and then name. This is quite easy to use, so we can say printName, and then place ABBA inside the brackets, and then run the code, and we get ABBA printed to the screen, and that's fine. But let's say if we had someone else's name in there, as Joe for example, then we get Joe to the screen, and let's just say as the developer, you only want to default this to ABBA if you don't actually insert anything. So now if you don't insert anything, of course we're going to get a compiler error because we need a parameter. But if we assume what we did here and just follow the same approach, if we use default, then it's going to give us nothing because the default value for a string is just empty quotes, which is just nothing. But instead of default, we can actually specify a value. So we can say, if no one types their name inside the brackets, then use ABBA. There we go. So you can have this optional parameter that defaults to something, and if someone types in Joe or whatever inside the printName function, then the default optional parameter is not going to be used, since this will be overridden if you have a parameter placed inside here. So now the ABBA is going to get overridden by the Joe, because this is actually the parameter that's being used in the function. So you've looked at functions with normal parameters, optional parameters, and now let's take a look at name parameters. So let's say you had a situation where you had string name, ABBA, int age equals 23, and string address equals 1 something road. And then you had a function that would simply print these details out to the console. So static void, print details, string name, int age, string address. So you have 3 console write lines that just print out a name value pair, just like this. And then when you go to call this function, what you're going to have to do is specify the name, then the age, then the address, in that specific order as per the parameters show. If we try and run the code now, we should get the desired output. Perfect. Let's say for example you wanted to rearrange the parameters and put age first. You'll see we have a compiler error now because age and name are in the wrong order. String name should be first and int age should be second. We can still achieve this by using something called name parameters. We don't have to stick to this order if we tell the compiler which parameter we're directly talking about. So we can say age, colon, because our parameter is now called age, as you can see it's been highlighted, and then after the colon it's the variables that we're talking about. So it just happens to be that age is the same value as the age. So maybe we can change this to age input and place input at the end of these. So then we can have age equals the age input, and name parameter equals the name input, and the address parameter equals the address input. Now we can have it like this, and to make it look even better, you can actually add new lines in here just to break it off like this, and this is a similar pattern that you'll see in normal production code. Putting a space here can separate them out a little bit, and there we go. It doesn't matter which order that we put these in right now. We can even put address first, and it'll still work okay, and if we run it, you should still get exactly the same output, it's just specified in a different way. So let's just have a little recap. To make use of name parameters, you don't need to do anything to the original function, you just write it exactly the way you're used to doing. You specify the parameters in the order that you think is sensible, and when you go to call it, you can simply just type in the parameter's name first, followed by a colon, and then the variable name that you want to address. Once you've done that, then you can use name parameters. You can go back to using the normal function by just getting rid of the name followed by the colon, and just replacing all of the parameters using the correct order and the original variables, instead of the new notation having name colon followed by name input. So far we've covered functions with no parameters, normal parameters, optional parameters, named parameters, and let's look at a concept called out parameters. Let's demonstrate a quick example. So if we call a function called test, and we pass in a value, and let's just make this work. So we can have an int, num equals 0, and then we have a test function. So we can say static, void test, and we can say int num, and inside here let's make num the value of 5. Now in this example, if we print out num to the screen, what do you think is going to happen? Is num going to take the value of 5, or is it going to keep the value of 0? I'll give you a second to think, and let's run the code. So let's run it and see what happens. And if you guess 5, you are indeed incorrect, and if you guess 0, you are correct. And the reason why it's not 5 is because when you pass in num inside this parameter, it just becomes a parameter, and therefore it becomes a local variable. Even though these two variables are actually called exactly the same thing, you'll see that when I highlight it, it only highlights this one and doesn't highlight this one, and the same is true for this. It highlights these three references, but not the ones down here. The num variable is only accessible in each other's scope. This one is available through here, and this one is available through here and here. Therefore, if we use this assignment, then it's actually doing nothing. If we print out num inside here, num equals num, and then we print that, we can see that it is assigned the value 5, but because it doesn't do anything at the end of this function, then it simply doesn't get returned back or anything happens to it. So let's see how we can make this into 5 when it gets printed out here. So the options that we have is we can actually make this void an integer, and we can say num equals 5, and then we can return num, or alternatively we could simply just return 5 and not do both of these lines. So if we run that now, then we still get 0. And the reason why we get 0 is the test function is being called and it returns back an integer, but we're simply not doing anything with it. So we can say num equals the return value of this function, which will be 5, and now if we run it, we should see our 5. Perfect. Now this is a little bit cumbersome, and let's say you wanted to return a value and return back another value at the same time, then what are your options? So let me show you a quick example. When you're using int.TryParse, we have a string s, an out, int result, and a bool. So what this function is effectively doing is return you back a true or false value to dictate whether or not the conversion has been successful, and it's also returned you an out int result. And what this means is you can actually specify an integer variable straight inside the brackets, so in essence this function has gave you back two values. It's gave you back something from the integer parameter, and it's also returned back a Boolean variable. So let's convert this to our code and see what the third option is of trying to return back 5 over to this. So if we just comment out this line, and as you saw in the TryParse, you simply just need to put the word out just before here. Out int num. Now we don't actually need to return anything in this specific example because we want to just change a num variable using the out parameter. But if we wanted to return something separate to the num, like a Boolean like the TryParse did, then we have that option. So we can return back true, but just before we return back true, as there's a red underline here, it will say that the out parameter num must be assigned. So we need to give num a value. We give it the value 5 because what we're actually doing here, even if we double click on this, we'll still get num being selected here because the scope is still exactly the same. Now except what's happening is when this variable gets returned, it actually gets put into the variable that it was initially called with. So let's fix these compiler errors first. So the reason why it's complaining is because we need to give it the out keyword. So when we're specifying in TryParse, our first parameter is a string. So if the user types in 123, we put in the first parameter, and then we'd say out int result or something along them lines. You have an out, and then you say you want to make a new integer and you want to call it result. See, in our case, we don't need to put int, just like in here, because we've already created our num. So the only keyword we need is out followed by a space. And now, of course, we're trying to assign this back into an integer, which we don't need anymore because this is a Boolean. So we can say bool success equals test out num. So you print out success, print them both to screen now. We should have 5 and true. The true comes from the return true, and the 5 comes from num equals 5. So what's actually happening here is we're creating our new integer. We're passing it into this function, but we're also telling it that it's going to be an out parameter, so this function can still output things to our number variable, and then when it gets placed inside here, we assign num equal to 5, and then just because we have a bool, we have to return true or we can return false. Of course, we could just take this out completely, take away the return true, and just keep this as test. Of course, in both scenarios, these aren't actually doing anything, they're just complete random values, it's just made for demonstration. So bool is returned back true or false, doesn't actually mean anything, I was just demonstrating that you can have 2 return values from one function. There we go, we get 5 when we run it just like this. So now I've completed this little example, let's have a look at how it's used in the real world. So before we continue, let's see if we can rewrite the TryParse function in our code. So it's going to be a static, returns back a bool, we have a TryParse, our first parameter is a string s, and our second parameter is out int result, and then inside there, we can just do result equals to 0, and then we can return back true. Of course, we actually need to do conversions inside here if you want this function to work, but I'm just showing you for demonstration purpose. If we uncomment this line out and have a look at the parameters again, you'll see that now they line up perfectly. String s, out in result, and it returns back a bool, which we have exactly the same here. There you go. Bool int.tryparse, string s, out in result. So that's how this function has been declared. Of course, they're doing something inside the body that can take in the string, convert it to an integer, place it inside result, and then return whether or not the function has been executed successfully. So now that we understand how to make an example and how to make the TryParse function ourselves, and to give you the declaration, let's have a look at a real world example. So if we had a list of string, and we had our shopping list that was used from the examples, we can have list string, and let's just create our own initializer just with coffee and milk inside. There we go. So now that we've created that, we've got our shopping list. If we wanted to find something inside the shopping list, we have the function IndexOf. And what that will do, as it says here, searches for the specified object and returns the 0-base index of the first occurrence. So if we were to search for coffee, then we should get returned back 0. So let's try and run this and put it in the console write line and see what the value is. There we go, we get 0 since it's the first item, and if we place milk inside here, we should get back 1. There we go. So let's try and rewrite this function into our own code. So all this will do is loop around all of the positions until it finds it, and it'll find the first one, and it'll return us back the index. So in this case, there's no out parameters, but there is a return value. So we can also include an out parameter, and then instead of assigning the value of -1, we can actually assign the value of true or false to dictate whether or not that we found it. So let's write the code normally in here, and then let's wrap it around in a function. So we can say int index equals -1, because we want it to start at a value that we know is incorrect. Since the lists are from 0 onwards, the value is only ever -1, then that means it's not in the list. Then we can then create a for loop, int I equals 0, shopping list.count, because we want to go through every single item inside the shopping list. And inside here, we want to do a lowercase comparison. So we can do if the shopping list, square bracket I, dot to lower, dot equals, and then we want to make that equal to just something that we're going to type in statically, so we can just say coffee. We can make this into a parameter after, but this is just for demonstration purposes. So we have a bracket, and if we found that match, then we can say index equals to I, because the index of the position that we want to find must be up to I, because that's the one that we've made a match with. And we don't need an else inside here. We don't need to set an else inside here to make it equal to -1, because if it simply doesn't find it, then the index variable won't change its value, so it will always stay -1 if it doesn't find anything. So after the for loop is run, let's just print index out to the screen. There we go, we have 0, and if we change this over to milk, and run it again, then we actually have 1 placed inside here. Perfect. So now what our function is doing is giving us the values of the index if it finds it. Now if we type in something else, if you just add another k in, let's see what happens, then we get -1. And -1 means that it's incorrect and it hasn't found it. And what we can do inside here, we can say if the index is greater than -1, then we can say found, or else we can say not found. So let's run the code now and see if we get a visual representation. Not found, and if we change this back to milk, and run it again, then we get found. Perfect. So as you can see here, we're actually checking if the value is greater than -1, but it'd be easier if you had a variable called found, and it is actually a Boolean variable. So we can make a bool found and make that equal to an if statement condition. So we can say something like index is greater than -1, which is exactly what we had here a second ago. And because this is a condition, it's either going to return back true or false, and it's going to place the value inside found, and then we're going to use found inside here. This is easier logic to understand. If this is true, then it's found. If this is not true, then it's not found. True, true, false, false. It's quite really straightforward and very easy and clear. You have an index and you have whether or not it's been found. So let's try and wrap this around inside a function. So just as the TryParse does, it returns us back with a bool, which in this case will be our found, and it also gives us back an integer result, but in this case it's going to be our index. So let's see what we can do to write this. So we can have a static, we want to return back the bool, and we can say find in list. We need to give it the item we're going to find, so we're going to need a string s. We need a string s for the item that we're going to find. We need to give it the list as well, and then finally we need our out int index. There we go. So let's comment out this code here, and let's copy this down into our function and see what we need to do. So index has the value of -1. We don't need the integer variable declaration here because we've already declared it inside the parameter. So after declaring it inside here, we give it the value of -1. -1 indicates it hasn't been found since the index are 0 based. So instead of shopping list, we now just have list, and list here as well. And then instead of having it being equal to milk, we actually want to use our s variable. And to make it better, we can convert it to lowercase, just so we have lowercase conversions on both sides of the equals. If we find a match between the list that we've passed in and the s variable, which is our search term that we've passed in, then we assign I to the value of index. And then it's still got a red underline because we haven't returned back bool. So right now we actually want to return back the found variable. So we have two options here. We can return back found, or we can simply take this and return it back in here. We don't need to run this code to see if it's found or not and then store it and then return it after. Since we're not doing anything else with it, we could just return it like this. This makes the code considerably shorter because this will just return back a true or false. If the index is greater than -1, then it will return back true. If the index is less than -1, then it will return back false. So let's see how we can use this function inside our code now. So we wanted to search for milk, so let's just copy and paste this line, and let's see if we can get the same output as the shopping list IndexOf. So now our function is called find in list. We have a bracket, and then our string s is going to be our milk, our list is our shopping list, and our out int index. So this is going to return us back with a boolean, so we can print that boolean to the screen, and then if we just duplicate that down, and we can print index to the screen, and maybe using a console write line and just place a space right at the start. So we print out whether it's successfully converted or not, and we get the value back from it. Let's run the code. So we get true plus the value of 1. So that means it's found it, and it's found it at 1 index, and the previous line before it, which just run the normal IndexOf function, also returned back 1, so they're both the same. Let's just get rid of that space. So if we change this both to coffee, then hopefully we should see the same result, but with index 0. There we go. This 0 comes from the index function, this true is from our function telling us it's been successful, and this 0 is the index. So we can actually take this and put this straight into an if statement. So just like we had down here with the found and not found, we can say if, and then this function call, and then we can say found, and then the item what we passed in, so in this case it's going to be coffee, found coffee at index. And if it hasn't been found, then we can just print not found. And this is getting an error because we have two indexes up here. So let's comment out this line and let's try running now. Found coffee index 0, and you can see these two are the same again. One comes from here and one comes from that index. If we change these both to milk now, milk, milk, and milk, then run the code, and you can see found milk index 1. If you wanted to, just before you pass in here, you can ask the user, enter an item to search, store it inside string search equals console.readline. And then instead of passing milk in here, we can just pass in search. And then instead of passing milk in here, we can also use the search variable. So now if we try running again, we can type in milk, and then we go, found milk index 1, and then coffee, found coffee index 0. And just to give this a test, let's just try and find M, not found. Perfect. So let's have a little recap based on this function. So initially we tried to assign the value of 0, and then print out a normal function, and inside test, we just had a simple num equals 5. And what this was doing inside is just locally assigning it, but not actually return anything. And then we said we could assign it and then return it back. And that was another option of being able to assign the value to 5. And then we used the out parameter, which allowed you to pass in an integer. When you assign it in here, it will pass it back into the original call and place it in this variable here. So when we print it out on the next line, it says it's equal to 5. We wrote our own little shopping list for the list of strings. And then we called the shopping list function IndexOf, and then we actually created our own IndexOf function and made it into a function. So just a little recap of what's going on here. We have a string s, which is our search term, the list full of the items in the index that we're going to pass back to the user, as well as returning back a bool to indicate whether we found it or not. We set the index to -1, so then that completes our logic at the bottom. -1 means it hasn't been found since the list is all 0 based. If this value is greater than -1, then that means that we found it inside the list, since the list is 0 based. And if it's not that, and this returns back false, then we mustn't have found it, because this line would have executed. So we loop through the list, we do a lowercase comparison on both sides of the equation, on the list item and on the search term. If they both match, we run the index and store the I variable inside the index, and then we return whether index is greater than -1. So after we return this back from the end of the function, we can see once we run it inside the console write line, this is just going to return us back with a true or false value, as well as creating our new integer variable called index. So on the next line, we can use index and print it out to the screen. This line should return true or false, since it's a Boolean return, and this variable will either give us -1 or something above -1. But in this case, when we actually make use of the function, we can ask a user to enter something, get them to type it in, and pass that into the function. But more importantly, when this function returns, if it's true, we output it's been found, and if it's false, we output not found. And we only make use of this integer variable should this return back true. There is no point in printing -1 to this screen, because that's what you're going to get if it's not found. It's going to look something like this, which is kind of redundant because the user doesn't care about this. So we don't need to include it when we're printing not found, but we should include it when we're printing out the found. Of course, this is just a random example, and you might not need to print it out to the screen, or you might just do something else inside here. You might be searching for something, and then you might want to edit it or do something else with it, and then you can make use of that index. If you wanted to ask the user to search for an item, and then tell them what they want to replace it with, then you can also do that, just as we've covered in the last examples. So after we've covered out parameters and normal parameters, let's have a look at a concept called passing by reference. So we created int num equals 10, and let's call it assign, and we passed it straight into here. And we can have a static void assign int num. If we say num equals 20, if we use a console write line up here, then num is still going to be 10. Because we're not returning it and we're not really affecting it. Now other ways we can do this is by changing this into an int, and then we can say return 20, and then we don't really need this anymore, so we could just say num equals assign, and then we'll get 20 assigned back in. There we go. Or we can actually make this an out int num, and then we can say num equals to 20, and then inside here we can say out num, and we don't need to return back an int anymore, so we can make this void, and you can see the value 20. So there are different ways that we can assign a variable straight from here. So let's have a look at another method. So instead of having out, we can actually use this new keyword called ref. And the reason why it's ref, it means it's passing it by reference. So when you pass a value in through a parameter normally, you're actually passing by value. And what that means is, you're copying this value that gets passed inside the brackets into here, and it's making a whole new variable. What I mean by that is, this might have memory address location 1, and then when this variable gets created, it has memory address location 2, for example, and then it's used within here, and then 2 is now deleted because you've got rid of the variable because of this function, but 1 is still alive since in the main function. When you pass by reference, what you're doing is you're saying, give me the memory address location of the variable inside the brackets and give it into this function rather than copying the value. So if this has memory address location 1 and you pass it into here, then it's also going to have 1. So what this actually means is, if we put this ref keyword just before the int, just like we do with the out, and we can place it here as well, we're now saying we want to pass this by reference. So when this 10 gets passed in here, we actually have a link, if you will, to this num is now linked to this num. Which means if we simply do num equals 20 and run the code, then we're going to see 20. The main differences between reference and using the out keyword is when you're using out within a function, you actually need to make use of the value. If I don't include anything within here, then I'm going to get an exception, and it says the out parameter num must be assigned. So when using the out keyword, num has to be assigned. When using the ref keyword, you don't have to make any assignment because we're just passing a reference in. With the out keyword, you'll literally tell the function, I want to output this value. But if you haven't gave it a value to output, then of course it's going to be an error. So we can assign it in the reference if we really want to. But you don't have to, and it's not required. So they're the two main differences between passing by reference and passing by value, and also using the out parameter. Passing by reference is technically quicker because of efficiency. When you don't pass it by reference, you pass it by value, which means it'll essentially place that 10 inside these brackets. Instead of passing the variable in, it actually just passes the value, and then it makes a whole new variable down here. When you pass it in by reference, you're essentially actually giving it a link to this memory address location from inside this function, which means that you don't actually have another local variable inside here because this one is affecting this one directly. You can do this with any amount of references you want by simply just chaining them and adding another one in. Like that, for example, and then we can have a string name, and then we can pass our ref name inside here, and then inside here we can say name equals Abba. And this doesn't like it if it's unassigned, so we just give it empty quotes, or we can assign it another name, it doesn't really matter, it's just a demonstration. And if we run that, but let's just print out the name as well to the screen. There we go, we get Abba assigned into there. And same thing with this variable is we're actually just passing in the variable as a reference rather than as a value. It doesn't matter what the value is going to be because it's just given this variable inside this function. So we're actually saying name equals, we'll basically just assign it back into the original variable. So let's just have a look at another example. So we can have some sort of like change name function, and we can give it the name variable as a reference, and then we can give it the new name that we're going to pass in a second. So if we make a new function, static void, change name, we're going to need a ref string name and a string new name. And we can simply say in here, name equals new name. Perfect. So let's give this a shot. So if we just comment out this little section, and we can say console write, enter your new name, then we have a string, new name equals console.readline. And then just up here, as we've done before, we could just declare the name as being Joe, and then we enter the new name, call this function, and then after we can say your new name is, and then we can pass in name. Perfect, let's run that. So at this point the name is actually Joe, because we've made it appear, and then we'll enter a new name, so we can type in Abba. Now it says your new name is Abba. Perfect. So all this function's doing, I know it's pretty pointless right now because it's just doing one line, but all it's doing is assigning the reference to the variable that we pass in. So what we can do now is make sure that we can actually assign this variable in, and we can also pass in a Boolean variable. So what we should do now is actually make sure that we can do the assignment properly, because you don't want to assign it if the value is empty, and then return back a Boolean type just to indicate whether or not it's being assigned. So what we can do in here is just on the change name, we can wrap this around an if statement, and if this returns back true, then your name has been changed, and if not, we can say console write line, new name cannot be empty, or null. And in order to be able to do this check, as we've used before, we could say if new name, and then just around that we can say string.IsNullOrEmpty and wrap that inside the brackets. And we want to say if it's not null or empty, then we want to do our assignment. After we've done our assignment, we can return back true inside here, and then just outside we can return back false. Notice how in this little bit of code we actually don't have an else. We don't need to write else inside here and place return false inside here, because if this returns back true, then it's going to execute this one line, return back true, and since it's a return, it's going to jump to the end of the function. So we don't need the else in there, because the only way that this line will ever execute is if we actually had this function returning back false. So if this returns back true, it's going to hit this line, hit the return, jump to the end. If this returns back false, it's going to skip over the if statement and then just return back false to the user. Perfect, so now we've got no compile errors, let's give it a run. So if we want to change the name to nothing, if we just press enter, then we can see it says new name cannot be empty or null. And if we type something in, then we get our name changed. So just to round up this video, let's talk about the main differences between the ref parameter and the out parameter. When you assign it by reference, you actually have to make the variable before you pass it in. For example, you can't just write ref string in here and that actually works. Whereas you can't actually do that with the int. Let me demonstrate. So if you had the int.TryParse and that has an out parameter, you can actually type out int index inside here. You don't actually have to make the int index inside here and then specify it outside. You could just initialize and declare the variable straight inside the brackets, whereas because you're passing a reference with the string, you actually need to make the string first and then pass it in. So that's a big difference between the out and the ref. When you make use of it actually inside the function, if you're using a reference, then you never have to assign it, or at least it's not required. You could have a series of if statements inside this body, and then you might determine that you might not need to assign it, which is exactly what we've got here. The only way we assign name is if this returns back true. If it doesn't return back true, then we simply don't assign it and move to here. This is a problem if the out variable. If it changes to an out, then we're going to get a compiler error because it doesn't return back a value. So we'd have to write something like this at the top, name equals something, and then potentially assign it here and then return back false. So with reference, you don't have to worry about the fact that you might not assign it in every single path of your code. And finally, the main difference is the fact that out parameters are still used by value and this is by reference. Reference will be slightly quicker since you'll get the memory address location being passed in instead of the value, so you won't have two copies of the same variable. The focus of this task is to create a function that calculates the area of a triangle. So we're going to ask the user for a width and a height, install them both, create a function to calculate the area. The function is going to calculate it using width times by height, taking that calculation and dividing the value by 2, call it in the main and print out the area of the triangle to the screen. So let's start with entering the width and the height. So we can say enter width colon and have int width equals convert to int32 console.readline. And if we copy these down, change width to height and change width here to height. And just before we continue, because we did copy and paste down, then this is quite bad and we should use a function here. So in both of the cases, we're going to output something to the console and then read it in and convert it back as an integer. So we can say static int, because we return back an integer so we can store it, we can say read int. And we want a string message so we can pass in this value inside here. So we take these two lines and place it inside here. Instead of enter height, we're now going to have message. Instead of int height, we're just going to have a return value, and then we're returning the conversion from the console readline. And now we can use it inside here, read int. And inside the brackets, you want to put the string output, which is going to be enter height. If we paste that inside here, and then do the same thing for the previous section, and change height to width, and now get rid of these, so we just have these two lines. Perfect. So let's just print these out to the screen on separate lines, just to make sure it's working. Say the width of 10 and height of 15, we get 10 and 15, perfect. Since that's working okay, we can now create a function that can calculate the area for us. So we can get static int calc area, and we can have int width and int height. And then taking this formula, we can simply just do return bracket width times by height divided by 2. As you can see, this is literally exactly the same as what we've got here. It's crucial to include the brackets because we want to do this calculation first, take the value of that and divide it by 2. If this is too many steps, you can actually break it down. We can say int calculation is equal to the width times by the height, and then we can simply return calculation divided by 2 back to the function. It's slightly grayed out because we haven't used it, but that's not a problem, we're going to use it now. I personally just prefer is to keep that inside here and just have the brackets, since it's a bit more obvious to me what's going on, but it's up to you as the programmer. Either way it makes no difference, it's just more for the programmer's convenience. So now we need to call the function above, so we can say int result equals calc area and then pass in the width and pass in the height. And then we can have a console write line that just says the area is and then result. And then let's run it. So you have 10 and 15 and there we go, we get the area is 75. Perfect. If you didn't want to call the function inside here and store it inside a variable, you could just output this straight to the screen by placing the function call straight in the curly braces. And if you run that again just to make sure, 10, 15 and we get 75 again. Perfect. So just a quick little recap, we had the console write plus the convert inside this function, which will let us return us back an integer, and we can pass in the message straight in the variable. To make this a little bit quicker and a bit easier, you can actually just change this one word inside here. So you could actually say enter message colon space, and then just inside here you can say height, and just inside this one you can say width, just to reduce on code. Because in this specific case, the only thing that changes between them two string variables was the fact that one was width and one was height. There we go, you can see it's exactly the same now. So after we've read in these two variables, we pass it into the function, and all the function will do is take width and height, times them both together, take that value and divide it by 2, and return it back to the user. And then we can call it straight in here, the area is calc area, and pass in width and height. In this task, we're going to create a function that will return us back with the sum of numbers inside an integer array. So first step is to create and initialize an array of numbers, create the function with the int return type, and it also takes an int array as a parameter. The function should return a total of all the numbers inside the int array, call it in the main, output the total. And just for extra bonus points, inside the function, instead of using a for loop immediately, you can check if the array length is greater than 0, and then return -1 if it's empty, and then check that inside the main and then output a specific message, and also see if you can think of any other implementations you can use. Instead of having to do return -1, how else can you make this function? Whether that means you have to change the parameters or return type or anything like that, just have a think about the situation and see what other options you can make. Of course, the output at the end is still going to be the same, but it's the way you do it and the problem solving skills that I'm trying to get you to get used to. Let's get started. So let's create and initialize an array of numbers. So we have int numbers equals new int, and let's just allocate them manually 1, 2, 3, 4, 5, and add a semicolon. There we go. Now let's create the function sum of numbers, and we want it to return an integer back with the total, and we want to take an int array called numbers. And then inside here we need to actually return back an int, so we can create an int total, make that equal to 0. And at the end we can return total, and then during the middle we're going to have to write our for loop so we can go through the integer array and count through everything. So we can use a for each, var item inside our numbers, and just inside here we can say total plus equals item. Perfect. So if we can call it in here, we can have a console write line, and we can just say sum of numbers and pass our numbers array in the parameters. So we're just going to output it to the screen just for the time being. So sum of values from 0 all the way till 5 is 15. Perfect. So now that we've done that, we've created a function that returns the total numbers, call it in the main, output the total. So we can just say the total is, and then wrap this round in the curly brace. There we go, the total is 15. Now as the extra points, we can check the array length and return -1 if the array is empty. So let's see what we can do in here. Before we even end up going inside anything to do with the total, we can wrap this around in an if statement that says if the numbers.length is greater than 0, then we can proceed with this little section. So if you highlight all of this, hold Alt and press up arrow key, then because it's one back, just press tab once, and just press the delete key here, and let's get rid of the empty line. This is going to return us back with an error because not all code paths return a value. If this returns back true, then we'll eventually hit a return, but if this returns back false, then we'll not do anything inside here. So let's have a look at our requirements. Return -1 if the array is empty. This dictates whether the array is empty, so if this returns back false, then it's going to come into here, and we can say return -1. So we've got this function call in here. We don't want to print the total right now, because we want to make sure that this total is actually greater than 0, because we don't want to make a sum of the numbers if the array is empty. So if we run this right now, we're going to get the total is 15, And if we get rid of all these variables and just have the length of 5, but not give it any values, so all the values are going to be 0, then if we still run that, then the total is going to be 0, but that's still an acceptable value because that's actually got values inside. But if you said the array length is 0, then the total is -1. Of course, we don't want the user to see -1, so we want to bring this back. And instead of calling the function immediately down here, let's call it here. We can say int result is equal to this. And then we can say if the result is greater than -1, then we can output the total. And again, press into this line, hold Alt and press arrow key. And then we can place the result inside here. And the else to this will be cannot add up an empty array. There we go. So now if we run it, we should still see 15. But if we get rid of this and put it back to 0, there we go. We cannot add an empty array. So if we bring that back, perfect. So now if we check this, we've got check in the main, output the message, and then now we've got this little solution. Do we need to return -1? How else can we make this? So right now we're going to have to return back -1 because that's the only way that we can tell the user whether or not it's been successful. If the array is empty, we return -1, and if the array is not empty, then we return something greater than -1, which will be something above 0, or 0 itself, but as long as it's greater than -1, that's how we know it's complete. But we don't actually want to do this. We want to be ideally returning back a Boolean. So let's duplicate this function and show you both implementations. Let's change this into a bool. And then because we're still going to need to reference the total, we're going to have an out int total. So we need to change up a few things inside here. Instead of this return -1, we can do return false to indicate that it hasn't been successful. Instead of returning back total, we can actually just return back true. Now we haven't done everything yet. We don't need to redeclare int total inside here because we already declared it inside here. So we could just initialize total to equal to 0. But the problem here is, if we make total equal to 0 just within this path, then it's still going to complain that total must be assigned. So we can take this and just assign it right at the start of the function, just like that. There we go. So we make total equal to 0, that gets rid of the compiler errors and gives it a value. The reason why we have to give it a value is because this out int parameter doesn't like it if you don't assign the value. That is a requirement for using the out parameter. So we make total equal to 0, check the numbers length. If this were to return back false, then we return false to indicate that we can't do anything. If this returns back true, it will go through and count all of the items, place it inside total, and then return back true. So let's have a look and see what else we can write this little section of code. So instead of having to call it inside here and use it within there, then we can actually do this another way. The reason why we're actually calling this straight inside here is because we can't place this straight into here since it returns us back with an integer. And now that is actually fine if that returns back with integer, because as you can see, there's no problems here. The issue arises is when we have our result variable, we can use it inside the bracket and down here. There's no point in calling this twice to get the same value, although this would still technically work, but this is not really efficient since you're calling the function twice. It's best to call it once, store the value, and then make use of it twice. When we use our out parameter, you'll see that this gets a bit easier. So straight inside the if statement, we can say sum of numbers, and then we can pass in our numbers, and then space out int total. And what that'll do now is, because this returns us back with a bool, we don't need any additional conditions like we have one here, because this will turn us back with a true or false. True if it succeeds, false if it doesn't. So we don't need to say if it's greater than -1, because we don't actually care about the value of the total right now, we just care if this returns back with true or false. So inside here we can take this same output message, and instead of having result here, we can have total. And then we can take this exact else statement and place it here, and let's see what happens now. The total is 15 and the total is 15. So they're both returning back the same values. Let's add something else on here just to make sure it works. There we go. So you can see that both these solutions look very identical, but one is considerably different. We have to make a variable outside, use it inside here, and use it inside here, whereas in this function, we can actually just call the function straight inside. That will process our new out int total, and then we can simply use total inside here. And we don't have to require another additional variable just outside here, as this one will. And you can see that the functions is a little bit better, because we're returning true and returning false to indicate whether or not it's been successful, whereas in this solution we have to return back an arbitrary value and then check that in the console. The reason with returning -1 is kind of a problem is, what if these numbers are actually all negative? Then this value is going to be very bad. This can only really work if all of these values are positive. If you had negatives for all of these, and we tried running the code, there you go. This is a major issue. Cannot add up an empty array. Well, it's not the fact that it is empty, it's the fact that these values are smaller than -1, so you don't actually want to be going with something like this approach, where you're comparing the value because you don't know what numbers are going to be typed into here. If the user were to type in positive or negative, you want to provide a solution just like this one that works for either positive or negative. You don't want to restrict that. By checking if it's greater than -1, only works if all of these are positive values, or this is an index for the array. Since arrays start at 0 and go upwards, you can't have a -1 array position. But in terms of numbers that are randomly typed inside of array, you should always be wary of using this option, because if some of them are negative, then this could return back false. So let's just have a quick recap. So we have an integer array, we have our values initialized down here, and then in the first solution we call the function, pass in the numbers array, get our result back, check if it's greater than -1, then that means it's been successful, so we print it out, and else we tell it it's an empty array. Now second option, we actually call the function because it returns back a Boolean in this case, so we can place it straight inside the if statement, and then we can pass in the numbers array, and then we have an out in total, which will give us the total, and in this case we don't need to check the value because this returns us back with the true or false, and in this case, true determines whether it's been successful and false it doesn't. If it returns back true, then it has some values inside the numbers array that we can actually add up, and if it returns back false, then that means the array is empty. So let's have a look at the implementations. So without the out parameters, this is the first solution up here. We get the number's length, check if it's greater than 0. If it's not, we return -1. Make a new variable called total, make it equal to 0, and we run a for each loop, var item inside the numbers, and we just say total plus equals item, add them all up in the for loop, and simply return the total. And then in the out solution, we have a total equals 0, which just initializes this variable, otherwise we'll get a compiler error. Then we can say if the numbers is greater than 0, then we can say if numbers.length is greater than 0, then we can do the for loop and return back true. And if it returns back false, then we can say false inside here. And then when we use it straight in the brackets, we have access to it straight away since it uses a Boolean variable. And then our value will be placed inside our out int total parameter, which is used down here for the output to the screen. And again, if this returns back false, then it'll say cannot add up an empty array, and then we hit the console read line and wait at the end. There we go, that covers everything inside here. Exceptions are used to prevent your code from crashing and then the program closes down. Let's have a look at a very common example. Let's have a console write, and we can say enter a number. And then we can use int num equals convert to int 32, and then we can have a console.readline inside here. And let's just print out num to the screen. Now if you assume everything goes well and we actually enter an integer like 15 and we press enter, then we simply get 15 returned. And as we saw in the past when we covered the TryParse function, if you enter anything else that's not exactly a number, then you're going to get an exception. Exception unhandled. Unhandled means that we haven't wrote anything specific that will handle this exception, so it's causing the program to close. It's a system.format exception, and it says the input string was not in a correct format. So this is a format exception because we've entered in a very weird set of characters that can't be converted over to an integer. So now our program is forced to crash, and now the rest of our code is going to be deleted now because it won't be able to run. So if you had any important data that was stored just before this point, then it is now lost. This is very crucial because if you have a system that writes to a database or it stores some very important information that someone's typed in, you want to handle the exceptions so if something were to arise, it doesn't actually close the program down and they lose all of their data. I'm sure you've had it in the past where you've tried to do something and the program comes up in Windows and it says this program had stopped responding. When that normally comes up, it means that something's happened that's so fatal that the program cannot continue, it has to crash down, and in most cases this is what's called an exception. So if we run this code again, let's have a look and see what else we can do to make this code break. So of course, as we said before, a num integer can only survive up to about 2 billion numbers. So if we enter a number bigger than that, let's see what happens, then we get an overflow exception. The value is either too large or too small for an int32. Of course this number is very big, and only a long would handle something like this, and an integer definitely won't. So these are the kind of exceptions where you'd have to handle it yourself manually, otherwise your program's going to crash. Coming up next, we're going to go through the ways that we can handle these and make sure our programs don't come to a halt exactly like these examples. I want to explore a technique called try-catch. This is very similar to when we use the int.TryParse. What this essentially does is it tries to do something and it lets you know if something went wrong. This is exactly the same when we're dealing with exceptions, except when we're doing a try-catch, what the catch means is it's catching the exceptions that happen, and therefore it is now a handled exception instead of an unhandled exception. So before we try and fix how this works, let's just explore the syntax. So we can type in try, followed by a curly brace, and just after this curly brace, we can say catch, and then we're going to put something inside the brackets, and then we have an opens brackets. If you wanted a quick shortcut to this, just like we've done the for loop and we double tap tab, we can actually delete this, so you can type in try and press tab twice, and then you get try, the open brackets, you get the exception, and then we get a throw. So let's get rid of this, and what we can do right now is we can actually place the code that we want inside here, inside this try bit. Because we're telling the compiler that we want to try to do the things inside here, and then we want to catch these things. So inside these brackets, what you want to actually do is decide what thing that you want to catch. If you type in exception, this will catch every single exception. Now the problem with that is you'll actually face some difficulties when you're trying to output very specific messages. So as we've said before, when you type in a value too large, you get an overflow exception, but when you type a value that can't be converted like a square bracket, then you get an input format exception. So first what you actually want to do is run this code outside the try, and let's run it now, and let's get them bad values. So we had the square brackets, and we can get this, and let's copy it down and place it inside a comment, just like this, and then let's rerun it. And if we type a number too big, take this, stop the program, and put it inside here. So now that you know what the exceptions are called, we can actually write these inside the code. So we have a format exception and an overflow exception. But before we get into these specific exceptions, let's just catch everything. This is just to catch all, and then see how this works. So as we've put it back inside here, let's see what actually happens. So we can just put a console write line here and say, something has went wrong. The reason why it's something has went wrong is because this is a catch all. Any exception appears during this code, it will always come into here, regardless of what the exception is. Whether it's a format or an overflow, it doesn't matter, it will always come into here. So it's going to be something because this is not specific at all. So let's run the code, enter a very big number, something has went wrong. But if you notice how the program doesn't actually clash, it's still very much live. And we can test this by putting a simple message here at the end that says goodbye, and we run it again, enter a big number, and there you go, we get the message as goodbye. So it successfully skipped over this section without actually causing an exception that breaks the program. So even though we've entered something very fatal, because we've handled it, then there's no problems. So if we now type the other one where we have the square brackets, then you'll see we'll also get something has went wrong. So if we wanted to catch a very specific exception, what we can do is say catch, open the brackets, and we can say format exception, just like it says above here, and then place the curly braces. And what you can do now is you can actually chain these, and these go from top to bottom. When an exception occurs up here, it will match this one. If it doesn't match, it will match this one. And you want to put the catch all right at the end, so if it doesn't match any of the ones above it, it will always match the last one. So you can have a generic message inside here, but you can have a very specific message inside here. Because it's a format exception, you can say please only enter numbers. So now if we run the code, and if we type in square brackets, it'll say please only enter numbers. There we go. So this is a very specific example. And if we copy and paste this down again, and then we can say overflow exception, and we can say please enter a number less than 2 billion. If you enter a very big number again, please enter a number that's less than 2 billion. Perfect. So this will get checked like if statements. It will start on the first one and go down the list. Imagine this is an if, and then we have an else if, and then an else if as well. If you place this one right at the start, then you're actually going to get compiler errors, and you can't actually have the catch all right at the start. So even if you wanted to, the compiler literally doesn't let you. And anyway, you don't really want to be doing that because then you'll be ruling out these two, and it's kind of pointless writing this code if it's never going to get used anyway. So now when we run the code, you can see even if we type in a bad value, our program will still run and everything works okay. So now what we can do is actually make this into a real life situation. So if we actually type in 10.2, then it says please only enter numbers, then we're going to have an issue here, because if we try and print the value down here, then it's going to cause a problem. Let's try and print out num, and you can see that num does not exist. Now we have an issue of scope. Int is only declared within here and here, so if you wanted to print out the value of num, we'd have to print it out up here. So now let's run it again, and if we enter 20, 20 comes up. If we enter 15.5, then it actually skips over this console write line because the exception occurs right here, and then it'll jump into one of these paths. So in order to store the value of num, you can either move num outside here and make it equal to 0, and then assign num inside here, and then you can take this console write line and actually put it right after the TryParse, but I don't really suggest this option. So if you said 15.5, then you're just going to get 0 returned, but we don't really care about the 0 because we're not going to get the value converted, so why do we need to print the 0? And the answer is we don't. So what we should do is keep it all inside here again. And then what we should do instead is wrap this around in a while loop. So this will try to do the code, this section will catch them all, and then we simply have a goodbye at the end. But let's just make sure that this actually runs, because if we type in 15.5, then the user still hasn't entered the number, but our program is closed. So we want to loop around until the user has successfully entered a correct number. So we can say bool looping equals true. And we can have while the code is looping, then we can have the curly braces. And let's place our entire try catch inside here. If we highlight it all, hold Alt and press the up arrow key, and then tab it once, and then get rid of this empty line. So now we'll keep looping around here until this is going to be a different value. So because the while loop will only keep looping until this is true, and the moment when it's false is when it'll cancel the while loop. So as I said before, when we run this code, and then just at this specific line, if the exception occurs, it will actually skip this line and jump below here. So if it skipped this line, then what we can actually do is we know if it reaches this line, then the conversion's been successful. So we can print it out to the screen and we can say looping equals false. And we don't need to place looping is equal to true inside all of these three paths, because if we don't assign it to true, then it's still going to be the value of false no matter how many times you loop around. So let's try and run that now. Enter a number 15.5, enter a number 15, and we can keep doing this forever as it's a while loop, and as soon as we enter a valid character, 20, and now it says goodbye because we hit the end of the program. So that's it for this video, but let's just have a little recap. So we've determined when we ran our code, just these two lines, that in both situations we can have a format exception and an overflow exception. We can use these to catch them specific exceptions and then have a catch-all at the end. The reason why you want to catch multiple is you can have a very specific message. Overflow dictates we have a number that's too big or too small to fit inside of an integer. It can be less than -2 billion or it can be greater than 2 billion, and that's how you get the overflow exception. We get a format exception if you entered something that's literally not a number or something that has decimal places, and then our catch-all can be if anything else goes wrong, we can output a generic message, but in 99% of the cases, you'll either enter a number too big or too small, or it's in the wrong format, and this exception is just so it catches everything else should anything else happen. So at this point, even though our program doesn't actually close and there's no exceptions, the user hasn't had a chance to enter the number again. So we use this inside a while loop, and we can say while looping is true. When we hit a conversion that's successful, we say looping is equal to false, and once it hits this line, the while loop will then exit, and then we'll get our goodbye message. And we wrap the entire try catch inside the while loop, just so this keeps on looping until the user has typed in a successful value. As demonstrated above, we can type all this, and 15.2, 15.15, and then finally says 15, and then goodbye. So I want to explore different ways you can output messages inside this catch block. When you have a catch exception, this is actually a parameter that we're passing in. This parameter can actually have a variable as well. Normally when you specify parameters in a function form, you say int and then something. Whereas right now we're kind of defining the data type, which is our exception, in the same case as int in here, but we're actually not giving it a name, so it looks something like this. Of course, when we do this inside a function, we're going to get a syntax error. But for a catch, we're not going to get any errors at all. And the reason is because we can catch without having to use a local variable. So if we actually add a local variable, make you call it E for exception, then we actually have lots of options inside here. Type E, then we have lots of data, and the stack trace is very helpful when you're debugging, but we'll cover that at a later date. The thing I want to focus on right now is the message. So we can use this and print out to the screen. So we can say error, colon, and then type in e.message, and let's run that. Now if you enter something invalid, input string was not in a correct format. If you enter a very big number, then value is either too large or too small for an int32. As you can see, these error messages are pretty descriptive, and normal users should be able to read this and understand it. Of course, if you want this error message to be more specific, then you can add some more catches inside here, and we can have format exception. This will be if you type in something other than number, but if you do exactly the same thing in here, then it's kind of redundant because you're just outputting exactly the same value. If we try put the square brackets again, then we're going to get this string, which is actually outputted from this line. But even if we include the catch-all exception, you get exactly the same error message outputted from here. The moral of the story is, you should always have a catch-all right at the end of your chain. But if the only thing you're going to do inside here is simply output this message to the screen, then you don't need any multiple catches. What you should do is catch multiple exceptions that you know are going to get fired in your code, and then you want to handle them, and then have a catch-all at the bottom that will display the message generically. Instead of displaying the message right here, you can actually have a more specific message like we covered in the last video. So this could be, please only enter numbers, and we don't actually need the message in this case because we know what exception we're going to catch because we've specified format exception. Another little tip, if you hover over the function call, it says here, format exception and overflow exception, which is the two that we handled in the previous video. This is very easy and understandable if you can just read the values from here and to see what exceptions can get raised. And the same thing here, you get an IO exception for the console write line. The console write can also give back an IO exception as well. Generally speaking, these console functions almost never return back exceptions. I don't think I've ever hit a situation where this exception has been returned, unless you do something ridiculous and maybe you type in way too many values that the console write line can handle. Let's try an example and we can do something like this. If you enter a very big number that can't be specified inside an integer, then console write line has so many overloads that it actually processes it as a long right now. So you almost can't break this unless something fundamental to your computer actually happens. So you have exception E, and with exception E, you can actually take this local variable and print out the message. This is the preferred pattern because instead of outputting here, something went wrong, just very generically, you can actually give them the error message that comes back from the exception. The reason why this is helpful is because if it doesn't hit any of these exceptions and it just happens to fall into the catch-all, at least the user has an idea of what the error message is going to be. The preferred option is to try get to a point where you never have to reach the catch-all and try chain as many catches as you can in order to handle as many exceptions based on the code that you're writing, which can be found if you hover over the function and read the exceptions. Once you've covered as many options as you can throughout the catches, then you almost never have to worry about the code entering this section. Because we've covered both the exceptions in format and overflow, and we can do the overflow right now, please enter a value under 2 billion, then that means we've actually covered all of the catches that are to do with converting an integer 32, covered format and covered overflow. So when we run this code, the only two things that can possibly go wrong are these two functions, the format exception, overflow exception, and we won't ever hit the catch all in this case, but if anything goes wrong, at least we have a belt and braces option to catch it and we can tell the user what happened. And because it's e.message, then the value is going to be quite descriptive so the user can read it without any problems. So in this task, we want to be able to convert a string to an int successfully without any errors occurring and without any exceptions that could break our code. So in steps, we want to create an int and try and convert any string from the console to an integer. Notice the error that appears when you try to do that. Write a try-catch handler around it to successfully operate that and output the message to the screen. And you won't need to change the console outprint and the convert int32 to be able to make this work, so you don't want to change the current code, you just want to add the try-catch handler around it. So why is this a bad situation? How can we know if it's been converted? This is just a question that you should keep at the back of your head, and we'll answer this shortly. And then finally, we want to create a custom TryParse function, find the real TryParse function and copy the return type and parameters and see if you can mimic its behavior. Read the tooltip it gives you to give you ideas on what to do. So let's take these in steps. First, we can have a console write and say enter a number, and then int num equals convert to int32, and then we need a console read line. And then if we run the code, if we try and just convert some square brackets, then we get a format exception. So that's the exception that we're going to be handling right now. So we can take this code and we can wrap it around in a try, use Alt and up arrow key, and then just after do a catch, and then we want to do a format exception, and then space E to give it a variable, and then we do e.message out to the screen, and now let's run the code. Square brackets, input string was not in a correct format. So we get our message, and our exception has been successfully handled and our program hasn't crashed. But the problem is it's got to this console read line, and the user hasn't had a chance to actually enter a number. So what we can do in here to ensure the user always has access to writing a number is we can say something like this. Bool success equals false, and then just after here we can say success equals the true. And then just down here we can say console write line, success, question mark, yay, and then colon or no. So if it converts it at 15, we should get a yay, and if we convert it and it fails, then we should get an or no along with the message. Of course, what you can also do is wrap this entire section inside a while loop, but we've already covered that inside the tutorial, and that means it'll keep repeating this until this is set to true, and therefore exit the while loop, and then the user's finally typed in a number. So let's go back. So we've noticed an error and we've wrote a try catch handler around it. Now we want to catch the error and output the error message, which we've done, and then we haven't changed the current code, which was these two lines. We've added a Boolean and set it to true here, just so we can have a bit of an output message before. So why is this a bad situation? How can we know if it's being converted? So this code is a bad situation because we just have these two lines outputted, and then now that we've added our Boolean to tell the user whether it's been successful or not, it's actually making it a bit more meaningful. The problem is, even if we print or no, then the user doesn't really have a chance to enter it again. So like I said before, you could loop around and use a while loop to make sure that this situation can go from something that gets handled into a situation where the user can actually type it in. There's no point handling an exception and realizing there's an error if you don't give the user a chance to enter another value. If they enter out 15 followed by a full stop when they only meant to type 15, then you need to give them another chance to type in that 15 value, otherwise the program is simply just going to end and nothing's going to happen. For example, 15 dot, it says oh no, or you can have another message that says something went wrong, or you can have a more specific message about the conversion, and then once you press enter, the program simply closes. This is not an interaction that you want the user to be able to reselect another value. So that's why it's a bad situation, because you know it's being converted or not using our bool success, but the problem is we don't have any sort of looping. So let's have a look. So now let's comment out this, and let's see how we can make our custom TryParse. So if you type in int.tryparse, you can see they have a bool, int TryParse, string s, and out int result. So let's try and copy that and make our own custom function. So we can say static, bool, and then it's TryParse, and then we have a string, input, and out int result. Perfect. So now we can get rid of this line just so we use it for reference, and let's use it straight in here, and then we can write the implementation in a second. So we can say if TryParse, the thing that we want to parse is actually a console read line, and then we just say out int result. And the console read line is going to be answer to this question, which is enter a number. We place that straight inside here, and then we say out int result. So if this has been successful, we can print out yay again, and else. If it's not successful, we can print out or no. Of course, you can do other things inside here, or you can even print out the value straight from here. So we can say yay plus a space, and then result, just so we can get that back to the user, and then or no if something goes wrong. Of course, this is just so we can test things and see how they work. So this TryParse function, it will take in a string input, and it will try and give us back the result. So in order to be able to make this successful function, what we need to do is essentially do the conversion ourselves, which will be this convert to int32. So first we need to assign this out int, so we can say result equals -1. So now that we've used that, we actually need to have a return type as well, but let's worry about that in a second. So essentially what we actually want to do is say that the result is equal to convert to int32, and then we want to convert the input, store it inside the result, and if this goes successful, then we want to return true, and if it doesn't go successful, then we want to return false. But of course, we need to be able to do these things separately. So like we said with the try, you only wrap around the section of which is going to be problematic. So in this case, as we've done here, we've wrapped the convert in 32 inside the try, so we're going to need to do that down here as well. So we can open the try right here and place these two lines inside, and then have a catch. Have a little think about what sort of catch do we need. The whole point of this function is to simply convert value and return back whether it's been successful or not. There is no messages here, we just need, has it been successful, yes or no. And because we only need to know if it's a yes or a no, then we can just have a generic exception, and we don't need the e variable because we're not going to access the message. We're going to keep it as an exception. And instead of returning false down here, we actually want to do this straight inside the catch. So now the code reads like this. We set the result to -1, and the reason why we do that is because if we don't, then we're going to get a compiler error, and it says that not all paths we're going to assign result. Alternatively, we can also assign result straight inside here, just so we have an assignment in both paths, or you could just leave it outside at the top. So we assign result to -1, and then we place our problematic code straight inside here. We try and convert the result, and if this line returns back successful, then it's going to execute the second line and return back true. If this line returns back an exception, it's going to miss this line completely and jump straight into the exception and then return us back with false. So let's actually try this and see what happens. 15 dot, oh no, and then 15, yay 15. So the reason why we don't care about the exception in here, we can add in different values as we've used before with format exception, overflow exception, but as we saw with TryParse, it simply just returns us back with a bool. The bool simply tells us if it's been successful or not. So we could stack these multiple times. We can say catch, and then we have the format exception, and then we can place a return false in there, and then we have another catch for the overflow exception, and we can place another return false in there. But as you can see, we're just returning false inside here. So now that we've changed these, it's kind of pointless. Each of them are returning back false, and because we're not doing anything very specific, we don't actually need to chain them all together. We don't care about the message, we don't care about the exception, we only care about the fact that something has went wrong, and if something has went wrong, then we return back false. If everything goes okay, then we return back true, and that's all this TryParse function is going to need to do. It simply converts it, or it doesn't convert it, using an input and outputting a result. So if we run it, we type in a real number, we get a number back, and then 15.0, then we get oh no because it can't convert it. There we go, we've met all our requirements for this program. Let's have a look at how we can do debugging using Visual Studio to step through our code manually. So this is the example I used last time, int age equals 35, and ideally in this case you'd want something like 30 plus to be printed instead of 18 plus. Even though 18 plus is still technically true, we'd still like 30 to be printed in this case, because this says if it's over 18, do 18, if it's over 30, do 30 plus. So in order to start the debugging process, you shouldn't run the code first. If you run the code first, it's going to execute so fast that you won't get a chance to actually put any code in and try and debug it. There we go, we've already hit the console read line and it's executed for a split second. So the best thing to do, just to the left of the line numbers, you want to press in the gap, and that'll create a red dot, and it'll tell you that this is a debugging red dot just in this little tooltip, debugging.program.main. Debugging.program.main. So it tells us that we're in the program class and we're going inside the main. You can also address the debug menu up here, and it says we can have a toggle breakpoint, we can add new one, we can delete them all, or we can actually disable. Deleting them will just simply get rid of them. As you can see here, if I set a couple more and press disable, then it's going to hide them, so when I run our code, it doesn't actually apply the debugging, but it doesn't delete them, and then we can enable them, and then we can also delete them all. And it gives you a little prompt, because if you're doing this inside a big project, and you just spent a lot of time going through and debugging certain functions, then you don't want to be able to delete them all without any confirmation. So let's delete them all and put it back on line 13, which is our int age. So let's run the code and see what happens. So as you can see, it minimizes our console for us, and nothing's actually been printed yet because we're only up to this line. And then we can use these buttons up here. Step into goes inside a function. Step over goes over the line, so it'll go from this line to this line. Step out is used after you've stepped in. If you stepped into a function and then you don't want to see the rest of the function executing, you can step out to jump back out of it, which I'll demonstrate later on in this video. So now that we've hit this line, you can actually see what's going on. So we have int age equals 0, because when this line is highlighted, it means this line hasn't executed just yet. So we can press this, or we can press F10 on our keyboard. If I press F10, you can now see int age has the value 35. And what you can actually do is double click on it and just change the value to 30, for example. Now if you highlight, you can see the value is 30. So you need to double click, change the value to something, and then simply press enter. If you change the value, but leave the box like this, then it won't change the value. So you have to remember to press enter. So now I've made the age 40, but let's just change it back to 35 to keep it the same. And then now what we can do, we can explore what's going on here. If age is greater than 18, then we're going to check if this condition is true or false. So in order to check if this returns back true or false, you can actually hover over the operator, and it says here, age is greater than 18 is equal to true. And if we hover over this one, it says age is greater than 30 is equal to true. Notice what we actually did there. We essentially ran this condition through the debugger without actually reaching this line. We're only up to line 15 as of right now, but we've managed to execute this and give us back a function. So as you can see, age greater than 30 is true, and age greater than 18 is true. And because this is an else if chain, it only cares about the first one that turns back true. And because this one has turned back true, then if you press F10 again, you'll see that now it's went inside this curly brace, which will print out the console write line. And if I press F10 again, you can see we're now waiting on here. If I use Alt Tab, I can get back to the console. You see that 18 plus has now been printed. Now that we're waiting here, we actually press F10 one more time, and then it jumps straight to this read line. Of course, because this is an else if chain, as soon as one of these become true, it jumps over the else if, because of course this is a chain. The first one it hits that's true, it skips over the rest. If we didn't want this to be a chain, then we could keep them as both independent if statements, if age is greater than 18, and if age is greater than 30, and don't use the else keyword. But in this case, because you do want to output a different message for every single age range, you do want to place the else word in there. And now that we've hit this line, we can press F10. And then now we jump back in the console, and now we're waiting right here. And just a little tip when it comes to debugging, if at any point you just want to exit the debugging, you can either press continue or just press F5 and the program will run. For example, if we investigate this variable and we can see the value is 35, and then now we're happy with the rest of the code, we can just press F5 and our code will run as normal. We'll get the outprint and we'll get a read line waiting here. So we know our problem here is both conditions return back true, so just like in the last video, we actually changed this condition so to make sure that it only goes between this range. But let's not repeat ourselves, let's have a look at a different example. So we can have string name equals ABBA, and then int age, and then age equals 23, which I'll demonstrate why I've done it like this in a second. And then let's have a function just so I can show you how to step in. So we can have a static string, print details, string name, int age. And here actually we want to just return back a void because we just want to print it out to the screen. And we can say name, space, age. And maybe just put a dash between them. And let's run that code. Now we can see ABBA-23. Of course, making that function wasn't the point. I actually want to show you what's going on. So if we just print this a couple of times just so we can show you the step out and step in. So if we run the code now, we can see our string name. If we go over that, you can see it's called ABBA. And then now that it's stepped over this line, because there's nothing really to execute here, it's just creating back a variable. So you can see the age is 0 because that's the default value for an integer. And when we skip over that, now it's got the value of 23. So one line creates the integer with the default value equal to 0, and then the next line will make it equal to 23. And then we're passing in the variables here, and if you wanted to investigate it, you could simply just hover over them like this, so you can see what the values contain. And then now that we've hit this function, if we press F10, then it's just going to skip over it. But what we actually want to do is be able to go inside the function. So this is where our step in goes. Step over doesn't care if it's a function or a normal line, it'll just step over it regardless. So we want to, in here, we want to use step into, or we can press F11. Once you press F11, you can see that now it's jumped from print details up here to print details down here. And then now look, if I step through, it's going to actually execute these one by one. So right now it hasn't executed anything. So I step over this once using F10, you'll see it now appears. And then the same thing with this one and this one. And now that I've executed 3, we should see 3 in the console. Perfect. So now what I want to demonstrate is, let's say we're happy with the rest of this function. And then now we want to just step out. So I press this button and you can see it jumps back up to print details, F11 to go in, and then shift F11 to go out. So now that we're back in here, the only thing we can do really from this point is either press F5 to stop debugging or press F10 to jump to this line. And at this point, we've already hit the last line now code. So we don't really need to use F10 anymore because we've nothing to step over. So we can just press F5 and let our program finish, and there we go. So let's have a look at another example. We can have a string message equals read from console. Then we can pass this in, enter anything. And then we can have a console write line and we can just print the message. And then let's create this function. So because it's a return value and store it inside a string, we're going to need a static string, read from console. And then this is one string parameter. So we'll have a string message. And then we can just do a console write. And then print the message to the screen. And then we just want to return the console.readline. There we go. And again, let's put a breakpoint here. And we can remove this one so it doesn't always have to be the first line. If we're perfectly happy with this amount of code, then we can simply take that off and it'll stop when it gets after this line. And now if you look at the console, you'll see all of this is executed. That function is executed 4 times to print the name and age of the screen, and now we're waiting here. So we have our read from console, and now we can step into using F11. And you can see that if you hover over the string message, it has enter anything, which is our parameter that we specified up here. And then there you go, and then that'll print it to the screen. So you tab back in, you'll see it says enter anything. And then just at the read line, we need to actually enter it now. Something. And then press enter, and then just right here, it's going to return it back. So if we use F10, it jumps back in here. And then actually we need to execute this line. So F10 again. And then if we hover over message, you see it says something, which is exactly what we typed in the console here. And then we just print it back to the screen. There you go. And now we're just at the console read line and we can press F5 to finish up. There we go. So debugging is mainly used by pressing this button on the side. So debugging is used by pressing on the empty gap just to the left of the line number and it'll create a red dot. Once you create a red dot, it'll highlight this for you. Once you've clicked on it, it should show up a red dot. You can also disable or delete all the breakpoints from the debug window at the top of the screen. When you run the code, it will stop here, and then you can either use F9 as a shortcut as well. Click into the line that you want to debug and press F9. Please note there is specific cases where if you try and press this one right here, it's not going to let you. If the line doesn't really do anything, for example, this is creating an integer. There's no real action that's happening here that you should or want to debug. This is an assignment, this is an assignment, this is a function call, and so on and so forth. And this is also a function call. When it comes to just declaring variables, then a compiler does not let you put in a breakpoint because there's nothing really to investigate when you're just creating a variable. So don't get thrown off or think something's wrong if you click on the empty line and nothing appears. So that's it for debugging, but let's just have a little recap. We can use F10 to step over, F11 to step into functions, Shift F11 to step out, or you can use the buttons that appear at the top of the screen when you run the code just right here. Hover over variables and you get their values. As I showed you in the if statements, if you hover over the operator inside the if statement, it will actually tell you what the condition is and whether it's true or false. So we can say if 1 equals to 1, and let's just print out true to the screen just so I can demonstrate this. If I hover over the equals, it says 1 equals 1 is true. So that's how you check if a condition is going to be true or false when you're debugging. You can check the parameter values by simply hovering over it, and the tooltip should include the value, just like so. And if you wanted to step into this function, you can use step into, and then use step over, which is F10, just here. And then you can actually investigate these values as well, or you can look at the parameters, and once you're done with the function, you can do Shift F11, or you can use step out, and then you can skip over this, and the same thing with this. You can have a look at the string variable once it gets returned, something in here, and now it says something in here and string message, and then we can print out to the screen, etc. So you can have a little bit of freedom with what you can do in terms of debugging. Play around with debugging in the past exercises that we've made together, and then what you can actually do is gain experience in debugging, so when it comes to more complicated projects, you can also apply that learning there and make sure that your code is error-free. So we covered how to debug by pressing the white space just to the left of the line number. If we run the code, the program will stop where our breakpoint is and it won't execute the line that we're up to, we have to step over it. So we've actually used this before to analyze our functions and see what values are inside things. So we have these extra windows called the local and the auto. So let's take a look at them and see what they're about. So again, if you don't have this layout, you can use Window, Reset Layout, and it should be on the left panel, not the right one this time. So we've got Watch, which we'll explore later, and we're going to have Locals and Autos. So the autos, because we're up to the age, then it shows us the age has value 0, and then that prevents us from hovering over it, and if we step over it, you'll see that now it's got age 23, and now name has appeared. The auto tab will try and figure out what functions and what parameters you need to be displayed down here based on the section of code that you're currently up to. So my guess is because we're up to this function, and it takes in a name and an age, then we're getting name and age appearing. Before we were on this line, it was only showing back the age, and because that section only used the age, we only got age here. But if you press locals, you can see all the variables that are local to this main function are actually showing up. We have a parameter called args, and technically this is a parameter, and it's a string array type, but it's currently unused, but it's still a parameter. So you can see it down here, and then in order we have the name variable down here, then we've got the age, and then we've got the message which is currently set to null, because we haven't created this in memory yet. But as you can see, this changes depending on the scope of our variables. So now that we're about to hit this function, let's use the step into, and you'll see that the locals have now changed. We've got rid of name, age, arguments, and string message, and it's replaced with name and age. Because remember what I was saying about the scope of the variables, parameters inside a function are always going to be local to that function around the curly braces that they're surrounded by. Name and age is only within here, so when it's trying to show us the local variables, it's only local to what's inside these curly braces, which in this case is name and age. So now if we step over this, and then if we step into this read from console, you'll see that just before we step into this function, that these have all came back, because again the scope has changed back to this function, which is our main function, which has all these variables inside. So our read from console will only have our string message, so hopefully when we press F11 or press the step into button at the top, we should only see the message variable inside here. There we go, we get enter anything, because that's what was passed in over here. And then as soon as we return back to that, and we type something in, and then we get all of the values again, and you can see that system.console.readLine had returned hello, which is this line, and then if we press F10 again, you'll see that even though we've got it back here, our message is about to be assigned once we step over this. There you go, it says hello, and as you can see, this changes in real time, so as soon as we step over lines, hello got placed straight into there. This helps us tremendously because we don't have to keep hovering over variables like this to keep checking over their values. You can simply use this menu and it will always update, because whenever you change scopes between functions, that will automatically update as you just saw in them examples. There we go, and then when the program ends, obviously this window is going to close down. So that's a very helpful method of being able to debug without having to hover over anything. In the next video, we're going to cover how to watch variables, and this can be very handy when you're looking for specific errors. Another really good debugging technique is the watch window. Let's press a breakpoint just left of line 13, and let's run the code and let's see what this is about. So we covered that we have the locals window and we have the auto window that will automatically give us the variables that we're currently in the scope of. But let's forget about that right now. Let's have a look at the watch window. It says here, add an item to watch. So there's a couple ways that we can do this. You can actually double click on a variable and right click, or you can just highlight it like this and then right click. And it says here, add watch, and you can press it. It says name, value null, because we haven't created it yet. So the default value is null as of right now, because it's not actually assigned anything. So if you press F10 and step over it, you'll see that it immediately changes to ABBA without us having to do anything except simply press F10, which is the shortcut for our step over button right at the top of the screen. This prevents us from having to hold over the variables to get the little tooltip so we can see the value. The power of this is we can watch variables and we don't have to worry about showing in the locals or the auto because it's always there. And if you have lots of variables like this, then you're only concerned about the one that you're watching. Locals and auto will always change depending on the scope that you're currently at, whereas watch will only do what you want it to do. So because we don't put age inside there, then it simply won't come up just because it likes it. If we check the locals, we have age in there, and the autos, we have age in there as well, but we don't have it in the watch. So what else you could do is actually just type straight into here, age 23. If you really wanted to, you can actually also type in conditions, age equals 23, that returns back true. So if you had an if statement that you wanted to track, then you could do that as well. So let's have a look. So you've had if statement that said, if age is greater than 18, then we can just print out 18 plus to the screen. So let's run the code now and see what happens. So as you know, we have this condition right here. So if you actually highlight this and drag and drop it, you can see that the cursor changes and you can drop it inside here. Let's click on the age equals 23 and click delete. So of course we can't really render this function right now because we haven't even created the integer variable. So let's run over the integer variable, and as you can see here, it says age is 0, which is the default value for integer, and that is indeed 0 right now, and then age is greater than 18 is false. But as soon as I step over this line and it makes age the value of 23, you'll see that these two immediately change. You know they change because the values have went red. Red means that the values have just changed in the last button that you've pressed. Whether that means you stepped into, over, or stepped out, it doesn't matter. Red always dictates that the values just changed. So now it's telling us that age is greater than 18 is returned back true. So when I step over this line, because this is returned back true, I should render 18 plus. Let's have a look. F10, F10, and there we go. We've reached the middle, which means that's going to get printed out now. So moving on to another example, we can have print details. If we go into this function, and let's say we're only concerned about the name, then we can print out the name down here. But as you can see, we already have it twice, so that's just going to update depending on the parameter name. And even if you wanted to show something like this, you can drag this down here and it actually shows you the output. This is very handy so you can see the output, because sometimes when you have it like this, it doesn't look very clear. You can also hover over it right there and you can see the value placed here. But again, it's very handy to have it here so you don't have to keep hovering over the tooltip just to see the values. And from here you can actually change the values. So we can just say Harry is now the value for the name. And Harry is going to be age 35. So when we press F5 and let the program run naturally, you'll see that Harry is age 35 now, and that's all done through the watch list down here, and it doesn't even matter because we have full control over the watch list variables and we can change their contents to see how our code acts in different situations. So please use this watch list as much as you can, and don't forget that once you can double click on variables and add it to the watch just from here. You can also say quick watch, and what that'll let you do is it'll give you the value, and then if you want to add it, you can press add watch here, or you can just keep pressing reevaluate once you've skipped over some lines. So let's say we skip over it now, and then go back onto it, and because it has a shortcut Shift F9, we can just quickly press it like this, and it says ABBA inside here. And we can change the expression, maybe do something like age, and then click reevaluate, and it changes the value to 0. And then we can even change this to like 50, for example. And as you can see down here, it's changed to 50 as well. So you can drag and drop it into here, or you can double click and press add watch. It's up to you. Please make use of this watch variable and don't rely too much on the autos and the local, just so you can keep your own variables inside here, and you can have complicated outputs like these. You can check conditions, you can check console outputs, as well as just checking normal variables. So using the watch window, you have lots of different opportunities to keep track of your code. So we've got another debugging task. Let's try and run the code and see what happens. We're going to get printed over 18. So our value is age equals 35, and we're already getting over 18 printed to the screen. So if we place a break line inside here and actually run the code, we can see what's going on. We can add them inside the watch, just like this. We can add in all the conditions inside, just like this. Perfect. So we can actually see here that because our age is over 35, it's saying greater than 18 is true, greater than 30 is true, but greater than 50 isn't true, and we can easily see that. Except because this is an if and an else if chain, as soon as the first one is true, it's going to enter that one, and you press F10, then we get over 18. And then as soon as it finishes that path, it actually skips all the way to the end. The problem with this is we only want it to print over 30 since it's over 30. So we have to introduce ranges inside here, and we can say age is less than 30, and then you can have age is greater than 30 here, and then you can also insert an and say age is less than 50, and there we go. And now it says over 30. And if we change this to 55, then we should get over 50. And then finally, if we change this to something like 23, then we should also get over 18. Perfect. So what was going on here is because we had if and else if chains, then you're only going to get one of them printed. And because a value over 18 satisfied both the first path and the second path, then it's only going to print the first path. If we actually undo our changes all the way to the start, and then we actually flip the order of this. If we put our this one first and delete the else and change it to else if inside here, so now we have a new chain, except the first one in the chain is actually if age is greater than 30. Now if you run the code, you'll see that the first one actually says over 30. And it says over 30 and it doesn't say over 18 anymore, but it's simply because this is the first one in the list. As soon as it hits the first one, as I'll demonstrate now, it will go inside this bracket, hit this curly brace and then jump straight to the end. You should always order them from smallest to biggest because that will probably make the most logical sense when you're reviewing your code. And in doing so, you can actually have a more formatted code, but you need to watch out that the ranges need to make sense. If you have something like this, then you need to restrict this one because it's going to be blocking the second one. And you don't want to make these all ifs because then you get multiple outputs. Now we should get 18 and 30 being printed to the screen. This is not something you want, so make sure that you place your ranges inside here by adding an and then placing the other end of it, which will be 30, and then this one will continue from it. So just to sum up, what you need to do is make sure that you use else ifs and make sure that you have ranges just so when one exits, it's going to check the other one and the other one. You don't want the first condition to beat the second one if that's for the right path. Age 35 goes into this path, or at least we want it to, but it's been restricted by the fact that age is greater than 18 when we had it like this. This is restricting everything over 18 to go inside this path. If this was even like 65, we should only fall into this one, and we run the code, then we're still going to get over 18. Which is still technically true, it is still over 18, but we have different outputs for this sort of age range. Make sure that you use else ifs and you keep in an appropriate range and keep them in the order of the if statements going from lowest to highest, or whatever makes sense in that situation that you're using it. This is the start of object-oriented programming. Let's start with a concept called structures. Structures allow us to store different data types inside one data type, so it's almost like a group of data types. We can demonstrate this if you wanted to store something like a person. You would normally have something like a string name equals Abba and an int age equals 23. So in here we have a string name that represents their name and an int age which represents their age. And you can see that because these are two different data types, you can't wrap them around inside an array. You can't have a string array called person and then say we want to have two different values. Although this will still compile, we can't store both these data types inside our array unless you make the age and store it as a string, which will be 23 inside the quotation marks, and then you'll have to worry about converting it later on in your program. So this is not really ideal. So we have something called a structure. So just outside here, we can say struct, which stands for structure, and then we can have our name straight after. So we can say person. And the next line we just open the curly braces and let's see what we've just created. So now in order to make an instance of this, we can actually use that like a data type. So we can say person. There we go. So now we've created our person variable. Now you see we've got our own data type. Before we were just using string and ints and arrays and things like that, but now we actually have a new person. So because our person is made up of a name and an age, let's place that in here. String name and then int age. Of course you don't want to give them default values, because like all variables, you don't know what the value is going to be to begin with. So now what we can do, person dot, and we don't actually have access to using these values yet. So what we're going to have to do, there is a concept called access modifiers, which we'll cover on later on in this course. But just for now, what this means is you either have private or public, and they're the main two words. There's other words that you can have, but they're the main two for now. If you have it private, it means you can't access it down here through person.name. But as soon as you make this public, then now it becomes accessible. There we go. We can make that equal to something. And if we take off public, then you see we don't have access to it. It's inaccessible due to its protection level because the protection level is private, which means that you can only access name within these two curly braces. The second you make it public, it means that anyone outside of the structure, e.g. down here, can also have access to name. So if we do that to our public on int age and string name, then we actually can access both now. We can say person.age and it comes up like this. The purple cube is a function and the blue is fields. You can actually filter them out by pressing them down here. Show only methods and show only fields. So we can do age equals 23 and I can actually just place Abba inside here. And now that this data is essentially the same as this, the benefit that we have now is when we print to the screen, we can say person.name and then hyphen person.age. And if you run that now, Then we get abba23. If we actually copy and paste this line down and just remove person dot, just so we're using these two variables at the top of here, and we run the code, you should see exactly the same values coming up. There we go. But now what's really handy about this situation is we have two data types that are wrapped inside of one data type. Instead of having a name and an age, we have a person. Because what gets really easy now is if you wanted to add something else inside here, like for example, birth month, which for me is 5. So in here, you'd have to make another one, birth month equals 5. And then all we have to do inside our person is just say person.birthmonth, and we could just assign it right here, instead of having to create a whole new variable. We add it up here, and then we can use it down here, and then we can add that into here, person.birthmonth. And we can add this to this one, and then get rid of birth month, and as you can see, it's exactly the same. So we've taken these data types and placed it inside our structure, so then we can just reference it by the person. This becomes very, very handy for this exact reason that I'm going to show you now. Let's say you wanted to read this data in from the user. So you have static, and then you're a bit stuck on what data type you want to return. If you forget about the birth month, then we have a name and age as a very basic person. But our return type only lets us have one type, so that's going to be a problem now. So you could do a string return that will give us back the name, and then we can say return person, and then inside the brackets, what you can actually do is do out int age. So you can have two output variables, an out age, and then a return string. So inside here, we could say enter your name, and then string name equals console.readline. If we copy and paste this down, and then we can say enter your age, and then we can say int age equals convert to int32, and then put the console readline inside there. There we go. Now that we've got that, we don't actually need int age because we've already got output parameter, so we just need to be age. And then after we've retrieved them two values, we can return name. There we go. So let's actually try that up here. So we can say new name is equal to return person and then out int new age. And I can take this exact line, paste it down here, get rid of the birth month, and then we can use new age in here and new name inside here. So let's run that now. Asks us what is your name, Abba, what is your age, 23, and then we got Abba23, which is the same as what we've got before. But you see that this situation is pretty messy. We have to return a string variable and also use an output in order to be able to give back two values. Alternatively, what we could do is actually just return back void, and then we can say string, name, and then int age. But we're going to have to use references inside here, and then have string new name equals nothing, and then new int age equals 0. So we have string new name equals nothing, and then int new age also equal to nothing. And then inside our function, instead of having out parameters, we can actually use a reference, and we can say new name, and then ref new age. And what that will do is, we can just return it like this because it's void. Instead of declaring a new string name, we can actually just assign it to the reference it just passed, and because it's a void parameter now, and for the return type, we don't actually need to return anything. So we can actually assign these by reference. Enter your name, Abba, and 23. So as you can see, it still works fine. But let's say we wanted to add another birth month. So we'd have to take the birth month variable, new birth month, make it equal to 0, and then add yet another parameter, ref new birth month, and then we need a new birth month inside here, ref int birth month, and then we'd need another one from here, enter your birth month, and then we'd store it inside birth month. And then finally, we can also return it up here as a new birth month. There we go, Abba 23 and then 5. So we get them values being returned. So in order to keep adding different properties to your code, you have to make a new parameter, a new reference variable, and then append the parameters inside the function. Now the problem with that is, even though you can have an infinite amount of parameters, then this gets very tedious very quickly and you don't want this. So let's have a look at how we can make this function exactly the same way, just using our new structure. You can see that instead of having to pass all of these different things in, or return back a certain value, we can actually just return back a complete person. So all of this can be squished pretty quietly. So actually, let's just comment all of this out. And let's comment out this function, and let's have another rewrite. So now that everything's gone, we only want to be returning and dealing with the person. So we can say static, and instead of void, we actually want to say we want to give the user back a person, return person, and we don't need any parameters in this case. This is only passed in because it's a reference, so we can assign these values back to the original variables, but because we're going to be returning a person, then we don't need to do that. So we can essentially take this code and put it in here, and we can say string name, then we have an int here, and then also an int here. There we go. So now that we've constructed all our variables that we need for the person, what we can do is we can make a new person, person, and then person.name equals name. And then duplicate this down, we can say person.age is equal to age, and finally the birth month is equal to the birth month. And then now that we've constructed our person, we still got a red underline because we haven't returned anything yet, and after all of that we can say return person. There we go. And now simply in here we could just say person equals return person. There we go. And then we can take this console write line here and place it straight underneath since it uses the same properties. Now let's try and run it. ABBA 23 5. There you go. So now instead of having to make a whole new variable, all you have to do is simply just add another one down here. So we can just say number. This could be your favorite number or anything, and we can add it onto here. Person.number. And then here we can paste this down. We can say enter your number, and then it'll be number in here. We can paste it down here and change this to number. And there we go. That's all we need to change. And this code doesn't change because it's simply calling back the function, and we're doing all the hard work inside here. So now if you run this, enter your name, ABBA 23 5, and finally 4. And there you go, we get the values being returned. So this looks a little bit tedious. We have to assign each one individually every single time we do it. So we can actually use something called a constructor in order to achieve this result. We make the person, we set them, and then we return it. It'd be easier if we could have the constructor that we can assign straight inside here and then just return it immediately instead of having to do all of these lines and then reference each one individually. So let's have a look and see what we can do. Inside here, we can have a new function that'll just be called whatever the structure is called. Then you open the brackets, close the brackets for now, and this is called a constructor. In order to be able to use it down here, we need to make it public in order for someone else to access it. So this says that it needs explicit parameters in order to be able to compile. It says that it needs to assign name, age, birth month, and number. So let's see how we can do that. As we've used constructors in the past, for example, when we had things like the string builder, we had SB equals new string builder, and when you make a new something, that means you're making a new constructor. So all of these 6s are the parameters that go inside of this, but each one of these is a separate constructor. If we control click this, we should be able to see them all. There we go. You see that the class is called string builder, and this is called string builder, and these two names match exactly. So to make a string builder, you can give it any one of these as long as your parameters match one of these 6. You can give it nothing, or you can give it some other values. And that's the same is true with our current person. So what we need to do in this case is we don't have multiple ways that we can construct this. In the case of our person, we have to provide all of these details, otherwise the compiler is not going to like it. So we can have a string name, int age, int birth month, and an int number. And now we've got our parameters set up, we actually need to make use of them in here. So because we have name, and they're exactly the same, string by string, then in here we can't say name equals name. In terms of global and local variables, this is global within the structure, as it's within these two curly braces, and all of these variables are only within these two curly braces. Local variables always take precedence over the main one. If I double click on this, you'll see that all 3 are referencing this constructor. If I double click on this, you'll see that both name references on line 20 down here is all referencing this one in the parameter and not the one up top. We want it to be assigned into here. So you have 2 options in this case. You could capitalize all of these, so then you don't run into this issue, and then instead of name equals name, it's capital N equals name, and that fixes it. Alternatively, if you want it to be a lowercase, then what you can simply do is you can place this dot. If you use this, it goes back to the current scope, and the current scope of name is going to be this, which is within the structure. When you use this, it doesn't reference the local variables, it references the global variables up here. So when I double click on this now, you'll see that that gets highlighted. So we can say this.age equals age, this.birthmonth equals birthmonth, and finally this.number equals number. So we're just getting all the parameters from here and putting them into these values. This might look a little bit redundant, but I'll show you why this is a lot cleaner. So back in our return person function, we have the variable and then we assign them all manually. But look how easy this now has become. If I comment out this return, we can say return person. So now we can reference person with a capital P this time because I want to reference the structure directly. So after the person, we can open the brackets and then start to type in. So our first one is name, age, and then birth month. Name, comma, age, comma, birth month, comma, and then number, comma. And then this is not going to like it because we also need to place new inside. As I said before, when you're making a string builder, you have a new keyword, and this new means that you want to create a new instance of this. You could think of this structure as a template. This is the template for something, and until you start using that something, it's actually not going to do anything. So we have to make a new instance of it because it's not already available, so we need to make it available through our data type. So when we say we want a new person, that gives us access to the constructor. If I remove that, you'll see we've got one of two. Now we can create an empty person, and that will just make us assign all the values individually, but we don't want that. We want to use the second path, and if you drop the arrow, you'll be able to see the different parameters, which is the ones we just typed in. Name, age, birth month, and then number. And now that we've returned back this, we actually don't even need to do any of these lines right here. We can actually just return it exactly like this. So now if you run it again, you should see exactly the same output, 23, 5, and 4. Perfect. So let's just have a little recap. So normally when we're creating variables, we use common variables that we've used in the past. String, int, double, float, bool, etc. But with the use of structures, we can create our own group of variables, and then we can use them variables inside functions and inside our code to make things a lot cleaner and a lot easier. So inside person, we actually store 4 different variables, and they can be an infinite amount of variables should you will. And you can easily remove them and then remove them from the parameters and from the assignment, and then that's it. If we use this without our structure, then we're going to have to declare every single variable separately, and I know this is the same as doing it up here. It's actually a little bit more work because you need to create a new parameter and create all the new instances inside here and assign the values. Now the benefit of doing it within a structure is that when you go to do a function, look how easy this line is. Before you'd have to have name, age, birth month all as references or have them as out parameters, and it gets a little bit long and a bit sloppy. In order to include the month in here, we'd have to have another int number, and you can see that the parameters are growing. If you wanted to store a user from a registration form, you might have name, address, phone number, country, and the list goes on. It can be a very long form, and therefore you'll have a lot of parameters. So it's very easy to wrap it around inside a structure and then simply reference it like that, and you'll need 0 parameters because everything is contained within the data type. And then inside here, we can ask for the user's details individually, store them as their integers and string variables, and then instead of using this notation, we can now use our fancy constructor where we can pass it in this exact order right here. Name, age, birth month, and then the number. Perfect. And then we can use it inside here. We can call each of these positions separately and concatenate them together. So now that we've covered structures, known by struct as the keyword, let's have a look at classes and how to define them syntactically. So we can make a struct called person, and we can give them a string name and an int age, and to make them accessible, we'll make them public. And we can say public, person, string name, and int age. And that means we can assign these values using the constructor. So we can say this.name equals name, and this.age equals age. Perfect. So let's get rid of our compiler error since we're assigning both the values. And then down here we can use it. We can say person, person equals new person, and then have ABBA, and then 23 in the brackets. And we can print to the screen person.name, and then if we use Ctrl D to duplicate that down, and we can do .age, and if we run that right now, we should see ABBA and 23 being printed to the console. Perfect. So as we talked about in introduction, syntactically the struct and the classes are very similar. So let's comment this out so we don't get any compiler errors, and let's see how this is going to work. So of course we're going to get error on this line, but once we make our class, the error should disappear from here. So instead of struct person, we're simply just going to have class person. Exactly the same, and because these are fields, we can also copy these down. So we can have public string name and public int age. And then we can have public person and then string name, int age, this.name equals name, and this.age equals age. So as you can see, this is exactly the same as this, except for the fact we have structure and we have class inside here. Now you see our compiler error is gone, and if you run the code, we should see exactly the same output. There we go. Now the main difference about classes and about structures is that you don't actually have to give these a default value inside the constructor. If we just comment this one out for a second, and if we bring the structure back, and we actually remove the parameters from here, then we're actually going to get compiler errors, and it says that the name and age must be assigned before it's returned, and structs cannot have parameterless constructors. Now that's a bit of a problem in certain cases. You might want to create an instance of something but not actually derive any values. So you could actually make these into default values. You can have string name equals nothing and int age equals 0, and therefore once we place it inside here, then there's no problems. If you run the code, then you will get the output, this will be nothing, this will be 0, and you'll get errors. And you won't get any compiler errors doing it this way. But the point is, you have to include them and you don't have a choice. So if we just comment this back out, now what you'll notice about the class person is even if we get rid of it, then it still lets us have it. Of course, we can't actually give it parameters since we don't have a constructor that lets us have parameters, but what you can do as well is you can overload this and actually include it as well. So you can have another set that literally lets you define both of them. And then you can even have another overload that lets you just include the name without the age. And then also another one that lets you include the int age without the name. Or you can include both the details. So in these cases, what you can do is you can store the values up here as the fields, let them use a default constructor, or only give it the name or the age, or you can actually give it both. So when we come down into here, we actually now have 4 different constructors. We can make an empty person, we can make it with an age, with the name, or with both. And what you can do in here is you can say this.name is equal to nothing, and then here you can say this.age is equal to -1, just to default it to a value that's incorrect. So after we've got this, let's have a look at the different ways. So we can give it a person, which gives us an empty value. So if you run that now, we get blank and 0. And if we just give it the name, which is Abba, then we should get Abba and -1. Yep. And then if we just give it the age, you should get nothing and 23. And if you actually give them both, then you should get both printed out to the screen. And there we go. So now we have 4 different ways that we can create our person. With our structure, we're only really limited to 1, since all of these values need to be assigned as the structure is created. Structures are meant to be used as an extension to a data type rather than almost like a mini management system. When we make a class, we have so many options of different ways that we can do this inside here, and later on in the course we're going to show you how to include functions inside here and then eventually do other advanced techniques with classes that aren't directly available with structures. If you have a basic example where you want to extend something to use inside a function or a data type like storing name and age, instead of having to do 2 return types inside a function, then a struct is perfect. The second you want to do more complicated things or make it a bit more specific and flexible, then classes are the way forward. You'll see it very often in games where they have a struct position. You'll see it in video games where they have something like a struct position, and they might have int x, int y, and int z. And that's for their 3D position, or they may even just have an x and y, or you could have something simple like a rectangle, and you can give it a width and a length. So now when you use that inside the code, you're going to have different flexibilities of the amount of data types that you can store, and then when you return that back from a function, that'll be okay as well, since you can use this as a data type. So if you want something simple and straightforward, then go for the struct. The second you want something a bit more complicated and a bit flexible, then you probably want a class. We'll go into more different situations inside this course so you understand in which cases to use what, and in most cases you'll notice that the class is more applicable. So if you wanted to, you could ask the user to enter these details in, and then you can pass them inside the constructor. So we could say console writeLine, change this to a write, enter your name, string name, console.readLine, and then copy and paste this down, change this into a int age, and then wrap this around inside a convert in 32. Instead of enter your name, it'll be enter your age. And then since these are grayed out, it means we haven't used them, so we can change Abba to your name, and then change 23 to age. Perfect. So now if we run the code now, enter your name, Abba, enter your age 23. Then we get Abba 23 printed out to the screen. So just a quick recap. Constructors are basically defined the same way. You have public, followed by the class or the structure name, and then the parameters inside the brackets, and then you can assign it after. With our structure, you have to declare all of the variables inside the parameter and assign them all down here, otherwise you won't be able to run your code. With classes, we have the flexibility of just including one default function, which will just be our constructor, and even if it does nothing, this is still acceptable. And then we broke it down into multiple sections, where you might have situations where you only want their name or their age, or you might even collect both to store it. If you collect their name, then we'll initialize age to -1, just so you know that this is a bad value, and if you declare only the age, then we'll initialize aim to nothing, just so you know that it's an empty value, and if you accept both, then we simply assign both. And down here, we have access to it. We can even make this a little bit better by checking these values. So we can say if string is not null or empty of person.name, and we can put a not inside here, then we can print out this. And then the same thing for age, we can say if person.age, we can say greater than -1, since we set -1 as the bad value. And then we can move this line up, and let's try run it now. So these two if statements are fundamentally separate from each other. One is checking the name, and one is checking the age. So let's try and manually type these in and see what happens. So enter your name, let's make this blank and only include the age, and let's see if this runs okay. So if you add no name and the age is 23, then you see we only get printed 23, because it'll skip over this line. As you can see, if we put a breakpoint in now and just refresh the code, we get empty name plus 23, and when we press F10 over this line, it jumps to the next one, because if we hover over this, you'll see that it should return us back with false. There we go, we get string is null or empty is false. So that will skip over that, and because the age is 23, then this line is going to execute. Let's run it again and do the opposite. We could say name is Abba, and then age is -1, and then we get Abba printed, but not the age. There we go. So if you wanted to fix these in and type them manually, so we can say 23. There we go, we get 23, and if we only include the name, Abba, then we only get Abba printed out, and if we include both of them, then we get them both printed out. Perfect. So now that we've created our class, we've gave it some fields, and we've made our constructor that lets us initialize it. Let's see how we can print the details out to the console. So we can have a CW tab, a console write line, and then we can say string interpolation, name, colon, space, and then we can have our curly braces, and we can say person.name. We can access these fields using the dot operator, and then we can say \n for the new line, and then say age and the same thing, person.age. Let's try run that and see what we've got. So now we've outputted name and age out to the screen. Let's see how we can do this inside a function. If you wanted to place this in different parts of your code, then you're going to have to copy and paste this, and as we know, this is bad for our code because it's data duplication. We want to be able to wrap this inside a function somewhere. So let's see what we can do. We can have a static string, so you can return us back with this that we can output straight to the console, and we can say return details. And for our parameter, we can have something like string name and int age, because that's what our class is made up of. And inside here, we can simply take this, put it inside here, and put a return before it, and then get rid of the person dot, since we have an aim and age variables as local to the function. So now instead of this line, we can duplicate this down, take out the contents, and we can say return details, and then we can place person.name and person.age inside here. Let's run the code. So we get exactly the same output, but the problem with this function is we're having to type out the parameters manually. We have them here, and we're going to have to type them again in here, and again for the parameters. This is a bit of a problem because we've just made our class, but we haven't really used it when we're passing it in. So instead of having string name and int age, we can actually duplicate this method and just comment it out, just so you can see it for reference. And instead of doing this, you can actually just pass in an entire person. So now we have access to person, and we can bring this back and we can say person.name, and we can also say person.age. And the reason why this method is preferred is if you actually have something else, public int number, and then you added another one inside here, int number, and then you said this.number equals number, the parameters won't have to change inside the function. All you have to do is simply pass in the person, and then now we actually have access to doing person.number inside here should we need to. If you're passing them all in one by one like this, then you have to append into number on the end and then add it straight to here. And then also add it inside here as you have like this. It's easier to pass the class in because all of these properties above are just simply used throughout the function. So now if we just bring this back, and let's have a run and see if we get the same output. Which we do, name Abba, age 23. Perfect. So now that we've thought of two functions how to do this, we can manually type in the strings and the integer and any other parameters that we need, or we can actually pass in the person. The problem with these two approaches is the whole point of having classes and structures of the like is so we can wrap around lots of functionality inside it. If we want to send this to another developer for them to use in their project, or maybe this is a file that is shared within the projects, then you don't want them to include a separate function that is simply outside of the class. We want to include the functions inside the class. So of course, as you know, these are functions. So inside here, we can also make functions. So let's do it. So we can have public, and we want a string, return details, and then we don't need to pass anything in. The values that we're going to be returning are these two right here, which is technically local to our class. So therefore, we're not going to have any parameters. I'll explain that further in a second. So we can take this exact line, paste it straight into here, and get rid of the person dot, and get rid of the person dot on this side. So then we have the name variable and the age variable. If you double click on them, you see it references these variables, and the same thing for age. The reason why we don't have parameters is when you call this function, as I'll show you in a second, you call it directly on the person. So the person that you're trying to print has already got these contents inside of them. So let's have a look. We can duplicate this down, and instead of calling return details and passing the person, you actually do it the other way around. You say the person object dot return details. So now we're calling return details inside our person object. Now let's run the code. You see that the output is exactly the same, except now this functionality is a lot better. Our return details is wrapped inside our class, which is the preferred way. And now we can actually get rid of these inside here. And then we shouldn't really use this notation, even though it is technically correct, but you want to wrap all your functionality inside here. And just bear in mind that scope is also applicable here. Return details is within this class, which means if you try to run this function inside the main, then it's not going to know it exists. This return details function was able to be used inside here because this was in the scope of the class program, which is this curly brace and this curly brace. But this return details is only within the scope of this class, which means you can't just suddenly use it inside the main. So please bear that in mind when you're producing these classes and you're trying to understand where everything goes. Every function that you place inside here is accessible through the dot notation after the object once you've created the class. Say person equals new person, and then after we type person dot, then we'll get a list of all the functions. The same way if you have something else, just like this. And then if you do person dot, and then you see that something has appeared there. So all the functions that you create up inside in this class, for every person that you make, it'll be accessible through the dot notation. So just to round up this video, you should always make your functions inside your class. Having them inside the class is the whole point of making a big class and have lots of functionality inside. If you keep the function that does exactly the same thing outside of the class, then if you were to share this file or come back to it in the future, then you're not going to understand why you've done this and it's outside the class. Keeping everything wrapped inside the class is the best way forward in most case scenarios. So now we have our class person. It's got a name and an age, a constructor, and a function to return back the details, and we can simply use it like this and return back the details like this. But so far we've covered how to make classes, constructors, etc. and assign the values, but the values are only getting assigned throughout the constructor. But what if a different part of our program, the user wants to change their name or update their age, etc. Then what options do we have? So you know we can access our fields using person.name, and then you can simply type equals, and then type in another name, and we can say person.age equals 25. Now we've changed these properties. If we use the console write line and return details, you'll see that the values have indeed changed. As you can see there, it's changed to Harry and 25. This is okay, except for the fact that this shouldn't really be possible. We should try and restrict this directly by the use of getters and setters, so for now we're going to cover fields and how to restrict certain values, and later on in the course we're going to go through what properties are. So before auto properties got invented, we had to use getters and setters. Getters and setters are essentially functions that will prevent this from happening. So the reason why we can do this is simply because this public word is placed right here. If we change it to private, it means that name is still accessible within here and here, which is only the limits of the class, but as you can see, it's not applicable here. This is why you need the public getters and setters. So I'll explain what that means now. So we prevent these from accessing outside the class by making them private, so this functionality no longer works. So what you have to do instead is for every field that you have, you need to create a getter and a setter function. So in order to set a value, we can have public, and because we're setting it, we don't need to return anything, so it'll be void. And we can say set name, and then we pass in string name. And then we simply just say this.name equals name. So when someone calls set name and pass in the name like this, we just override it. So let's see how that looks. So if we comment these two lines out, we can simply say person.setName, and then we can say Harry. So this line is directly replaced by this line. And now if we run this, we'll see that Harry should be changed. There you go, Abba is changed to Harry. This is really powerful because what we can do now is restrict the access inside here and make sure that the value contains something genuine. We can say if string is null or empty and then pass the name inside there. If the string isn't null or empty, then we assign it. And if it is null or empty, then what we can do inside here is we can say else this.name equals nothing, and we can keep it blank, or we can use string.empty, just to make sure that we know that the name has been blanked out if they've entered something invalid. If they've entered something that's valid, we assign it. If it's invalid, then we don't assign it, and we just initialize it back to nothing. And because our options are endless with this, we can actually make this into something else. We can simply just say invalid name. So then what happens is, if we try and change this to nothing, and we run the code, we can see that we get invalid name being printed to the screen. And that's a lot better than if we had string.empty, because if you had string.empty, then it would kind of say nothing. Then it looks like something's went wrong. If you have something like invalid, then that gives you a bit of a better message. So we can have invalid name there. So using our setter lets us change our name from down here without directly exposing the public. If we expose the public, then everyone who uses classes can simply change the name to whatever they want. Having it private and only changing the name within the setName function is very preferable because you can restrict the access and what people can set the values to. If they try to set it to something that's not valid, then we set it to invalid name. Whereas before, when we did this, and if we make this public again, we can simply set this to something bad like null. Null is a very bad value, but it still lets us have it. And the reason why it's very bad is if you try to do something like this, person.equals, and just some empty brackets. Now, even if I just leave this empty, the fact that you try call equals on side person.name is going to be a bit of a problem. So we can say person object, the name property inside it, and we're checking if it equals to Abba, for example. But because we've just set it to null, let's see what happens. You see that we actually get an exception. It's a null reference exception because if you hover over name, you see that it returns back null. Nulls are very bad in this case. Whereas if we actually bring our function back, and we make this into a private, and then if we try and take this value, our null value, and place it straight inside our set name, if you uncomment it, get rid of the quotation marks, and if you actually try and assign it to null, let's see what happens. Then we're going to get invalid name, and this prevents us from breaking our code if a function like equals were to be called on any of our properties inside of name. So now that we've done it for our name, we can also do it for our age. But before we do that, we can also call a function called getName. Return details gives you back these details in a very specific fashion. But what if you wanted to do something like this? Your name is, and then you wanted to do person.name. But of course you can't do that because name is no longer public, so you can't reference it directly. So we've got a set name, and then now we need to do a getName. So we can have public, and because name is a string, the return type is going to be string, and we can say getName. And this function is very simple, it just returns back name. And that's it. There's no parameters because all it does is return back a value. And in this case, it's just returning back name. So instead of using person.name in here, we can say person.getName. Open close the brackets to indicate it's a function, but there's no parameters. Now you see that we have no compiler errors. So now if you run that, you'll see that it says your name is invalid name. So let's actually give it a value. And we can say Harry again. Run the code. There you go. Your name is Harry, so it's officially changed it. And now let's work on the age. So just following the exact same approach, we can have a public void set age int age. And instead of just doing this.age equals age, let's try set some boundaries on this. We can wrap this inside an if statement. So as for the condition, we want to validate if the age is successful. So we want to do if age is greater than or equal to 0 and age is less than or equal to 150. So this means if the age is less than 0 or greater than 150, then this is going to return back false, and then it's not going to assign the value, and we can simply assign it to -1. -1 is just so we know it's a bad value. So now that we've created our set age, we can actually make our get age. So we want to return back an int because that's going to be the data type for our age. So we do public int get age. We don't need any parameters because as like the name, we're just simply returning something. So we can say return age. So now that we've made the set age and the get age, let's actually use it in our code. So we've made our set name and let's say person.setAge and we have 25 inside here, just like above. And then now that we've set the age, let's append this sentence. We can say and your age is, and then person.getAge. Perfect. So let's run the code and see what happens. There we go, we have 25 and Harry being changed. So another little tip when we do in this code. Our getAge is one line, and our setAge is a couple of lines, but we're fundamentally only assigning age. So what we can do is, we can make these into the tertiary operator. So as we can see here, this is the condition. If this returns back true, then we assign age, our local parameter, and if this returns back false, we assign -1. So we can actually make this into this.age equals, and if you remember the format of our conditional operator, we use condition, true, and then condition false. So this is our condition that is leading our if statement, and if this returns back true, then we do question mark and put age in there, and then colon. If it returns back false, then it's simply -1. There we go. So this has actually been entirely replaced by this one simple line. And we can do the same thing for our string. So we can say this.name is equal to string.isNullOrEmpty, pass the name inside there, and if that is true, then we assign it to name, and if that is false, we say invalid name. Let's comment this one out and let's see if our code runs okay still. Harry 25, Harry 25. And now let's try our bad values. So we can try set the age to 200 and the value to nothing, and let's see what happens. We get invalid name, -1, and there you go. Perfect, so that's working okay. Let's undo them values. And you can see that this has been shortened completely. Another top tip for functions like this, you can actually use something called arrow functions. And if you've done any JavaScript, this might be quite familiar. So we can have our getAge, and instead of opening the curly brace at this point, we can actually place this arrow inside. So if we comment out this one, with arrow functions, you can only return back one simple line. So because this is only one line, we can have return age. But arrow functions don't like the keyword return. Any variable that you put straight inside here is automatically applied that it's a return type. So we literally just put age. GetAge returns us back with age. If this is confusing, then stick to this approach. But this might tidy up your code because instead of having all of this and all the curly braces for one simple line, you can use arrow function. So if we actually copy and paste, but first comment out all of these functions, you can see how small the code can actually get. There we go. And then let's actually have a public void setAge. Let's put our arrow function in, and then we can take this one line and paste it straight into here. So you can see that these two lines are now being replaced by all of this. And of course, we need our int age inside here. There we go. So now we can do the same thing with our set name. We can take this. We can have public void set name, string name, and then have our arrow function, and then simply paste that in. You can see that this will get a little bit long now, but it's still ideal. I've got the code zoomed in, but if you put that to 100%, you see that this code is actually pretty small. It's just I've zoomed in just so you can see the code a lot clearer. And then finally for public string, and we can get name, and then we simply just do arrow and then name. And you can see that with all this other code commented, We're just relying on these functions as we just created, and you'll see there's no console errors or anything else. So if you try and run it, you'll see that everything is going okay. Of course, if you don't like this notation, then you don't have to include it. You can stick with the curly braces. I don't use the arrow functions a lot in practice because there isn't many situations where you'd actually use them, and even if you do, some people might not like them, or there might be certain guidelines that you might be following inside a company. What I do suggest you stick with is the tertiary operator. These are a lot good and a lot better to use since it reduces the code drastically. If we actually remove this, and I'll paste it back in just so you can see it for reference inside the resources, but you can see that these 4 functions are now reduced to on one page. You can see that they're all got 1 lines and they're pretty short. So let me undo that just so you can see the original code and have it for reference. So there's a lot covered inside this video, so let's just have a little recap before we finish up. So just to start at the beginning, when we initialize our person with their name and their age, we don't actually have any other opportunities to change their value, which is where this comes in. You can actually just say a person.name and assign any sort of value. You can put anything inside there and it will assign it directly, unconditionally. The problems with doing this is someone might expose it to null by accident, and somewhere in your code, if you're using something like equals, this will actually prevent an exception. Of course, you can wrap this inside a try-catch, but this is unnecessary because we can prevent this in the first place. It's always best to prevent an exception than to put additional code in like a try-catch in order to catch something that you can prevent in the first place. Prevention is definitely better than the cure in this case. So having something like person.name being exposed, it's not so much for the integer because integers will always have number values, whereas strings, they can be initialized to null. There is no such thing as null in our age. Our default value for an integer is 0, so we don't really have the same issue. We started introducing the name function and the age function. These are used so we can control what values get assigned to our local variables. And we also have our get functions, getName and getAge. So let's explore how these are made inside our class and expand on that and see how they work. So first, we need to make sure that our variables are actually private. They're private so we can't access them just like this. If I copy and paste this line above, you'll see we're going to get a compiler error. And this error is because we can't actually use it because, as it says here, it's inaccessible due to its protection level. And the protection level comes from the fact that this is indeed private. It's private, so it's only accessible within class person. So every reference to name can be used inside here, just not outside. So the only way to be able to change the name now you've made it private is by enforcing this function. The good thing about this function is we can check if the value is invalid, and then we can store it if it's valid, and then change it to something else if it's invalid. And then we can wrap this if statement around in a conditional operator just to make it a little bit shorter. And in order to retrieve a name, because now that we've made it public, we can neither set or retrieve it. So we have our getName function that simply just returns it back to the screen. Nothing special here. And the same thing for our setAge. We can check if the age is between 0 and 150 and assign it, and if it's not, assign it to -1, and then again wrap it around in our conditional operator. And then for our getAge, we can just return age. I demonstrated arrow functions inside here. You can take all of these one-line functions and actually add them all in one line without the need of curly braces. If you want to return back an age, then you simply just type in age, just like you can see here and here. When you do assignment, you want to specify this.name equals, but when you're doing returns, you just need to type in the variable that you need. Of course, this looks a little bit cleaner and a bit shorter, but not everyone likes this notation, so it's completely up to the developer or the environment that you're working in. And finally, we just have our return details. And then we can make use of them just like this by using person, which is the name of our local variable for our new instance, followed by a dot, and then setName, setAge, and then getName, and then getAge. So now that we're dealing with classes, it's important you focus on the scope. We have a person here that's defined within the main, which means it's only within these two curly braces. So if we had a static void and a function that did something inside here, we can't access person inside here. If you take out the comment and we try it, the only reference we have is accessing the class directly, not this local variable. If you want to access the local variable from inside this function, then you'd simply have to pass it in like this, and then it'll finally become available. As you can see now there's two, and it says as a parameter. And the same goes for this class above. Just because we have name and age up here, it doesn't necessarily mean that we can magically use name down here. If we have something like a static int defined right here, then we can use this integer inside these functions. As it says there, it's available. We can assign that to 10, and it's also down here available, and we can assign that one to 20. And you'll see we have no compiler errors, but if we take this and put it inside our return details function, then you're going to get an exception because X is not available within that scope. And the functional scope matters inside here as well. If you have a string test inside here, we can't just access it in another function, for example the constructor. We can't just print out test as a screen. The handy things with classes, if you want variables to be available throughout the class, then you put them at the top. We can have that private string test, and there you go, you see that the compiler error is now gone. And we can give that initial value, and then you can use that to print to the screen, etc. And just a note, when you have a variable that's called exactly the same thing, we have a private string test up here, and we can say hello, and then we also have a string test down here. So let me demonstrate what happens when two variables are the same. So let's move this into our constructor. So if we run this as it is, test equals hello, and then we print out test, and then let's run the code. There you go, we get hello printed, and just ignore this, this is from the return details function. As we've got in the main down here, return details. So we've made our new constructor, and then assigned it the value of ABBA and 23, and then we can get hello printed to the screen. But let's say we actually made a string test inside here, and we said hi instead of hello. Then which one do you think gets used? The global one or the local one? Let's run it and find out. It's actually the local one. The compiler will always prioritize the local variables over the global variables, and this is the reason why you need to type this dot, because when you use name, it's always going to reference the parameter when it's name on its own. If you use console write line and say name, and then if we do after this line another console write line and we say this.name, then these are completely different. This one is the parameter, and this one is talking about the variables from the class, and these are known as our fields. Local variables take precedence over our fields, as long as they're called the same thing. As you can see now, it says it's assigned, but the value is never used. If you take the string test out, then you can see it's now being used. There you go, hello gets printed out to the screen, and there you go, the green line has went because we're using it down here. Scope is very important when you're designing these classes, and just to note that the variables that are available inside here are not going to be necessarily available inside here unless you make them public. And even when you make them public, that doesn't necessarily mean that this is still available magically over here. Name will only be available through an instance of the person class. So if we do person.name, now we can see that that's available as our field. So that's why that makes it public. If we try and make this private again just to return that value back, and we scroll down, you'll see now we get a compiler error because it's inaccessible, because it's outside the scope, because it's now a private variable. So we've covered what it means to have a public or a private field. If you have a private field, then you're going to have to use setters and getters in order to work with this field. If you make it directly public, then you won't need any setters and getters because the user can just type in .name after their public instance. So you can have person followed by the dot. And right now, you can't see name inside here, and the blue little icon is no longer there. And the reason why it's not there is because there's no public fields. If we then change this to public, remove the dot and re-add it, you'll see that our blue square is now back, because our field is now accessible, and we can assign that to anything that we want. The whole point of making this private is you only restrict the access so you know what you're doing. And the reason why I say that is, if they enter something that's invalid, then we want to specify something like invalid. If we give them public access, then we're not going to know and we won't be able to validate what they've entered. So in order to do it through a setter, we can make it private, create our set function with a return type. It's going to take in a string parameter, and this string has to be the same data type as the parameter you're talking about. Call it name or whatever you want it to be, and because these two are called exactly the same thing, we have to use this dot, so we're referencing this name instead of this name in the parameters. And here we're just using a conditional operator, and we're saying if the string is not null or empty, hence the exclamation point, then we assign it to name. Name gets put in this.name. And if this were to return back false, then we place invalid name straight into this.name. And for the get, we simply just return a string, since that's a data type for name, and then just return it back, and it's that simple. And the same thing for age. We validate the age range, set it, and if it's outside this range, we can set it to -1. So as you can see, this is a bit long. We have our private variables, and then we have two functions, one for set, one for get, and the same thing for age. So these are called fields and getters and setters. So I'm going to introduce a notion called properties, and properties make it easier to do this exact notation. So let's now see how a property is created. Since these fields are private, we need to make something that's actually public. So we can do something like this. We can say public string, and we can say name with a capital N. So now you can see that name and name are not actually clashing, and we can assign that in here should we want to. And you see we don't need this dot anymore because this is now different. It's a capital N, so this one always references this, and this references this. So we need to add something else onto here. So if you create them both, now you can see we can do age equals age, and there'll be no problems with this. So now that we've made our two new fields, so now we have our two new public variables which are known as our fields, let's see how we can turn them into properties. So if you remove the semicolon, you can actually add in some curly braces. So inside here, we need a getter and setter, just like we had down there, but we have a quicker notation for it. Instead of making two distinct functions, you can actually create a little section inside these curly braces to get and set the name. So you got to think of this as a middleman, the same way this is a middleman. We call this function, and this function will affect the name. And this is going to be the same principle. We make use of name with a capital N, but it will actually be affecting the lowercase n variable. These are going to be our new middlemans, and they will directly replace the getters and setters here. So what we can do in here is we can say get, press enter, go on the next line and make some curly braces. And then we can also have a set. So this is like our mini get and mini set function, just like we've got here, but as you can see it's a lot shorter. We don't need to give it a distinct name or set the public or anything else, we just give it a simple set and get. So if you have a look at the compiler error, it says not all call paths return a value, because as it says here, this get function is actually a mini function built into this property. Person.name, which is our name with a capital N, and then it's .get, and this returns back a string. So if we actually just type in return this, then it gets rid of the compiler error. But of course we don't want to return nothing, we actually want to return name. Because remember what I said, string name and int age up here as our private fields, they actually store the data. The public string name and the public int age is the middlemans that coordinates all of the getters and setters to do with the private variables. So for the set, just for now we can say name equals, and then what do we give it the value of? So if we hover over set, it doesn't actually give you any indication of what it's going to be. So let's have a look. If we press Control space, then we don't also get the list of everything that we can add inside here. Now it's very difficult to understand what to assign this to. When we have set name, we've given it a string name parameter, so we can use name down here. So what's our parameter in this case? Well, the function itself doesn't actually tell us, but I'm telling you right now that the parameter is actually just called value. And this is a very default parameter that you'll see everywhere when you're doing getters and setters inside a property. You don't have to specify value or anything, it just gets simply assigned in. Just like here, where we have string name, this will be a string value. So it will look something like this behind the scenes, but of course you can't actually type this in. Because remember, these properties are trying to give you a shorthand on how to do getters and setters. So you just got to remember that when you're trying to set, you get the property inserted as value so you can store that into name. So that's it, the name is actually sorted now. So before we do the same thing for age, let's see how we can use this inside the code. So we scroll down to our main, we have a person, and then we have a console write line that prints the details. So we can actually do person dot, and you can see now that it's slightly different. If you ignore the age, since that's returning back as a field since we haven't done that yet, you'll see that name now has a little cog next to it. Show only properties. This is a new icon that we haven't saw yet, so this is our new icon. It says it's going to return us back with a string, and we can actually execute a get and execute a set straight on this name. Then we can say name equals Harry, and we don't get any compiler errors whatsoever. This lets us do it completely. So now if we do another console write line and we say person.return details, and let's run that, and you should see that the name gets changed. There we go, Abba gets changed to Harry. Perfect. So after we've got person.name, let's see how we can also get the value. So we can just say string interpolation, your name is, and then we do person, and followed by a dot. And as you can see, the exact same list that we got given over here is given right here as well. Name also says get and set, and it returns back a property, which is a string type. So we can open it like this, and you'll notice that we don't have the parentheses after it. And the reason for that is because the brackets indicate that you're calling a function, but a property is just a property. It's almost like a variable. So you're not actually needing to put any brackets after it because there's no function to call. So as you can see, this is exactly the same as this. In this case, we're actually setting the value, and in this case, we're actually getting the value. So let's comment this line out, and let's see what happens. Your name is Harry. So that's worked okay. So now let's do the same thing for age. Remove the semicolon, add the curly brace, we can say get, and then return age, and then simply do set, and then do age equals value. There we go. So now we've got that set up. If we return back down here and we see person dot, so as you can see now, the age is being removed as being a field, as we saw in the blue icon. It's now been turned into a spanner, which means it's a property. As shown here, show only properties. So now you can see it returns back an integer, and we've got a get and a set. So we can set that to 25, for example, and then we can append onto here, and your age is person.age. You can see that it's a capital A, just as this one is a capital N, and now we have get and set available, and again, we don't need the brackets inside here, since this is a property, not a function. Now let's run it. We should see Harry 25. There you go, your name is Harry and your age is 25. Perfect. So as you can see now is, instead of having our set name and get name, which are these two functions, we actually have them contained within a property. We call this property and it affects these variables, but as you can see, just as these functions below were a middleman, we've now moved the middleman into these properties. So, as these are only one line, you're probably thinking, there's probably a better way of doing this, and it's a lot quicker for syntax. And you're right, there is. So let's explore that. So I said before about arrow functions. When you're doing something like this getName, you can have public, string, getName, and then you can simply do arrow name. And this is a very common string function. GetName that just returns back a value, and you can make that into an arrow function by literally just putting back name. So we can actually do the same thing, but for our properties. So these both contain one line. So we can actually minimize this, and if we just block comment this out, we can say public, string, name, and then we can have get, and then the same thing with the arrow function. When we're doing the arrow function down here, you would simply won't use the return keyword, you would just type in the variable you want to return. So we can say get, arrow, and then simply lowercase name, and then add a semicolon, just so you know that that section is ended, and then straight after it we can have set, and then arrow, and then name equals value. Just like that. So as you can see, these contents are exactly the same, but you've actually returned them back in a shorter space. And of course here, as we've got a compiler error, it just expects a semicolon to be right at the end here. There you go. And now we do the same thing for our age. We can do public, int age, get arrow age, and set arrow age equals value. Perfect. So now you can see that this has been drastically reduced. If I cut this just underneath, you'll see that almost all of these lines are just replaced in a 2. And you'll see that our functionality will still work exactly the same if we just run the code. Harry and 25 is being reassigned over our default variables. Perfect. Of course, now if you want to add some more functionality inside here, for example, in our set name, we had a little check that makes sure that it's a valid name before we assign it. So we actually take this and paste it over here, then you see the lines grown quite a lot. So what's best to do is, if you're going to have any data inside here that does a little bit of logic, then it's best to keep the curly braces since you can have a bigger output and it looks a bit more sensible. If you're just simply getting and you're setting the variables, then you can leave this notation. So let's undo this and bring back the original ones in this case. There we go. And then we can take that line and in the set, we can actually replace it here. So as you can see, this is a little bit grayed out. So let's put the semicolon at the end and let's see why this is grayed out. Name can be simplified. So what we're doing now is name and all of these variables are actually looking at the private variable. Whereas if you actually look down here and we uncomment this, you'll see that set name, if we double click on this one, this is the only reference to it. which is our private variable up here. And the reason why this doesn't need to be used in this case is because our parameter is now called value. So it's saying the name is equal to, checking if the value is null or empty, assigning the value into name if not, and then if it is empty, then we assign invalid straight into name. In the case of our set name, our name was our parameter. The same goes here. If we change this to value, we can change these two for value. As you can see, now this dot is actually grayed out and it can be simplified to just simply name. And the same principle applies above. So let's comment these back out and scroll back to the top. So now that we've assigned name, there we go. We've got our check inside there, and you can also leave this in one line if you want. You can even drop the curly brace in just so it looks like this, instead of having it all in one line. So you could do this, and this would be applicable as well. But the second you start to put it all in one line, then it gets a little bit messy quickly. So if you leave the outer bracket just like that, then it can be pretty short since you don't need more curly braces. So now that we've done that for the name, let's do it for the age as well. So we had this.age, we check the range and we assign the relevant values. So let's take that, paste it over this. We don't need this dot anymore, and age in this case is actually going to be the value that gets passed in. So replace all the ages with value. There we go. So if the value passes the range check, we put the value inside age, or not, we can put -1 inside age. And again, we can have the same thing. We can use our arrows inside here. There we go. So now we've got our code drastically reduced. So we went from these big functions that have to be defined with specific names over to our properties, and they went from really small to just a little bit bigger, but now they have advanced connections just to make sure that the variables are okay before you assign it in. So now that we've got our properties, let's have a look. So inside our constructor, we don't also need to use our local variables, which is our private ones directly. We should actually get rid of this now, and we should always do everything through our properties. Name equals name, and because this is a capital and this is a lowercase, we don't need this dot in there. There we go. So what you should do in the return details function is also use the capital N and the capital Age. So when you hover over these, you're actually referring to the property. Because like I said before, these are the middleman to communicate with the private variables. You shouldn't need to access the private variables directly, you should use the middleman as much as possible. So now that we've done that, I have one last thing to introduce. So if you actually abandon all of this code just to keep it for reference, we have something called an auto property. And you briefly saw it when we saw it down here. So if you actually just bring them back for a second, and if you hover over name down here, it says string, name, get and set in the curly brace. But you see how the get and set is empty, it just has two values inside there, and it just ends a curly brace with no actual logic. You see in our get, we're saying age, and our set, we're saying age equals this. So when we're doing auto properties, what you can do is you can actually make these public again. Change these to a capital N, change this to a capital A, and just straight after it, you can say get, set, just like that. And what that will do is, although they're actually made public, what it's doing behind the scenes is actually doing this for you. It actually has a private and a public for you behind the scenes. This is just a shorthand. These are what's called a auto property. What it does is it makes an anonymous property behind the scenes, as I'll show you in Microsoft documentation right now. As it says here, in C# 3 or later, auto-implemented properties make property declaration more concise when no additional logic is required. And what that means is, no additional logic, all of these are additional logic. If you're just simply assigning a value and reading it back just like here, then this is no need to write get name and set name if all you're doing is getting and setting it. If you're getting and setting it but there is a certain amount of logic, as we have here, we essentially have a conditional operator that's making a subconscious decision about what to assign the name to. But if you're just simply assigning something like this, then an auto property is perfect. They also enable client code to create objects. When you declare a property as shown in the following example, the compiler creates a private, anonymous backing field that can only be accessed through the properties get and setters. As you can see here, just like in our example, we have public int something and then get and set. and then they have a public int something with the get and set as well, and they can use it just here to access it directly. And because they're simply just assigning and getting the values and there isn't any additional logic, then this is the best way to do it, and you get, as it says here, an anonymous private backing field. So this would be the same thing as doing this. Private string name and private int age. So once you do that, and you make this into the get and set properties, which are these two right here, this and this line together make a property. What the auto implemented property does is actually combine this line and this line together and make the private one behind the scenes so the programmer doesn't see it, but it will be applicable when the program runs in the compiler, and then you only get publicly exposed with this parameter, which will be our name property. So it will actually make the private for you if you just keep it like we had it a second ago. Just like this. So if you leave it like this, it will actually create the private variable behind the scenes, as it says here, it's anonymous backing field. And it can only be accessed through name and age. And as you can see, none of our code has actually changed. All of these still function okay, and if we run the code, we should still get Harry and 25. So just to sum this video up, since there was a lot covered, the bottom line is, if you're going to have any sort of values that require any logic, then you should use normal properties. If you're simply just going to assign and get the value, and it doesn't matter and you have no control over it, then you can use the auto implemented properties, since that will do the same thing with less code. Using the getters and setters is the old way of doing this, and you should always use the properties going forward. Getters and setters are very helpful to know, just so you understand what they are and why they exist, but you should note that properties are the best way forward. Properties give you access to doing the same logic as it says inside here. If you're doing auto implemented properties, then you're not allowed to use the logic inside the set or the get. So if you don't want to do any logic, then don't use the auto implemented properties, only use the normal properties. To make a getter and setter, you just do set name, get the parameter and assign the local variable, and the get just returns it. Getting back a property, you want to capitalize your private variable. If you had private string name with a lowercase n, you want public string name with a capital N. You get the name, and then you can set the name with some sort of conditional operator or any if statement or anything inside here. And the same thing goes with the age. You can have a public int age with a capital A and a private int age with a lowercase a. You can get the age and then set the age with a conditional operator again or any other code. If you don't require any logic like these two lines indicate, then you can simply just use the auto properties as demonstrated above here, and they can be used quite easily throughout the constructor and our functions, and even outside the function when the user is trying to call them. But one thing that we haven't been able to solve, and you may not have noticed this as a nuisance, the problem is when you're trying to return details about something, we're having to call this function every single time. If we have an int age, for example, and made that equal to 23, and we did console writeline and simply placed age inside the brackets, we don't have to do anything like this, because it simply just prints the value out. If we run the code, you'll see that it simply just says 23. This should be pretty simple for our person as well, but it's not. We need to call return details every single time we want to print the properties. And if we don't do this, the only way to do it is by making some string interpolation, and we can say person.name, and then also include person.age, etc., and then that can print out to the screen just like that. Of course, it doesn't have the same formatting, but we can also just take this, place it straight inside here, add our person dot before them, person dot, and there you go. Then you get exactly the same output as call and return details. But of course, you don't want to do this every time, and you certainly don't want to have to type in return details function every single time as well. You want to keep it as just person. Now, of course, this is not going to work straight out of the box. Let's try run that and see what happens. So we get string override dot person. And what's going on here is it's saying namespace is string override, and then it's a class person. So it's just printing out this person object, but it's not really doing anything because we haven't really told it to do something. So what we can do here is we can actually override the toString method. So let me explain. So let me set up a couple of examples just to show you what's going to happen at the end. So right now we call return details to return these details. What we can also do is say .toString, and then we can also do these three options. Return the details, convert it to a string, or just print the person straight to the console. At the end of this little section, we're going to make all three of these print out the same values. So let's have a look now. ToString and printing out normally, these two lines right here are actually doing exactly the same thing. Behind the scenes, when you place anything inside these brackets inside a console write line, it will try and convert it to string anyway, so whether you put ToString or you leave it as person, the console write line function will still accept it. So let's just comment out the age for the time being. In order to make the ToString function work, as well as just pasting person inside the brackets, we need to make a special function, which is an override function. So let's have a look. So just underneath our return details, still within the scope of the class, we'd say public, and then override. After we press tab, we can follow it by a space, and we can see the functions that we can override. So in this video, we're actually going to cover ToString and .equals. Get hash code will actually serve as the default hash function. If I show you the documentation, it says here, a hash code is a numeric value that is used to insert and identify an object in a hash-based collection. This is normally used when you're doing hash functions, as it says here, and for the time being, we're not actually going to be using this right now. So the two we can do are ToString and equals. But as you can see, our ToString is available right now. We'll cover equals as an extension in a minute. So let's double click on our ToString and we get this little template placed in. If you don't want the template, then it's just an override. It returns back a string since it's converting it to string. It needs to be this exact notation. If you drop the T, then it's got nothing to override. There you go, we get a compiler error because there's nothing to override itself. So we place ToString in the capitals, there's no parameters passed in, and then we're going to be returning something. So the thing that we're going to be returning is exactly the same as our return details function. We actually have two options here. We could say return and then return details. So what that will do is it'll go to this function, it will call this function, grab that and essentially place it inside here and then return it back to the console. In the ideal world, we don't actually need this return details function. So we could comment it out, but I'm going to leave it in just so the demonstration doesn't break down here. So we can take this and place it straight inside here. Now we have two functions that essentially do the same thing. But the advantage is, this function is something that needs to be called explicitly, .return details. Whereas this function, the ToString override, actually just gets called naturally without having to add any extensions. So if we run the code now, you'll see that now they all equal exactly the same value. We get three sections that have this. Maybe we can place \t instead, just so we can have them all on the same line. There we go. So you can see all three are exactly the same. So what we can do now is if we comment this option, and we comment out this function, we don't have to include ToString if we don't want to, we can also comment this one out, and we can keep it just as person. So as we do when we declare the integer, we say int age equals 23, and then we simply print it out. And this is exactly the notation that we want. It should really be this simple. There you go. One line creates the person, and one line with just a variable name goes inside the brackets to print them out. The same thing here. Person, age, and age. And let's run that code now, and there you go. You get the person printed and the age printed exactly and straightforward as you may think it should be. So now that we've done that, let's explore what the equals function needs to be done. Let's make another person. We can say person test equals new person, and we can have Harry, age 23. Now we don't need to print them out in this example, we just need to demonstrate this equals function. So if you remember with strings, we can have a string called ABBA for example, and we can say .equals straight after it. And we can say if ABBA is equal to Harry, then we can do something inside here. What I'm trying to demonstrate is once you've got an object, you can place .equals and then you can compare it like that. So you can also do that with our classes. So we can say person .equals and then equals to test. And in here we could just say same. And let's try and make these as same as possible and see what happens. So let's keep the name exactly the same, just like that, and let's copy the 25 down just like that. So now these two are instantiated exactly the same way. Let's see what happens when we run the equals. Then we don't get anything printed, which means they're not the same. So because this doesn't automatically tell us that these two are exactly the same, we can override that and provide our own functionality, just like we did with the operator overload. We override equals, we get passed in an object, and we need to check something inside it. So let's see what we can do inside here. So in order to check if something is equal to another thing, what can we do? So we have a name and an age. If this one is the same as this, and this is the same as this, then two people are exactly the same. So let's try that out and see what happens. So we can say name, which is the property inside the class that we're currently inside, and then we can use .equals because this is just a string parameter, and then we can say that equals to object.name. But you can see we've got a little problem here. this object is very generic. It's just an object. Every class that you create is derived by an object. What that means is every class or integer or double at the end of the day is also just known as an object through inheritance, which we'll discuss further on in this course. But just know that everything inside C# is always an object somewhere down the line. So what that means is we have to convert it from an object to our custom class, which is person in this case. So we can use this thing called casting. So we can say person, which is just defining a new variable, and we can make that immediately equal to object as person. So what we've done here is we've said our object, which is this parameter, is currently an object right now. We want to cast it as a person, which is kind of like converting it into a person and then placing the values inside here. So now if we get rid of this comment, and instead of using object, we actually have a new local variable called person. So then here we can say person.name. There we go. Now we have access to the person property since we've converted this object into a person. And of course we know that we have name and age available. So if the name is equal to the person.name and the age is equal to the person.age, then we must have a match. And of course we want to keep using the properties, so we're going to use a capital A. And there we go. So we run the conversion on one line and then we check if they're equal to each other. Now in this specific case, you can actually pass anything inside here. So let's try it. We can pass 5 inside here, and as you can see, there's no compiler error, because like I said, 5 is just an integer, which is an object at the end of the day. If we make it a double, that works as well. There is literally no compiler errors. And even if you put m to make it into a decimal, again, there's no compiler errors because they're all objects at the end of the day. So let's pass test in there. What you will have to note is, if you do accidentally pass in a double, for example, like this, you're going to hit an error here, which will be a runtime error. It will try and convert it as soon as it hits this line, and obviously you can't convert a double into our person. So what you could do, just to wrap it around, you could say, if the object is a person, then we can proceed with the conversion, just like this. And then what you can do for safety is just outside of this, you can actually just return back false, just so the user knows that this isn't equal to each other. So if the object is a person, then we convert it as a person. Is used for checking, and as is used for converting. Is this object a person? And if it is, then we try and convert it and then return back if they're equal to each other. And if we accidentally pass something in that's not a person, then we just return back false. So let's just demonstrate this first. Not the same. So let's just say a 5 inside here. It says not the same. So let's actually go into this, place a breakpoint, and let's run it again. Hover over object, then we get 5. If we place this straight inside the watch, you can see object is person is returning back false, so it's skipping this entire function and going into return false, and then it's returning back false, so we get not same. Let's stop the program, change this over to test, and rerun it using F5, and now we can see object is person is actually set to true. So now if we put the object inside here, you can see that generically it's an object. Right here it says object. So what we can do now is we can place person and down here as well. And you see that person doesn't exist, but if you just give it a second and we change this to just the P, there we go. So obviously the person doesn't exist because we're only up to this line. We press F10 and F10 again. So now it's created the variable, and F10 once to skip over it. And now you can see the object has went from type object to type string.override.person. String override is the name of our namespace, and .person with a capital P is the name of our class. Now you can see that the object and the values are exactly the same, 25 ABBA and 25 ABBA, as you can see right here. So now both of them are exactly equal to each other. So when we check this, name here is ABBA, name here is ABBA, age is 25, and age is 25. So this must return back true, and we can check that by highlighting everything, dragging and dropping it down here, and we can see it says true there. So when it returns back to our code, it's going to go and print there same. Perfect. There you go. So that's it for this video, but let's just have a recap before we wrap up. So before this video, we'd always print the details out like this, person.return details, but obviously we don't have that function anymore, so let's just bring it back quickly. There we go. So we use return details, and this is just a bit long having to do this every single time. If you want to print the details of the test object as well, you have to do test dot and then return details again. It'd be so much easier if we could simply just use it like this. as you would do with a normal variable like an integer, double, a string, etc. And now it's made possible by using our public override string ToString function. It will contain exactly the same contents as our previous function, except we won't have to go through an additional function just to print out the details. We can override the ToString, and then we can call it straight in the console like this. And finally, when you're doing .equals inside an object, you can actually build in some custom functionality. We can convert the person using object as person, but first, before doing the conversion, you want to check if the object is indeed a person type before doing the conversion. This will give you a runtime error on this line. So let me just demonstrate that before we continue. So if I comment out this one and actually just change this into 5D, and then let's press into the code right here. It's going to hit this line if I press F10, then it's going to try and convert it, but you're going to get back null. And then if you run the code again, then you're going to get exception thrown here. You're going to get a runtime exception because it's a null reference. We're trying to run the equals function on something that is null, which is right here, null reference exception. So you shouldn't do this. You should also make sure that these are correct values before doing it. This is a form of error checking. If you don't do this, then you're going to have to wrap this inside a try catch, and it will look something like this, and the code will be considerably longer. You can place these two lines inside here, and then place your catch inside here, etc, etc, and you can return false inside here. But as you can see, the code is a bit more complicated now, and there's no reason for this extra complication if you can prevent it with an if statement. So let's undo that. So what's best in this case is to say if the object is of type person, then we can run the conversion. If we run the conversion and it's not of type person, then as you can see, it's going to return back null for the person, and then when you run this line, it's actually going to return you back a null reference exception at this point. But anyway, the whole point of this equals is to check if two objects are going to be equal to each other. So if we keep this back to test, because this is a custom classes, you can't just simply do person equals equals test and assume that that will just work. These aren't built-in functionalities for custom classes. We covered operator overloading, where you can actually override what you do with the equal sign, but we didn't cover the dot equals, which is what we're doing today in this video, as well as the ToString. This is a different kind of overriding because in the other one, when we're doing operator overloading, that's specifically an operator that you're just changing the parameters of, whereas this one is a strict override of a function equals and the function's ToString. This will make it easier to print your custom classes out to the screen, as well as comparing them just like this. Person.equals, putting test inside the brackets, is a lot easier and quicker, and you can build in your own custom functionality. If you only had the age in there, then you can compare the age, maybe have a lot more properties, and you can always just chain them inside a big if statement. That's fine as well, but the point is you have full control over how you compare your custom classes. Maybe you had a list of names inside a dictionary, for example, and you wanted to add a new name, or a new age, or a new user to this dictionary. But first, before you add a new user to the dictionary, you want to check if the user already exists. So maybe you could have a system where it uses the equals function and it loops through all of the dictionary items and it checks if all the values are not equal to this one. If you didn't build in this functionality so you could do the dot equals function, then you won't be able to determine if this one is equal to this one. And now with your equals function overrided, you can now have the functionality to do so. Thank you for watching this C# course. I hope you found it helpful in your journey to becoming a proficient C# developer. If you have any questions or need further clarification on any topic we have covered, please don't hesitate to leave a comment below and I will do my best to assist you. For those of you who want to dive deeper into C#, consider checking out my Udemy course. You'll find more comprehensive lessons and hands-on exercises to enhance your skills. Remember, practice makes perfect. Keep coding and exploring, and I wish you all the best on your programming journey.